Good morning, sir.
Morning, good morning. Good morning to all.
Good morning to all, sir. A very good morning to all of you. After the completion of first day, we are moving ahead for the second day of the international conference on advanced material science and nanotechnology. Today we have five technical sessions, which is first is delivered by the Mahavir Singh from the former Vice Chancellor of IC University and Himachal Pradesh University, SP Himachal Pradesh. Second one is by the Dr. Pankaj Koinkar, is from Japan, Tokushima University, Japan. And third one is delivered by the Dr. Harshad Jadhav, who is from the South Korea. And then Sandeep Wagule, Dr. Sandeep Wagule is from Department of Physics, Sant Gadgiawa University, Amravati. And last one is from Dr. Prasanta Kumar Ghosh. He is from MIT Pune, Vishwa Shanti University, Pune. Now we will move further and start our sessions. Today's technical session was chaired by the Dr. N.G. Belsere. He was a former principal of Bizdal Biani Science College, Amravati. And first session will be delivered by the Dr. Professor Mahavir Singh. Professor Mahavir Singh is presently working as in the Department of Physics, Himachal Pradesh University, and he was former Vice Chancellor of IC University. He has completed his PhD from Indian Institute of Technology, Delhi, and he was also visiting at several foreign universities as UK, and several other countries. Now I request to Professor Mahavir Singh sir to deliver his talk. Welcome, sir.
Welcome, sir. So, good morning to everybody. First of all, my sincere thanks to organizer of this NANOMAT 2020, especially Dr. Prashant. For giving me the opportunity to interact with the international conference on nanomaterial and nanotechnology. So title of my talk is Role of Size, Shape and Surface Control of Magnetic Nanoparticle for Health Communication data storage and water purification sector. Dear delegates, dear participants, as you know, we are passing with difficult phase globally because of COVID-19. Every day we find new kinds of situation where we find that coronavirus is changing every day, its structure, its shape, and its surface morphology. That is why I have chosen this topic because it is highly important when we talk about the nanomaterial or nanotechnology. At nano level, shape, size, and surface is very, very important wherever you want to use, whether it is in health sector, as we know that so many universities, so many companies are working closely on vaccine or drugs. So where they are controlling the shape, size, and surface morphology of the particular drug which they are working. So I am talking on magnetic nanoparticle, where the role of these three important heads is very, very important, especially in health sector as well as in other secondary sectors. So current issue in nanotechnology, as we know, it is the toxicity. When we talk about nanomaterial, toxicity is the major issue. Nanomaterial can become toxic, but the positive part of magnetic nanoparticle is their toxicity is minimal. There is minimal toxicity in magnetic nanoparticle. Then the second issue is electromagnetic radiation. As we know, radiation is the major concern globally. And then clean water as well as air. As we find that in India, there is a lot of issue, especially about drinking water, how we can achieve drinkable water as well as air quality. Then health sector is also important, where a lot of latest technology which is based upon nanotechnology in health sector is important. Then data storage is also the another area, and communication, especially in the ultra high frequency region, that is in gigahertz region, is important. So as I mentioned, in nanotechnology there are various issues, especially toxicity, pollution. Nanomaterial can cause pollution. They can be non-biodegradable, they can be unstable, but the positive part of magnetic nanotechnology is that they are pollution-free, their toxicity is minimal, they are mostly non-toxic, they are biodegradable, they are stable, as well as cost-wise, magnetic nanoparticles are less as compared to other counterparts, whether it is metallurgy or semiconductor or any other materials. And moreover, magnetic nanoparticles are eco-friendly, biocompatible, and non-toxic. So as we know that nanotechnology is not today's discovery. It was when this universe was built up, when Earth was formed. So as we know that the skin of fish is also full of magnetic nanoparticle. The skin of fish is iron-based nanoparticle having particle size roughly 50 nanometer. So basically, that is why for navigation purposes, fish use this magnetic nanotechnology for navigation purpose. As we know in modern technology, aircraft use magnetic nanoparticle for navigation purposes. So as I mentioned, these three effects, that is quantum size effect, large surface area of magnetic nanoparticle. These two important properties are the unique when we talk about the magnetic nanoparticle. So basically quantum size effect and large surface to volume ratio is important, and they are unique, especially for magnetic nanoparticle. So I'm talking about these four areas. One is health, another is communication, another is storage, another is environment. And I think, in my opinion, these four sectors are very, very important, and they are directly linked with society. you can even correlate it within the modern time. That is, we are passing with COVID-19. So here I think these four sectors are very, very important. The understanding of these four sectors. So for health sector, what is important for health sector? We have to achieve one important property in physics that is called super paramagnetic. So we have to achieve the SPM if we want to use this for hyperthermia for treatment of cancer, targeted drug delivery, or implant infection, or increasing tissue growth, etc. Then communication, we want to use these magnetic nanoparticles, especially for gigahertz range, for defense purposes in radar sector, mobile network for different technological level. Then storage sector, we that is quantum storage sector, especially saturation magnetization is very, very important parameter for controlling the storage sector. Then environment, this is also very important area, that is air, purification of air, purification of water, and purification of soil. So for that, these three, porosity play the important role. Porosity play the important role of magnetic nanoparticle. Through porosity, we can control the air quality, we can control the water quality, and we can control the soil. So these are the parameters, and I think we all know right from high school, high cruise level education, schooling education, these parameter, that is initial permeability, saturation magnetization, porosity, then electric and magnetic medium, where we talk about as in +2 level permittivity and permeability. But these parameters are very, very important when we talk about the designing of any kind of antenna. Then we have loss tangent. Loss is also important concern, whether it is electric loss or whether it is magnetic loss. Then resistivity, anisotropy constant, and dielectric constant. All these parameters are shape, surface, and size dependent. So magnetic system is of two kinds. One is soft magnetic system, and other is hard magnetic system. So in soft magnetic system, as we know that bulk magnetic system is formed due to formation of domains. So domain is responsible for the formation of bulk system. So, when domains are formed, so there is when we talk about the nanoparticle, when we goes from bulk level to nano level, so there is decrease in size. So decrease in size means we change, physics is drastically changed from multi-domain to single domain, then single domain to spin glass transition, then there is a crucial stage which is unique in itself, that is SPM, super paramagnetic state. So as you can, it is clearly visible here that there are two boundaries. So this is multi-domain, this is formation of domain, then this is single domain. Between multi-domain and single domain, there is one boundary, and between single domain and SPS, there is another boundary. So this boundary, that is anisotropy energy and thermal energy, when they are equilibrium with each other, so that is the clear boundary. If this anisotropy is more prominent, more greater than the thermal energy, then we can achieve the super paramagnetic. So if we want to use magnetic nanoparticle in health sector, it has to be SPM for any kinds of application. Then this is multi-domain, this is single domain, this is single domain, and this is super paramagnetic. So basically, every magnetic material, if you want to use from ordinary magnetic material to nanomagnetic material, we have to change its radius from multi-domain to this single domain, then further reduce the nanoparticle radius, then that is as super paramagnetic state. So this is super paramagnetic state. This is hysteresis, as we know from +2 level. This is hard hysteresis group. Then this we decrease. This is soft hysteresis group. Then this red is super paramagnetic state, which can be achieved. But remember, this is unique, very, very sensitive state which exists at nano level. So then, as we first property was the This size. Then second is surface. So if we reduce the particle size, so at nano level, 60% of total number of spins are surface spins. So 60% lie on the surface. As I mentioned, surface to volume ratio is very, very large when we talk about the magnetic nanoparticle. So surface anisotropy and for surface exchange anisotropy, they play the very, very important role. I'm not discussing that is a specific issue which we talk about, especially at 5 nanometer particle size level. These two properties play the crucial role. So third is the shape effect. So accordingly, through controlling the shape of the nanoparticle, we can control the permeability, we can control the dielectric constant, we can control the resistivity, etc. for designing the particular application of this nanoparticle. So this is bulk magnetic nanoparticle, this is bulk particle magnetic system, and this is magnetic nanoparticle. So as we see on this side, it has 6-line peak. 6-line peak means there is hyperfine interaction, but on the left side there is relaxed kind of interaction. So at nano level, how we can retain the hyperfine interaction, that is also challengeable. So we can achieve that by changing the temperature or by adding the dopant. So we can achieve this kind of arrangement even at nano level. But that is a further, we can control the hyperfine interaction by changing the various either nature of dopant or temperature. Then this is the SPM. As I mentioned, SPM is the prerequisite requirement if we want to use for health kind of application. So this is the SPM of gold iron core shell nanoparticle, and this is the SPM. Previous one was Mosvor, and this was squid data. So dear delegates, these are two important points. For magnetization, if we want to observe magnetization at nano level, we need either squid or we need VSM. And if we want to authenticate, we want to verify the squid data, the only technique is Mosvor. So through Mosvor, we can verify. And in our study, Mosvor spectroscopy is also clearly indicating the SPM, and VSM, this squid data is also clearly indicating the SPM, and we have used this for hyperthermia technique. I will show at the end. We have used for the treatment of cancer iron-based nanoparticle. Then this is again SPM. This is Mosvor data. We have fabricated this by this hydrothermal technique. This is the methodology by thermal decomposition method. One is in the presence of vacuum and other in the presence of argon. This is XRD. I'm not going. This is the spinel phase clearly. Shape morphology. Shape is controlled. Spherical shape. There is no agglomeration. That is prerequisite as we want to use this for health sector. So there should not be no agglomeration, and they are controlled. Their morphology is controlled, and all the particles are spherical. Then this is squid data, and we have also applied some theoretical calculation also for AC susceptibility measurement. And this is the as I mentioned, gold iron nanoparticle, again TEM and squid data. Then Mosvor data, as I mentioned, this is SPM. We can enhance the hyperfine interaction by either changing the dopant nature or by changing the temperature. This is perfect SPM, no corrosivity at all. This is perfect SPM for especially for the treatment of cancer. And these are the following rules for the fabrication of nanoparticle: wet chemical method, microemulsion, thermal decomposition, solid state deposition, spray pyrolysis, lithography technique. Dear friends, I have fabricated these nanoparticles by all the techniques. My experience is this microemulsion and lithography techniques are the latest technique through which we can fabricate the excellent quality of nanoparticle. This is the microemulsion, one technique which I'm showing. I have fabricated through this microemulsion technique. So if you need any kinds of help, if you are interested to fabricate these nanoparticles by this microemulsion, so I can provide all the related, literature towards how we can fabricate through this technique. So I can provide all possible help through this technique. And this is the surface morphology. So particle size are in controlled way. So there is no agglomeration at all. Then we go through the different change in the particle size. So on this side, left side, there is hyperfine interaction, relax kind. This is SPM. This is again SPM. So this is, so basically there is boundary, as I mentioned. This is collective magnetic excitation, and this is single particles. This is SPM. This is basically this is the boundary. This is boundary between collective magnetic excitation and SPM. So there is interesting physics, and I have also this distribution function. So clearly there is matching between theoretical and experimental data. Again, this is distribution function. So this is for the different kinds of Mossberg spectroscopy of different size. So clearly this red is for bulk, and this black is for nanoparticle. So there is broadening, as clearly visible in black. There is broadening. Broadening is because of surface disorder. So X-ray, in X-ray, if we observe the X-ray of nanoparticle and bulk, so bulk has a sharp X-ray beam, nanoparticle has broad X-ray beam. Same is the case here in this Mossberg distribution function also. Sharp is for bulk particle and broad is for nanoparticle. So broadening means there is some kind of surface disorder or surface strain, and lot of physics is interesting there to understand this surface frustration or spin glass transition, as I mentioned. So again, this is Mossberg, and I want to mention one thing here. I'm not going detail on this, but I want to mention one thing. Our group is the first in the world who calculate the surface disorder. Who calculate this surface disorder? Surface disorder means how much percentage of spins are at the surface. So our group is the first in the world who calculated the surface disorder in the magnetic nanoparticle by using Mossberg spectroscopy and by using squid data. This is squid data. We have fitted this, and we also try to fit the Langevin function also, and we also try to understand the spin glass transition by Vogel-Fulcher law. So it was very well fitted. So then second application, as I mentioned, major challenge in communication is use of nano antenna. This is the future challenge in communication, to use in gigahertz. So if we want to use in gigahertz, so magnetic loss is the major concern. Real part we can control, but how we can control the magnetic loss, that is real challenge. Then, as I mentioned, this permittivity and permeability, we can control this electric and magnetic loss. So these are the Maxwell equation. Through these equations, we can understand, and they are very useful when we design the nano antenna. So this is the different region of frequency range or wavelength range for the use of antenna. So this is the kind of waveguide or the resonator which we can design. So we calculate this permeability tensor. So for designing any kind of antenna, we calculate this permeability tensor, and through this permeability tensor, we can design various kinds of radar or antenna or resonator or waveguide. So this is the this is frequency, and this is the real part of permittivity. So we have controlled permittivity, but really permeability, still we are struggling. Permittivity we are controlled. These are excellent results, but permeability still we are struggling, especially in the gigahertz range. real part is okay, but imaginary part still we are struggling. There is lot of loss emerging at a high frequency region. So as I mentioned, if we want to use any kind of nano antenna at gigahertz range, then our permittivity and permeability, real part should be greater than 2, which we have achieved. Imaginary part should be close to 0. Electric we have achieved the close to 0, but magnetic loss still we are struggling at high frequency region. So then, as I mentioned, environment issue. So magnetic nanoparticle for environment purpose such as contaminant removal, remediation and waste treatment, we can use iron nanoparticle for all the for environmental pollution control. As I mentioned, if we design these magnetic nanoparticle, iron-based nanoparticle, so by controlling the corrosivity, we can use for the purification of air, so purification of water and purification of soil. So one is in the agriculture sector, other is in the water sector, and other is in the environment sector. We have used this kind of study in Manali also for the aerosol purposes. So where we have studied the kind of magnetic nanoparticle, how we can use these magnetic nanoparticle for purification of air. Then, as I mentioned, more than this is great concern. More than 90% of world water reserves are salt water. So it is fresh water is only 2.8%. If fresh water is contaminated, this is lot of concern, and this is future research also. So I invite all young researchers. You can also find your interest to study in the health sector, in the water treatment sector, as we know that it is only 2.8% fresh water. So how fresh water can be retained its purity, its minerals? So we have to design nanofilter. Through nanofilter, we can purify, especially bacteria. I want to mention one thing here. 6-7 years in Shimla, there was lot of problem, even waterborne disease, where there was a mixing of bacteria in water. So through magnetic nanoparticle, bacteria can be removed and water can be treated for the treatment for the in fresh water form. And this is the magnetic nanoparticle for water purification. So this is the basically the role of this magnetic nanoparticle is important here. Bacteria removal is the major concern. Other organic material or metal ion material we can purify, but this bacteria removal can be important when we use these magnetic nanoparticles. Second is the data storage issue. So unique chance to control corrosivity in magnetic nanoparticle led to number of significant technological application. So data storage is also another concern, especially 100 gigabit per inch square up to 2 terabit inch, particularly in the field of information storage. So small magnetic nanoparticles are promising candidate for further increase in density of magnetic storage devices. So this is future physics about magnetism, that is dynamic spin fluctuation, spin reversal, increasing spin structure of nanoparticle, core versus surface contribution. So this is also future, core versus surface. Core is iron and surface is gold. As I mentioned, iron gold nanoparticle. Then graphene polymer coated nanoparticle. This is also future. Dear friends, dear delegates, future in magnetic nanotechnology for 50 years will be at the center. It will be magnetic nanoparticle. Then it will be coated with some suitable polymer. Then it will be further coated with graphene. So it is basically material and outer shell of coated material of polymer and graphene. This is the future. And the future is dimension eco-friendly, biodegrade compatible. So chitosan is the polymer, excellent biocompatible and biodegradable polymer with high content of amino groups, making it possible to form this enhance the further surface to surface character for drug delivery. And this graphene, large surface area of graphene, reduce graphene oxide or graphene oxide, make these nanoparticle, nanoparticle effective for drug carrier. So this is also magnetic nanomaterial. So future of magnetic nanomaterial is bright for 50 years. So there is lot of, whether it is storage sector, whether it is health sector, whether it is communication sector, whether it is storage sector. So this is the GMR effect. That is also spintronics. As you know, spintronics is also very, very important. So spintronics will also survive for next 50 years. So instead of electronics, spintronics will replace electronics. The beauty of spintronics is loss is less in spintronics, and spintronics are quick in action. So this is the hyperthermia study which we have used for these iron-based nanoparticle. This I have mentioned for different kinds of application. And thank you.
Thank you very much, sir, for delivering this wonderful lecture. You have nicely focused on magnetic materials, magnetic properties, and magnetic size-dependent properties of the nanoparticles, and the Mosfet spectroscopy too. We are very much thankful from my college, from Vinayak Vigyan Mahavidyalaya, for delivering this lecture. We are always need your help in the future with us. Thank you very much. Dear participants, now Mahavir Singh sir with us. If you have any query, any question, you can ask to Dr. Mahavir Singh sir. You can unmute your mic. Now you can unmute your mic and ask your query. Hello. Hello. Anybody has some question? Okay, since no question from audience, we'll move further for our next session, which is delivered by the Dr. Pankaj Koinkar, who is from Tokushima University, Japan. Dr. Pankaj Koinkar was done his PhD from the Department of Physics, North Maharashtra University, Jalgaon, and after that he moves to Pune, University of Pune, and then he starts his career into Tokushima University, Japan, as a research associate, and then now he's the associate professor in the Department of Optical Science in Tokushima University, Japan. So I am now invite to the Dr. Pankaj Koinkar, so to deliver his talk.
divided in 5 different parts. First, I will talk about myself, self-introduction. Then, what are the challenges two-dimensional material? I will talk on two-dimensional materials and its challenges. Then I will proceed to the laser ablation technique. Laser ablation techniques. What kind of laser ablation we have and how we are going to prepare the nanostructures. Then fourth, I will also emphasize the more different type of nanostructures. And then last part I will cover ongoing research that we are doing on nanostructures. So let's begin with the self-introduction. My name is and I'm with University as an associate professor. I did my and master also in physics 1995 and in 1997. And after that, I joined the until 2005 and was working as a researcher under the guidance of now it is a university. So after completing my physics and master I went to Korea for 1 year postdoctoral study at Korea University. So that was 1 year assignment. After completing 1 year postdoctoral study, I to Japan as a researcher. Initially, I was a researcher or research associate at Tokushima University. In Pakistan, I until 2016, and from 2016, I became associate professor in the Department of Science at Tokushima University. My research interests are preparation and synthesis of two-dimensional nanostructures, atomically nanostructures, using the laser ablation technique and electron emission. I'm also working on conducting polymers and sensors. I have published more than 80 research papers and several invited talks and presentations in international conferences, university and colleges. So this was my brief introduction. But where I am now I'm in Japan, but I have spent my initial 30 years in India. So I did my all education in India from standard 1, primary education, secondary, bachelor, master and PhD in India. That took me about 30 years to complete those education. And then I spent 1 year in Korea, and from last 14 years, I'm working in Japan. I have research experience of 24 years in the field of material. I have prepared several materials and studied their field, electron emission study and sensors. I started my research with conducting polymer, then diamond thin film, then carbon nanotube, then oxide thin film, and recently, last 5 years, I'm working on two-dimensional nanostructures. Since my research area is two-dimensional nanostructures, so I would like to begin with the challenges in two-dimensional nanostructure. First of all, I will explain what is the two-dimensional structures. You might seen this kind of diagram at several places or schematic or several. What is this? This is called as graphene. So you might heard about the graphene. Graphene is the two-dimensional structures, two-dimensional nanostructures. And if you remember, 10 years ago, these two researchers, Jim and Novoselov, got the Nobel Prize for their groundbreaking research in the area of graphene. They have prepared the graphene and show how graphene can be used for electrical and as well as optical property, especially field effect transistor and other property they have seen in their early year research. They started the research in 2004 and they got the Nobel in 2010. So they are the beginner of two-dimensional nanostructures. From them, in 2010, the research in the field of two-dimensional nanostructure has been rocketed. So many researchers started to prepare the various kind of nanostructures, two-dimensional nanostructures, beyond the graphene and as well as graphene. So what is graphene? Since graphene is the two-dimensional structure, is the first two-dimensional nanostructures we have prepared in the nano laboratory. So what is graphene? Graphene is a single atomic sheet of graphite. So graphite, the simple example of graphite is a pencil. Every day when you rub this pencil on a paper, what are you doing? What are you doing? Basically, you are creating thousands and millions of graphene on that paper. So, a layer structures of graphite, see this kind of layer structure. So, carbon atoms are attached to each other in hexagonal form, and when they arrange atomically like this, so this is one atomic sheet, and this one atomic sheet is nothing but graphene. But when these sheets are attached to each other, it is called as graphite because this single sheet is attached to each other. If it is not attached and they are separated from each other, then it is graphene. So there are difference between graphite and graphene. Both are carbon material, but their atomic structure is different. Single layer is called as graphene, but many single layer attached to each other, that is graphite. So we can prepare the graphene using the graphite, because graphene is nothing but a single atomic layer of graphite. So this is about the graphene. Graphene is the first two-dimensional one. Now, when the Nobel Prize has been awarded to these two researchers in 2010, the research on the graphene has been tremendously took place in various parts of the world, and by the time in 2015, in 5 years, there were 100,000 papers on the graphene, and people have started to search whether we can prepare different kind of dimensional structure. The answer was yes. We can prepare a different type of two-dimensional nanostructures. They are called as transition metal dichalcogenide material. So this kind of two-dimensional nanostructure can be prepared using the transition metal from this yellow color metal. You can see these are the yellow color, or maybe group 3 chalcogenide, this blue color, or maybe group 4 chalcogenide, this one, or maybe this topological insulator, green color. So you can pick up one metal from this, okay, from yellow or this blue, or this green area, you choose one. And then another, you can choose from chalcogenide atoms here. These sulfide or selenide or beryllium and sulfide, selenium or beryllium, you can combine with this transition metal. So when you combine this metal with this kind of chalcogenide, then you get another form of two-dimensional material. So if you make this combination, one metal from transition and joined with sulfide, selenide or beryllium, in that case you can get several combinations. So there are 88 possible combinations you can get, but out of these 88 combinations, only 44 are stable. So as I told you, you can get several type of material using this transition metal and chalcogenide kind of sulfide or selenide or beryllium. So this M and Q. So molybdenum base, for example, molybdenum sulfide or tungsten is there, for example, tungsten sulfide and tungsten selenide or molybdenum sulfide, molybdenum selenide. Such kind of initial EM transition metal chalcogenide material was prepared by various researchers. So that was the beginning of preparation of two-dimensional nanostructures beyond the graphene. Then another form of two-dimensional material is called as Xe. For example, graphene, silicene, germanium, or graphene nanoroutine, or phosphorine, stanline, silicene. These are the Xe form of two-dimensional material. Then Xen, that is graphene. Remember, graphene and graphene is a different material. It's sp2 and sp3. Their atomic structure is still different. Silicene, germanium, or stanline. So stanline, these are different materials. Or MXC. So here you can add some kind of metal and or maybe carbon or nitrogen here. You can prepare this MXC like Ai2CO3 or AC2CF2. So those kind of possible combination researchers are trying for desired application. And further two materials are fluoro-Xe. Here Xe, you can add fluoro or maybe chloro. So you can add fluorine or chlorine in this and then it becomes fluoro-Xe or chloro-Xe. So such kind of element we can prepare as a two-dimensional nanostructure. However, very few publication is available with MXZ or fluoro or fluoro-Xe. But in coming days, you will find many research papers on this composite material, two-dimensional composite material. So beyond graphene, as I told you, there are various material based on the molybdenum, tungstens, or even boron nitride. So those materials are prepared as a two-dimensional nanostructure. But initial was graphene. So let's look at what is graphene. Graphene is here. These are the carbon atoms. So graphene sheet is made from carbon atoms here. You can see these are the carbon atoms attached to each other in hexagonal form. Is it two-dimensional nanostructure? Yes, it is two-dimensional. Whether it conducts electricity? Yes, it is two-dimensional and as well as it conducts the electricity. Then how about another material, that is molybdenum sulfide? So in molybdenum sulfide, molybdenum atom and sulfur atom is attached to each other in this way. So this blue is sulfur and this yellow is molybdenum. similar form is a tungsten sulfide. Instead of MO, you can choose W as a tungsten, and similar kind of structure you will find. Or you can say MOSE or WSE, molybdenum selenide or tungsten selenide. How about their structure? These are, yes, these are two-dimensional structures. And conduct electricity, yes, it conduct electricity. Molybdenum sulfate, molybdenum sulfide material is considered as a semiconducting material, and it conducts electricity. The next is boron nitride, next example. Now, boron and nitride. So there are two parts. You can see one is boron atom and another is nitrogen atom. Look at the structures of how the atom is arranged. Exactly same as graphene. Okay. However, in case of graphene, there is only one carbon atom, but in case of boron nitride, there are two different atoms. One yellow is boron, and this purple nitrogen atom. But whether it is two-dimensional structure, yes, it is two-dimensional structure, but it does not conduct electricity because it is an insulator type of material. It cannot conduct electricity. Carbon atom, if attached hexagonally, it conducts electricity. But two boron or nitrogen attached similar way, they have similar structures like graphene, but they are not electrically conductor considered as. So three different type of materials I have shown you. One is graphene, molybdenum sulfide boron. Graphene is a good conductor. Molybdenum is semiconductor. It consists semi kind of metal, and boron nitride is insulator. So each two-dimensional structure has a different property, and that property can be used for desired applications. There are various publications available on two-dimensional nanostructures. Recent activities in 2010, as I told you, the research started with graphene and also then molybdenum sulfide. Various kind of processes has been invented by the researcher. This was on the synthesis of MOS2. Then another group from USA, they have started to see how we can prepare the MOS2 in large scale, and those kind of MOS2 we can use for application, electrical application or not. Then in 2012, exfoliation process has been also started to gear up, and we can see various kind of boron nitride MOS2, WS2 kind of nanostructures has been synthesized using the exfoliation techniques. Then in last 2 years, there are some paper on new type of two-dimensional nanostructure like phosphorine, and it can be used in display devices. There are some publication, also several kind of different combination of two-dimensional nanostructures like graphene, MOS2 or hexagonal boron nitride. These three type of different two-dimensional material we can make a composite, and it can be used as a FET. For FET application, the answer was yes, and this paper was published last year. And also in 2014, there was paper on silicene. So phosphorine, silicene, these are similar kind of materials. This made from silicon, this made from phosphorus. But if you look at the spectra, UV spectra, it exhibit a different type of bands here. So depending on the particle size, we might get a different type of wavelength or absorption spectra for these materials. So it was published in Nature Communication 2014. So after this recent activity, what are the future kind of application that two-dimensional material can have? There are several two-dimensional material, but if you look at the graphene has a zero band gap. Then boron nitride has 5. So 0 means good, but 5 is insulator. But if MO is 2, you consider 1.2 to 1. So it can be considered as a semiconductor material. And of course, you can dope some kind of metal in it, or maybe make a composite material of different kind of two-dimensional material like graphene, MOS2, and then its band gap can be changed, and we can get heterogeneation type of property from these two materials. So depending on the band gap, so we can control actually the band gap for photonic applications. If you add some kind of metal or some kind of material, you can control the band gap, and that band gap can be used for optical application in the photonics or energy parcelling processes. Similarly, we can use this kind of present two-dimensional nanostructure or future two-dimensional nanostructure in solar cell or flexible electronic, that is a display device or light emitting diodes. And beside this, as I told you, some kind of material, even though they are kind of insulator material, but still boron nitride is a good thermally resistive material. So we can use such kind of material display devices which can hold the thermal maybe energy for a long time, and we can enhance the performance of display. So these kind of applications are possible in near future. And another application of dimensional structures are sensor. So MOS2 based material can be used for sensor application, biosensor or chemical or gas sensors. Now coming to my research, I will talk about the laser ablation technique. That is my today's main topic. What is laser ablation process? So laser ablation process is the process where we can use the laser energy to remove the material from the target material. We are doing the research, the laser ablation in liquid medium. So in liquid medium, we irradiate the material using the laser, and that laser has certain energy. That energy can be used to remove the material, the top surface of the material, which can be transformed into the nanostructures. And high energy, high power energy laser pulse hit the surface of target, leading to melting, evaporation, ionization of material. Depending on what type of laser we use, it hit the target surface, and according to the available laser, we can see the various physical processes occur when the laser hit the surface of a target material. It might be melting, evaporation, or ionizations. So we can use various lasers like India laser or femtools laser. India laser is a nanosecond laser. Excimer laser or sapphire laser like femtosecond or picosecond laser we can use for ablating the material. So microsecond, nanosecond, picosecond, or femtosecond. These are four basic type of laser you can use for laser ablation as a source. And we can prepare oxide metallic systems, fluorine or carbide or nitride material using the laser ablation. The prepared size of nanostructure varies from 5 nanometer to 100 to 200 nanometers. So as I was telling you about the laser ablation, depending on the laser, what kind of laser we use, whether we are using microsecond, nanosecond, picosecond, femtosecond laser. If we use microsecond, because energy is very high, microsecond, then sometimes boiling happens because our medium is a liquid medium, so boiling happens. Nanosecond, we are using nanosecond in our laboratory. So radiation, ionization, vaporization, convection or melting also happen. How much time we are irradiating the sample, what kind of liquid we are using, depending on those conditions, these 5 physical processes occurs in the liquid medium. Or ionization in case of conduction happen in case of picosecond laser. In case of femto, absorption or excitation occurs at the surface. So these are the fundamental process of laser ablation. So if you consider this one is a solid material, okay? If you consider this as a solid material, so when you irradiate the laser like this, what happens? The laser energy used to remove the surface of the material. So laser goes a little deeper into the surface of solid, and it creates some kind of plasma plum like this, plasma plum. And here it is still liquid. The energy is used to create the dead zone in this maybe surface of the solid material. So such kind of changes occur when we irradiate the laser. So continuous laser, nanosecond laser, and pico or femtosecond laser. What is the difference between these lasers, and what kind of processes occur? So if you consider this one is your target material, you want to maybe prepare the nanostructure using the continuous wavelength laser. So continuous laser means laser is continuously falling. There is no pulse is given. Only continuous laser is falling. But it can hit the certain area only. It cannot go more deeper. But in case of nanosecond laser, it has energy, of course, and pulse. So when you have energy and pulse, so it can hit deeper the surface of target material. So it can hit here, and you can see this area surface is already evaporated in the liquid, and then there are some shock waves also created. So these shock waves also very important to create the nanostructure, because sometimes if there are many multi-structure, multi-layer material is there, so this shock wave can separate those kind of layers. So this is two type of effect we can see. One is due to the shock wave, another is due to the direct energy of nanosecond laser. In case of pico or femtosecond laser, the pulse time is picosecond or femtosecond. So it's very small, and energy is also like 3 milliwatt. In case of nanosecond, it is 400, 500 milliwatt also. So compared to nanosecond, femto laser has very small energy. So it can damage very little area here. It can damage very little area here. Of course, it creates shock wave, but that can control very few or very small area. So only small area is affected as compared to nanosecond laser. And continuous laser cannot go more deeper. However, at the surface, it can damage a surface part of the target material. So this is the difference. So difference is that it depends on the laser power, what kind of laser power, laser energy you are using, and how the processes is occurs that can decide the formation of nanostructures. We have prepared several nanostructures. The first nanostructure we have choose bismuth selenide. Why we choose the bismuth selenide? Actually, bismuth selenide material is a topological insulator. It is considered as a topological uh, insulator material, but it have some kind of conducting states on its edge or surfaces. So when this bulk insulator material convert the nanostructures, whether these conducting states are really useful for some kind of maybe property, whether they can change the property or not. That was one of the challenges in case of this topological insulator. Of course, this topological insulator like bismuth selenide has mm, maybe shown its ability to electronic, optoelectronic or thermoelectronic devices because of this unique property that it has some conductive states on the edge or maybe surface. And recently, there are a few publications already has been reported on this bismuth selenide material. But the challenge is the large scale production. Whether we can prepare the large scale production, and if we prepare the large scale production, then it might be used for making the devices. That is one of the challenges in topological insulator. So considering these challenges and to control the crystal morphology of two-dimensional material like bismuth selenide, we are thinking to prepare two-dimensional material which can have a different kind of crystal morphology or structure and that can be used for desired application. So furthermore, maybe these kind of materials is also need to understand their phonon scattering and what kind of interactions occurs when they convert the nanostructure. When they are in bulk, they are as a bulk material, they have different properties. But when they go to the nanostructure, whether the phonon scattering has some kind of effect or electrical property also changes, that was is not maybe described by any paper till date. So we want to see whether such kind of interaction we can see through this bismuth selenide material. So this is our setup, a simple setup for laser ablation process. This is a beaker we use, or maybe instead of beaker we can use some small glass bottle. We put different kind of liquid, for example, water, acetone, methanol, or any organic liquid like isopropyl alcohol also, and we cover with the glass lid, or if there is a bottle, we use some kind of bottle, pack bottle, and this is the India glazer, that is the nanosecond pulse laser, and these are the powders we put into the liquid, and when laser irradiate this powder is in microstructure, it transforms into the nanostructure. So this is the simple process for laser ablation. So we can use glass beaker or even glass bottle as a sample where we can put our powder sample, and laser ablation can be conducted using second Harman NDA laser having the wavelength of 532 nanometer. Its pulse time is a 10 second, like every 10 seconds one pulse go, and with the frequency of 10 hertz. Power is about 50 millijoule, or you can say 500 milliwatt. The beam size is 5 in diameter. Now, how we have synthesized, this was the process I told you. This is the experimental setup. Now, how we have done, we purchased the bulk bismuth selenide material. Now look at this bulk bismuth selenide material. The size is in micron. These are micron, but some are little big particle are there. So some small, some big. These particle are not uniform. So we try to prepare the uniform powder. We crush for 2 hours using isopropyl alcohol. After crushing, we have found that the powder become more fine, and now this powder is ready to use for laser ablation. So here we put this powder here, and then we have carried out the laser ablation. So after laser ablation, when we put this powder and laser ablation is carried out, what happened? So this was the water before the laser ablation. So you can see the color. So if you put this powder, of course, when we crushed, the quantity of powder was more. But when we try the experiment, the quantity of powder was like in milligram. So you can see the outer color is black. Okay. So before the laser ablation, the solution color is black. But after laser ablation, the solution color tremendously changed into the brownish color, yellowish brown color. So this is the first sign we can say that it shows the presence of nanostructures of bismuth selenide. So we have confirmed the structures using scanning electron microscope. Bismuth selenide, this is the bulk material. So when we crush, these sheets are like 2 micron, and some maybe 500 or 2 nanometer. But these are the sheets of the two-dimensional sheet. You can see on smaller scale. So these are the sheet, maybe 1 micron, or some are 500 or 200 nanometer also. But they are in sheet and they are attached to each other. They are not separated. But when we do the laser ablation after 120 minutes, the structure is changed completely, and it converted into the rods-like structure. So this structure is changed dramatically, and we can see the change in the structures after 120 minutes. And this is the TM image, and this is the bulk material. This is the bulk on 200 nanoscale, 200 nanometer scale. And this is also on 200, but this is after laser ablation. So this is the sheet you can see, and this is the rods. Okay. So this rod diameter is about 300 nanometer, and size is about the length of the rods is about 2 micrometer or so. So this is on 100 nanometer scale. So you can see about 300 nanometer is the diameter. Of course, there are some particles remains after the laser ablation. During the laser ablation, the rods, formation of rods occurs, but with the rods, there are some nanoparticle of bismuth selenide material are found on the rod nanostructures, bismuth selenide nanostructures. So these rods is also presence. So what happened? How this kind of structure can be created, can be transformed from bulk material to the nanostructures using the nanosecond time scale frame. So here, as I told you, every 10 seconds one pulse is going, and when it goes to the any solid material, it creates a plasma. plasma plum. This is the laser beam is coming here. So plasma plum is created, and here some part of the surface started to remove. These are the shock wave. These are the shock wave. And here, as I explained you in earlier slide, that some part of the surface on the surface has been removed because of the laser pulse, and this removal of the material is occurs because of creation of plasma, and of course the separation of sheet is also occur because of this short wave and creation of plasma. So this is the physical process occurs at the surface. So there are two possible mechanisms in case of laser ablation. One is reductive ablation, another is fragmentation. So what kind of mechanism we can suggest when there is a form of nanorods? We believe that in our case, since it is nanorods has been formed, we believe that the whole sheet has been cut into the pieces, and those pieces are like rods. So it is easy because the rods are look like uniform. If you look at the ACM, so that cutting of the sheets, this is one bulk sheet, but it's cut into the several parts like nanorods, and finally we can get the nano rods or sheet-like structures. I told you that there are some nanoparticle presence on the nanorods. So of course, when nanoparticle is formed, it creates some kind of nucleus sites, and those nucleates come together, agglomerate, and form the nanoparticle. So this is also possible when the nanoparticle happens or nanoparticle forms during the laser ablation. But in our case, we believe that rod is formed because of the fragmentation. Fragmentation means divides the bulk sheet into the several parts. And then we have checked whether the formation of bismuth selenide material is there or not. So this was the invisible spectra. You can see here, this is the bulk. And in case of ablated sample, you can see the enhancement in the absorption spectra, which gives the sign that the bismuth selenide material is transformed into the nanostructures. Also confirm using the X-ray diffraction spectroscopy. Black one is the bulk material, while the red one is the laser ablated, and you can see the intensity of many peaks has been reduced, and some kind of new peaks is also occurs. Since the intensity is reduced, it also shows the formation of nanostructures. These are the major peaks of bismuth selenide, and you can see a change in the intensities. This is the Raman spectroscopy in order to confirm whether the prepared material is still keeping its own structures or not, or maybe crystal structure is changed, or just keeping the same structure as an intact material, like bismuth selenide is really bismuth selenide or not. So this one is the bulk material. There are several peaks, 1, 2, 3, and 4 peaks are the characteristic peak of bismuth selenide. And in bulk material, of course, this 73, 129, 170 up to 50 occurs. These 4 peaks shows a different kind of phonon modes, and it suggests the microstructure of agitated sample. But when this bismuth selenide is irradiated for 120 minutes, after irradiation, you can see the intensity of these peaks has been reduced, and some peaks is already maybe lower down, or they are almost vanished. So for example, this 252 peaks is almost gone, and these peaks, the intensity is reduced, as well as these two peaks, the distance is also maybe increase after the laser ablation. So these are the sign for showing the presence of nanostructures. And then we try to see whether this nanostructure is good for any electrical property, for example, field electron property, electron emission property. So field electron emission is used for field emission displays. Here we can use our sample as a cathode, and we can see whether the electron is emitting from this sample material. So electron emission is the emission of electron from the condensed phase, such as metal. For example, our sample into the second phase, that is usually in the vacuum under the action of electrostatic field. So when you don't apply the field, if you don't apply the high field, the electron will tunnel like this. Okay, will tunnel like this. But when you apply the high electric field, electron tunnel like this. Okay, so its work function gets changed. That is field emission process. So this field emission has application in various areas like display device, or even field emission lab. And this is the setup. I'm not going into the detail of this setup, but I just tell you that this is the anode screen, and this is the substrate we can put and give high electric voltage to this substrate and see the change in current. Okay, and this is whole system. There different kind of vacuum pump has been used to create the vacuum of 10 to the power -8. So here, phosphor screen act as an anode and our substrate act as a cathode. We can see such kind of emission image, whether electron is tunneled or emitted from the our sample substrate, such as bismuth selenide or not. So this was the field emission result. You can see the maximum current here at this field was 408 microampere per centimeter square at 4.1 volt per micrometer. This was the maximum current in case of as-it-is sample, this one. But for rod-like sample, the current density was much higher than 408. It was 647. So of course, it suggests that the nanostructures is act as a kind of semiconductor material, because you can get the maximum current density from this material with lower field. So you apply low voltage, you get high current. So that is change in property. This occurs because you can see the bulk material is converted into the nanostructure. Beside these nanostructures of bismuth selenide, we have also studied several different type of nanostructure. For example, tin oxide RGO nanocomposite and its emission properties. You can see, as I was telling you, if you look the two-dimensional material, be metal or oxide or some kind of other two-dimensional material, you can able to enhance the property. Same thing is happening here. So if you look at this graph, it suggests that the RGO is giving the current up to 500 something. But when you have RGO doped with SNO2, that 500 changes to 800, nearly 800 microampere per centimeter. So this enhancement in the current density is because of the combined effect of SNO2 and RGO. So electron is transmitting from both RGO nanosheet as well as the SNO2 nanoparticle. So combined effect of both material enhance the field emission property. This was published in 2017 in Material Science and Semiconductor Processing. Then another material we are working on MOS2. We are prepare MOS2 for different laser ablation time, like 20 minute or 120. You can see the change in the nanostructures. The small nanosheet has been occurs after 120 minutes, that is 2-hour laser ablation, and field emission property also enhanced. So this field emission property enhanced because of one nanostructure as well as the removal of MOO3 particle. So bulk material, there are some MOO peak, but after laser ablation, MOO3 peaks was removed. So here there are possibility that removal of MOO3 also participated in the emission of electron, and it can enhance the overall electric current density. Then one of the research of field effect transistor has been done with Professor M.D. Shirsat from India. He's working in Dr. Babasaheb Medical University, Marathwada University at Aurangabad, and we have prepared this sample in our laboratory and sent this sample to him, and he has seen this property of field effect transistor. Surprisingly, we have seen that this kind of material is also useful for field effect transistor, and here most of the charge conduction is due to the electron. Of course, for FET application, you need a charge carrier. So in case of bismuth selenide, N type of charge conduction took place because of electron, and we get a good kind of field effect performance from this nanostructure. This is also published in 2019, that is last year. And conclusion of my present research we have done in last 4 years. We have synthesized bismuth selenide material and other two-dimensional nanostructure. You can see the change in surface morphology after laser ablation treatment, and these two-dimensional nanostructure can be used in various application because of their improvement in the optical as well as electrical properties. And I have only 5 minutes to go, so I will talk about the ongoing research work. We are working on various material like MOS2 bismuth sulfide or tungsten sulfide. So as I told you that before and after, you can see the change in the color. So MOS2, earlier I have shown you one result, but this MOS2 with the different liquid, you can see the small kind of nanostructures, nanoparticle has been formed on the MOS2 when we use methanol as organic liquid as a solvent during the laser ablation. So we can get the small nano maybe particle up to 20 or 30 nanometer. And another material is bismuth sulfide. So bismuth sulfide, when we irradiate the femto laser, we can get the some kind of nano particle, and tungsten sulfide also we are getting some kind of maybe nano sheets. And the research we are doing bismuth selenide using the femtosecond and nanosecond laser. We have prepare various type of nanostructures of bismuth selenide. For example, nanosheet, nanoparticle, nanotube, nano ropes, or maybe we are also creating some kind of nanoparticle or nanosheet combinations, like fluorine like nano ropes is possible using femto laser second. But those kind of structures we need to study more. This kind of material has been prepared, but we are now concentrating on their growth mechanism. How the growth mechanism of this material, these studies are under work now. And in recent research, we have also tried to prepare indium selenide material using the laser ablation, and we have get the cubical structures of indium selenide. So here you can see some cube of indium selenide is occurs, or you can say transform from the bulk material after the laser ablation. So these are the tube. These are the ACM. We have good TM, but I have not put here. And this was the same slide. I was telling you about the future research opportunity. So at least 10 years, you will find many papers in the area of two-dimensional materials. And now those properties, the targeted properties of two-dimensional material are optical and as well as electronic or electrical properties. For photonics applications or some flexible electronics or sensor applications. These are the three major areas where we still have a research opportunity. So two-dimensional material has a great futures. If you want to do the research in two-dimensional material, then you have good opportunity, research opportunity in the world. And as far as our laboratory is concerned, we are trying to develop the more powerful two-dimensional material using the laser ablation technique for the development of some kind of devices that is based on their electrical as well as optical properties. So this is our future pathway to develop the nanostructure using the laser ablation methods. So I would like to thank my collaborator, my group leader, and my students. So he is Professor Fube, he is our group leader, and my collaborator from Tokushima University, from Taiwan, Professor Lee, Professor Moriga from University, Professor More, and from Dr. Babasaheb Ambedkar Maratha University, Professor Sirsak. And these are my master student and doctoral student who has done a tremendous good work on the two-dimensional material, and they have spent their precious time to get these kind of material. So I would like to thank them all. And with this, I would like to say you thank you very much for listening to me. And I hope that you like my talk. If you have any question, please write email to me, okay? And I will be happy to answer you. So now I will stop here, and I have already shown you my email address, goinkar@tokushima UAC. Here you can write your email to me, and you can write email to me and ask question if you have any question. Thank you very much. Bye bye.
Thank you very much, sir, for delivering this such wonderful lecture. And you focused on laser ablation process and synthesis of materials by laser ablation process. I'm very much thankful to, on behalf of my college. Uh, Thank you very much, sir, again. Now the session is having a refreshment break up to 10, 10:50. After the 10:50, we have three sessions, again three sessions, namely Dr. Harsha Jadhav, Dr. Wagule, and Dr. Ghosh. All the participants should remain present at 10:50. Session will start sharply 10:50. Welcome back. Now it is time to I once again welcome to you. After the wonderful talk of Dr. Pankaj Koinkar, we are ahead for our today's third session, delivered by the Dr. Harshad Jadhav. Dr. Harshad Jadhav is presently working in the Myonggi University, South Korea, and he he has done his MSc from Kolhapur University, Kolhapur, and Shivaji University, Kolhapur, and his PhD from South Korea. And he's been working from since 2011 in the Myonggi in the South Korea. So I request to Dr. Harshad Jadhav to deliver his talk. So Dr. Harshad Jadhav.
So, good morning, everyone. For today, my presentation talk is about entitled protected lithium electrode for rechargeable lithium oxygen battery. I'm from South Korea and working as an associate professor over here. So, in short, my introduction is myself, Harshad Jadhav, working as associate professor in Myonggi University since last 6 years. And my research area, my research interest is majorly secondary batteries, including all lithium based batteries like lithium ion, lithium air, supercapacitor, solid electrolytes, and electrocatalyst for several applications such as water splitting, methanol oxidation for fuel cell. So yeah, I'm interested in this kind of all factors for energy conversion and storage application system. So the outline of my presentation will be like, which will include the motivation behind this work, then current energy outlook.
Thank you. Speaker is not working.
We are and lithium ion battery. Present lithium ion battery technology, lithium air batteries, solid electrolytes. First of all, as we know today, even we have seen since last after lockdown, shifted or lifted by government, the petrol diesel price increased almost by 4 to 5 rupees. Yeah, so everybody know we are dealing with some global warming problem as well as day by day increasing oil prices. So yeah, this is the big problem. So what we can do? So these are the non-renewable energy sources. These will end someday. So just we have option to find some alternative for this kind of problems, and we should have find some solution to deal with these problems. So what is the best solution to deal with this kind of problems? Use of renewable energy sources. So in our bachelor or undergraduate school, we have studied about the renewable and non-renewable energy sources. So there are a lot of renewable energy sources like solar, then wind energy, so which we can convert the solar or wind energy into the useful electric energy. So we know that with the solar cells, we can convert the solar energy into the electric energy. energy into the electric energy. Okay, so once we generate the electric energy from these renewable energy sources, so we cannot use it immediately, or when we generate it's in large amount, we have to also think about the future. When in future, when it need it, we can use it. So for this purpose, we need some storage systems which can store this generated electricity, and even also to use this electricity some at other places from the place where we are generating it. So we need some transmission system from one place to another place we can bring that electricity, we can say, we generated from the renewable energy sources. For that we need something medium which can store the electricity, and whenever we need it in future we can use that electricity. So one of the best medium, as we know and we use in our day-to-day life, is the battery, secondary battery. Especially in our day-to-day life, lithium-ion batteries are playing important role, as well as like supercapacitor we are using. So lithium-ion batteries, those batteries are like batteries. The basic chemistry in the lithium-ion batteries is which converts the chemical energy into the electrical energy and electrical energy into chemical energy. It's simply like when we charge the battery, there happens some chemical reactions and we store the electricity in terms of some charge in the battery. And when we discharge it, it means when we use for some our purpose, then it's convert into the again electrical energy into the chemical energy. So batteries plays important role, especially secondary battery. What does it mean by secondary battery? Those battery we can charge and discharge several times. We can say secondary battery, and the primary battery means the same like pencil cell, means once it is discharged fully, we cannot recharge it anymore. That's primary batteries. So in our case, we have seen your day-to-day life, we are using the secondary batteries for several purposes, like day-to-day life, say our cell phones, laptop, cameras, and main application is the electric vehicle. So electric vehicle is the main application for the energy battery system. But for the present situation, if we look like application for the electric vehicle, it's not that much satisfactory achievement in this field, because once we charge the battery system in the electric vehicle, we can go maximum like 200 kilometers maximum. So with single charge, so it's not enough. And in the place like in India, the situation is not like to use electric vehicles everywhere, because once we don't have that enough battery charging station at like specific distances in India. So it would be better if it can run like 500, 600 kilometers with a single charge. So if we look for the today's technology trend, we are now here to 2020, and we are like using presently lithium-ion battery system, which are mainly application like hybrid electric vehicles, smartphone, cordless tool, laptops. And what will be the future? The future which will replace the today's lithium-ion battery system, and the future where, as I mentioned, we can use the battery system minimum 5 to 600 kilometers in electric vehicles with a single charge. And this is only possible with if we're looking for new battery system. this is possible, like metal air battery system, metal sulfur battery system. In short, we can say the super batteries as compared to the lithium ion battery system. So today, if we see in a lithium ion battery system, almost every is saturated. Means there is a limitation in theoretical capacity of the lithium ion battery. So even if we try to change or find new alternative materials like anode and cathode and try to increase the total capacity of the lithium ion battery, there is limitations. So even if we compare today's lithium ion technology with another storage system like supercapacitor. So the basic difference between the supercapacitor and battery here I have shown. So the main basic difference we can compare on the basis of power and energy density. So power means the rate at which we can take out the electricity, and energy density means energy stored per unit value. It means battery can work for 1-2 days once charged. But in case of the supercapacitor just is charged and discharged for a few seconds. In case of the battery, it takes several hours to charge, even several hours to discharge. So we can say the specific power of the supercapacitor is higher as compared to battery, but on the other hand, this energy density is lower as compared to the battery. So if we're looking for long-term application, we have to go for battery. And if you're looking for short-term, just for seconds, just like in our vehicles or car, we are using starter. For that moment, we need like within few seconds, we need high power. That moment we can use supercapacitor. Even like another example, flashlight of the camera, there is use of supercapacitor, which provide the high power just within a seconds. So here are the application of today's lithium ion technology. So from which deals from the small scale to the high scale, like from watt hour to the megawatt hour applications, which includes just from our cell phone, like portable electronic devices, to electric vehicles and the big grid applications, we can say. So this is the lithium ion battery basic mechanism. So here, the traditional, which we are using today nowadays, battery, the traditional lithium ion battery, which consists of as a graphite as a cathode and lithium cobalt oxide as a positive electrode and graphite as a negative electrode. So there is an intercalation and de-intercalation of the lithium ion take place with this possible reaction. But if we look for this reaction, the theoretical capacity is only 372 milliampere hour per gram, which is very low. So if we want to go for higher applications, like if we want to increase the capacity, then what we should do? We should find some new materials instead of lithium cobalt oxide and even graphite, which will deal with good with the intercalation and de-intercalation process. So there are a lot of optional materials are there, but there are also limitation of the volume change and cycle life effect. So until now, it is found that the negative electrode, which is used as graphite, is highly stable. When there is a change, lithium insertion takes place within the layers of the graphite, there is only like 10% volume expansion take place. On the other hand, if we see in case of the silicon, which gives the almost like 10 times higher capacity than the graphite, like 4,000 milliampere hour per gram. But if we look if we use the silicon as a negative electrode, but the same time, the problem is volume expansion. In case of the graphite, the volume expansion is only 10%. But in case of the silicon, the volume expansion is almost 300%. So it means it lead into the lower cycle life, and just like after 40-50 cycle, it will fade up the capacity. So lithium-ion technology, where we are in case of the safety, thermal abuse tolerance is also there. energy cell capacity has been increased to over 3 ampere hours in some this is specific cell. Then power is also significant, but not that much as researcher expecting. The life is also short. Operating temperature is from minus 55 to 80 degrees Celsius, and cost is also the main goal, because especially in case of the lithium-ion battery, as compared to the petrol diesel price, the lithium-ion battery electric vehicle best cars price is much more higher. This is because of the lithium-ion battery cost is high. So because whenever we are looking for any practical applications or new battery system or new any technology, the price is also important. So here are the possible anode materials which we can focus as a new materials for batteries. So graphite here, as I have mentioned, graphite is the nowadays present used negative electrode in commercial batteries. But if we look, these are the possible materials we can use. And if you look, as I mentioned here, silicon is showing almost like 4,000 capacity. But the main problem with the silicon is the volume expansion is much more higher. So which lead into the change in the structure just within few cycles, and which lead into the shorter cycle life. In our case, we have designed some materials, oxide based especially, with composite with the graphene and these other things. So I will not go in detail about the advantage of the one-dimensional, two-dimensional, three-dimensional material. So here are summarized. Just I'm going in short overlook for the lithium-ion battery, because I have to explain you that why lithium-ion battery system is now saturated and we have to look for other battery system. So whenever we synthesize any application, the synthesis is very important. So with this strategy, we can design any materials to increase the surface area, create more active sites, also to make short diffusion path, to increase its conductivity and structural stability. So here are some materials we have explored, especially spinel oxide and some graphene composite we have explored for the lithium-ion battery application as a negative electrode. So we have got some good results, and we have published in good publications in international journal. But after this, is it enough to drive any electric vehicle only with like 150 miles with the electric present lithium-ion battery technology? So the answer is no. Because as I mentioned, in countries like India, we don't have the power system at every like 100 kilometers or 50 kilometers to charge battery once it's discharged. So we have to go like higher, we should expect the higher mileage with a single discharge. So if instead of like a range 150 miles, if we expecting like 600, we have to look for another battery chemistry. And that battery chemistry will be like this, which should be higher than the 200 minimum. So people say, researchers, those working in batteries, they are expecting like 500 to 600 kilometers with a single charge. So today we are here at like 160 kilometers for with a single charge. And if we look the future batteries, so as I told you, even if we are doing some modification in the present lithium-ion battery system, there will be like maximum 200 to 250. There is limitations in capacity. But if we look another for battery chemistry like zinc air battery, lithium sulfur battery, lithium air battery, these lithium zinc air, lithium air batteries belongs to the metal air battery system, which can go like more than 550 kilometers. So it means the theoretical capacity, because its theoretical capacity is very high. And it's in all these systems, okay, zinc air, lithium sulfur, and lithium air, all these systems are under development. So maybe in like 2030, maybe it's possible to drive electric car with the metal air battery system. So yeah, is there is a future with lithium air battery where we can drive a car with a single charge like 4 times higher than present uh, lithium-ion battery technology, because the metal air batteries gravimetric energy density is high. If we look here, the lithium-ion battery gravimetric energy density is only like 370 or something. But if we look around the lithium air and gasoline, yeah, gasoline already that's petrol we are using gasoline. This kind of having high energy density, gravimetric energy density. But in case of the batteries, if we are looking, it is like where is 160 and where is 1700. So we can say it's like 10 times higher gravimetric energy density in theoretical and practical also achieved. But also same time there are a lot of practical limitations or practical obstacles we have to overcome before the practical utilization of these battery systems, especially in case of the all metal air battery system. Why it is mentioned metal air? Because here the zinc, lithium are the metals. On the basis of it's named as a zinc air, lithium air, and in general class we can say metal air batteries. So especially here my interest was lithium air battery system, because it's even within all air battery system, lithium air battery system is having the higher energy, or we can say higher specific capacity. So if we look here, so energy density of these metal air batteries higher than lithium ion batteries. These are the less expensive and environmentally big, because in case of the lithium or metal air batteries, the main reactant is the air, which is already present in the air with free of cost. But in case of the lithium ion battery, all the reactants electrode are closed within a system. So if we look our mobile battery, you can see all the sealed, it means the electrode, and the main reactants with electrodes, all the sealed in the one specific assembly we can see in our mobile batteries. But in case of the metal air batteries, oxygen from outside will check inside the battery and it will react with the cathode and it will form some byproduct which will lead into the movement of the electron and which will give the electricity generation. So if we look specifically for metal air batteries, so if we see lithium air, aluminum, magnesium, calcium, sodium, zinc, iron, in this all the theoretical capacity or specific energy of the lithium is highest. After that, aluminum, magnesium. So my interest was like go for the lithium. But on other hand, there are also the lot of problems if we using the lithium as a metal in metal air batteries, because as we know, we cannot handle lithium easily with open hand or in open atmosphere. To use the handle lithium, we have to use the specific system like glow box, and even you cannot expose easily to the air because it get easily oxidized. Even in case of the lithium, you cannot use any aqueous electrolyte. These are the lot of drawbacks, and we have to overcome, or we have to find some solution to overcome these drawbacks. So just this is about the metal air batteries. Metal air batteries, what it's contain at the anode and the electrolyte interface, it's having some metal, as I mentioned, lithium, sodium, zinc, and at anode it's oxidized and results in the electron transfer to the other circuit, and at cathode oxygen is reduced to superoxide species in the presence of oxide metal. So here the main role of the cathode, which is possessing the catalyst. So we know that the catalyst will just enhance the reaction, but it do not participate in the reactions. So the main at the cathode with a specific catalyst which enhance the reaction, where it means in this case, if we see here, I will show in detail here. This is the anode, this is the cathode, and this the anode is the totally lithium metal foil, and cathode is the with some porous like structure with catalyst. So what will happen during the reaction? Oxygen, keep in mind, oxygen from atmosphere will take inside the system, battery system, and this will react. Lithium ions will move towards the catalyst through electrolyte, and it will form some lithium peroxide structure. At the same time, during the next step, during the charging, what will happen? During the charging, the reverse process will happen. Lithium will go to their place, oxygen will go to their place, and lithium will form the lithium metal, and oxygen will be like this. So it means there is easily charging and discharging process possible, and this formation of the byproduct, and during the charging and discharging, the high current will flow through the outer circuit, and this will lead to almost 10 times higher capacity than the present lithium-ion battery system. So what are the problems? Now actual presentation start. So what are the problems with the lithium battery challenges? So the problems with each part of the battery, with the anode, with the cathode, and with the electrolyte. So with anode, as we know in lithium-ion battery system, anode is the lithium. So cathode is the any composite catalyst. In case of the anode, lithium dendrite formation possible because of unequal distribution of the current, and the unstable with the moisture. So earlier I explained you with the moisture, even we cannot expose lithium to the air, and whenever we use it for the with the aqueous electrolyte, this is also important. And also, as we know, air also contains the moisture. So when we take the oxygen inside from this cathode side, if it is moisture pass to the lithium side, it can make trouble to the lithium, and it can lead into the catching the fire. Okay, that's why safety issue is also important. So cathode stability of the catalyst is important, because the lithium peroxide, reversibility of lithium peroxide is also important, and the poor round trip efficiency with the present catalyst, and discharge product. So those forming discharge products are like insulating in nature. Electrolyte, stability of electrolyte, conductivity of electrolyte, volatility, and oxygen solubility and diffusivity is important. Because conductivity, why conductivity is important? Because if the conductivity is high and good, the lithium movement will be the much more easily and faster, which will result into the higher capacity. So in this aspect, if we use the protected lithium electrode cathode with active catalyst and stable electrolyte, which can lead into the high capacity and good cycle battery. Here I will focus only on the lithium ion, lithium air battery system anode, because a lot of people are working on the cathode, but the anode is less exposed part. Handle this kind of the its challenges. So lithium dendrite, because if lithium dendrite take place and if it process like this to this way, it can puncture the cell and cell will not work anymore. Also the instability with the moisture is also important. So here I will explain this possible approach how we can protect this lithium from dendrite growth as well as from the moisture, as well as how we can increase the safety. Okay, so if you consider this is the battery cell like lithium cathode, which is separated by the electrolyte. So what happens? when we cycles for several charge and discharge cycles, with cycling what will happen? Lithium dendrite will take place, and that here we use the electrolyte with separator, which is a simple like filter paper kind of separator, so which can easily puncture lithium dendrite, can easily puncture it, and if we touch this way, it can it lead into the failure of the cell. So how we can avoid this? How we can protect this? Yes, we can protect it by introducing solid electrolyte. Because here initially people's we are using like the liquid electrolyte which is soaked in the separator. But if we insert an additional electrolyte which is a solid between the lithium metal and the electrolyte, then it can protect more. It can decrease the even unequal distribution of the current, which will lead into the reducing the lithium dendrite output, as well as its safety will increase. So what are the different possible solid electrolytes? So here are the different solid electrolyte class between on the basis of crystalline and amorphous nature. So among this crystalline, I have chosen the Nesicon type. Nesicon means sodium superionic conductor electrolyte. Among these, I have LATP and LAGP type of electrolyte. So I will not go in detail for other kind of electrolyte. So these are the solid electrolyte with lithium, aluminum, germanium phosphate, lithium, aluminum, titanium phosphate. So especially I have exposed the lithium, aluminum, germanium phosphate. So always the main problem with this kind of solid electrolyte is the conductivity, because in case of the liquid electrolyte, the conductivity is higher as compared to solid electrolyte. Because in case of the solid electrolyte, the conductivity get reduces because of the grain boundary effect. So here are the issues with the solid electrolyte. The total conductivity is mainly restricted by the grain boundary conductivity, and secondary phases along with the grain, which lead into also again the decreasing conductivity. So here are the, in case of the LAGP, main LI2 and ALPO4 are the secondary phases which are like less conductive as compared to the main grain, and the high crystallization temperature and time. High crystallization temperature during the synthesis especially it need, and also time to synthesis is higher. So what is the next attempt? If the conductivity is lower, the main target should be like we should increase, how we can increase conductivity. So we can increase conductivity. There are possible ways. We can do some specific material like aluminum, silicon. Also we can control the concentration of dielectric phases like Li2, AlPO4, which mainly segregate along the grain boundary, because the grain boundary conductivity mostly influence the total conductivity of the solid electrolyte. So here we plan to use the boron oxide as a doping, or we can say sintering agent. Sintering in the sense that which can reduce the crystallization temperature also, because in most of the catalyst, solid electrolyte synthesis, the crystallization temperature is about 500, 600, 700, in cases 900, and up to the 1000. So for practical purpose, this is not good. So we use the boron oxide, which is act as a sintering agent as well as which improves the conductivity. So in this case, if we look, the movement of the lithium ion from one grain to another grain is restricted mainly by the grain boundary. So here is the synthesis route for the solid electrolyte. We use the solid state melt quenching method. In that we use the all composition lithium, aluminum, germanium phosphate with the boron, proper ratio of the boron. We mix together and melt quench at a certain temperature, like high temperature of 1360, and just immediately poured on the some metal and press it with the another metal plate, And for the final crystallization, we use the temperature from 775 to 850 for the several different time, and we optimize it to get the high conductivity. So here, as I mentioned, we use the different boron content in the ALAGP structure, and this work we have published in the Journal of Our Source, which impact factor is around 8. And we found that with increasing the boron content from 0.05 to 0.4%, the crystallization temperature is get reduced from 630 to 554. So we can say it is acted as centering agent also. And also the crystalline temperature with the boron concentration is also explained the same. So it gets reduces with increasing the boron content. So here is some morphologies of the obtained solid electrolyte without boron, with increasing the boron content at different temperature. So here we found that you can see here, we see clearly the crystal, two crystal with connected with some crystal boundary. And here we have optimized like the boron content with 0.05% and aniline at 825 degrees Celsius shows the better conductivity. I will explain in later on. And we also check the Rex mapping at the grain boundary to check the boron, because here boron mainly segregates along the grain boundary. It does not form any mixed phase in the main grains. It segregates along the main grain boundaries, so which shown by the mapping. Okay, and here is the crystallization conductivity. We measure the ionic conductivity by using the EIS techniques for the different prepared sample, and we found that the sample with the 0.05% and annealed at the 825. Cathode as well as solid electrolyte are both responsible for the failure of the cell after the 35 cycles. Even if we can see after, in case of the EIS, even there is big change in the EIS after the cycling, just 35 cycling. It means the solid electrolyte is not highly stable in directly contact with the lithium metal. So how we can increase the stability? Then this is another question. Yes, we can increase the stability of solid electrolyte. Again, two peaks, it can give to check the boron, because here boron mainly segregates along the grain boundary. It does not form any mixed phase in the main grains. It segregates along the main grain boundaries, so which shown by the mapping. Okay, and here is the crystallization conductivity. We measure the ionic conductivity by using the EIS techniques for the different prepared sample, and we found that the sample with 0.05% and annealed at the 825 degrees Celsius shows the highest conductivity of almost 7 into 10 to minus 4 semi per centimeter at room temperature. So next, the part is the RNS plot. The RNS plot is a plot from where we can calculate the activation energy of the solid electrolyte. The activation energy is important because which will lead into the, if activation energy is lower, we can say the material is good, having a higher conductivity. So if we see the active, this RNS plot show the two slopes, we can say two regions, two linear segment, and this mainly this attributed like to this one segment and another segment, which is mainly attributed to the presence of the secondary phases along the grain boundaries. We also check for the XPS, but in case of the XPS with boron doping, we did not find any extra peaks because of the some amorphous nature of the boron oxide. Because I said it's mainly segregated along the grain boundary and it's having the amorphous nature. So along with the main LAGP phase, there is also, we can find some phase like Li2 and AlPO4, which are the secondary phases and dielectric in nature, which mainly segregates along the grain boundaries and which mainly responsible for lower grain boundary conductivity. So again, we have confirmed the presence of, boron by using the XPS, and we found that the boron is present in the form of LiBO2, and we found that as compared to single phase of boron oxide or the single phase of Li2, the mixed phase of Li2 and boron oxide is having the higher conductivity. So which can lead into the increase in the grain boundary conductivity, because here main motive is to increase the grain boundary conductivity. So what happened after the addition of the boron? When there is just LAGP without the boron, there is a moment of the lithium is restricted by the grain boundary. But when we add boron, most of the lithium easily passes from one grain to another grain. It means, in short, we can say we succeed to increase the grain boundary conductivity and in total conductivity. Because after that, when we looking for any practical application, the stability, especially my purpose was to use this solid electrolyte in the lithium air battery system for aqueous or non-aqueous battery system. So here, this electrolyte, if you can see, this is the solid electrolyte, and it should be water stable as well as fire stable, or it should not catch the fire. So in water stable, why there is a water stable? Because the moisture from the air should prevent to go to the lithium metal side, as well as the electrolyte itself should be water stable to prevent its degradation, as well as in case of the safety issue, it should not catch the fire. So we have also carried out. So we found that this is highly water stable. Even when we just kept in the fire flame, it didn't catch the fire. It means this solid electrolyte is excellent for the purpose of the lithium air battery system to protect the lithium. In addition, also we use this, we tested the stability of the solid electrolyte in different electrolyte, because as I say, we should try this electrolyte from different system, aqueous as well as non-aqueous. So in non-aqueous, we should consider about the alkaline and also acidic condition also. So this we tested in distilled water, lithium nitrate, lithium chloride, lithium hydroxide, and HCl. For like 3 weeks, we have tested its stability in this kind of electrolyte, and we can see the morphology change. In the water, not big change. Lithium nitrate also not big change. Lithium chloride, little surface roughness increase. But in case of the HCl, it's not much stable here. We can see there is a pitting. We can say pitting of the solid electrolyte after the 3 weeks observed. Also, after 3 weeks stability, we also conducted the XRD as well as conductivity to check its stability in terms of the phase as well as the conductivity. So solid electrolyte is unstable in strong acidic and alkaline media, but it can be acceptable in neutral and weak alkaline acidic media. So we observed from this, because with the high SCL or something LiOH, we can see there are a lot of peaks disappeared after the 3 weeks. And the total conductivity of the solid electrolyte was increased by an order after immersion in lithium oxide hydroxide, and HCl. So yeah, so especially in case of the water, the conductivity is not big change after the 3 weeks. But if we going through like HCl or LiOH, it's like decreasing like by 1 order. So the stability is not good in case of the HCl. So now finally we check the stability with the non-aqueous electrolyte, which is the most commonly used electrolyte, non-aqueous electrolyte for the lithium-ion battery. That is electrolyte is LiTFSI TEGDME. So we have checked the stability for 1 week and 3 weeks. So we found the electrolyte, the solid electrolyte is highly stable with this kind of liquid electrolyte, because this liquid solid electrolyte will be directly in contact with this liquid electrolyte, because the system is like this. So one side lithium, solid electrolyte, and then liquid electrolyte, and then cathode. So this is the summarization of the conductivity of the different electrolytes we have tested. Then we have also tested the dynamic stability test of the solid electrolyte with lithium metal, because this solid electrolyte will be in directly contact with the lithium metal. So we have to check the stability in contact with the lithium metal. So here we have is the symmetric system, means both side we have kept the lithium metal, and at the middle we have is the solid electrolyte. So here you can see both side lithium metal and solid electrolyte. We use the symmetric cell. So we have cycled this cell for the several cycles, like 1000 cycles at 0.2 milliampere current density. So, but we found that with the time, if you see after the even 200-300 cycles, the potential slightly continuously goes on increase. And even also we have checked the EIS for this cell after the several cycles, and finally after 1000 cycles. So we found that if you see here, the black one is the initial, red one is the after 200 cycle, and blue one is the after 1000 cycle. It means initial resistance was like 420 ohm, which increases to 620 and 2700 after 200 and 1000 cycle. Means if you see after 1000 cycle from 420 to 2700, it increase. There is increase like 2200 ohm increase in resistance. It means directly in contact with the lithium metal, this solid electrolyte will not be stable. So this is the APSM. After the stability test, we can find there is damage in the solid electrolyte. Okay, so this was the some earlier test, and for practical application, we use this electrolyte directly in the cell, lithium air cell. So if we see here, this we use the coin cell assembly. If we see here, lithium metal and the electrolyte, solid electrolyte, which we prepared in this, is directly in contact with the lithium metal, and then the separator with the liquid electrolyte, which is electrolyte this one, LiTFSI TEGDME, with the separator soaked in it, and cathode, and the oxygen will come inside from this way. And these are the conditions we use. And we found that the cell is run around 35 cycles with a limited capacity mode of 1000 cycles. And after that, it's dead after the 35 cycles. So the reason of the failure of the 35 cycles, to find it, we take again each part of each component of the cell, that is cathode, lithium sulfur, and lithium sulfate, that is anode, and solid electrolyte. So we found that on cathode there is a formation of lithium carbonate, which is the irreversible in nature, and also which is highly resistive. So the main failure of the cathode side is the formation of lithium carbonate, but at the same time we found the solid electrolyte is also not stable. So in this case, cathode as well as solid electrolyte are both responsible for the failure of the cell after the 35 cycles. Even if we can see after, in case of the EIS, even there is big change in the EIS after the cycling, just 35 cycling. It means the solid electrolyte is not highly stable in directly contact with the lithium metal. So how we can increase the stability? Then this is another question. Yes, we can increase the stability of solid electrolyte again by inserting another thin layer, nanometer layer, in between solid electrolyte and lithium metal, which layer is known as lithium phosphorus oxynitride layer, which is highly stable with the lithium metal. Okay, it means now our approach to protect or increase the stability of solid electrolyte in contact with lithium. Okay, no doubt the solid electrolyte is stable with the liquid electrolyte, organic ether-based liquid electrolyte, but we have our main aim to increase the lithium metal stability. So what we have did, we have deposited the lipon layer as another interlayer between the lithium metal and solid electrolyte. To deposit this lithium lipon layer, what we use the physical technique, that is sputtering. Everybody know this RF sputtering physical technique. I will not go in detail. Just we use the I will say here we use the nitrogen plasma to sputter the lithium to deposit the lipon on the substrate. So here we use the solid electrolyte, which is our under investigation. That solid electrolyte we use as a substrate, and we deposit this lipon layer directly on the solid electrolyte. Here we can see the glass, that is solid electrolyte, and lipon deposited layer. So here is the condition to deposit the lipon layer by using the sputtering. So here we can see the cross section on the glass solid electrolyte. You can see this area is nothing but the lipon layer. This area is nothing but the lipon layer on the solid electrolyte. When we took the XPS of this, XRD, this XRD doesn't show any peaks. It means lipon is amorphous in nature, and to check the conductivity in total, like solid electrolyte plus lipon conductivity, we have deposited this lipon layer by using sputtering at different temperature, from room temperature to the higher temperature up to the 400 degrees Celsius. We found that with increasing the temperature, the thickness of the lipon thin is increased. Even we have checked the ionic conductivity. Ionic conductivity is also shows the sample deposited at the 300 degrees Celsius shows the much more better conductivity. How we can say, if this semicircle radius is lower, okay, semicircle radius is lower, it means it can be showing the good ionic conductivity. So here this we can see here this graph, second graph shows the ionic conductivity versus the substrate temperature, as well as on another y-axis the MP ratio, because here the nitrogen to phosphorus ratio is important, because with increasing the nitrogen to phosphorus ratio, it can enhance the ionic conductivity. How, that I will also explain. So with the temperature increasing from 25 to 400 degrees Celsius, we can see the ionic conductivity is also increases because of nitrogen to phosphorus ratio is also increases. It means there is a increasing in the nitrogen content, because I already know we have seen a lot of cases the nitrogen doping enhance the electronic conductivity in some cases. Here the ionic conductivity is also increasing with the nitrogen doping. So nitrogen position or coordination with the lipon we have found we have diagnosed with the temperature. So at 25 degrees Celsius and 400 degrees Celsius, we check the XPS, and we found that if we see in this nitrogen spectrum, one spectrum in light-on thin films, which found around 399.7 at electron volt. And again, if we fitted this peak into the two peaks, it can give the two peaks, in which one peak at like 398.4, which is 398.4, which is mainly coordinated to the doubly coordinated nitrogen, and the triply coordinated nitrogen is at 399.7 electron volt. Here we found that this triple coordination of the nitrogen is much more better for the higher conductivity, and that's why at 400 degrees Celsius, if we see this triple coordination peak area is increased, it means this lead into the higher ionic conductivity of the life-on solid electrolyte structure. And also we have checked the express depth profile of the life-on, express depth profile for the different element, that is lithium, phosphorus, oxygen, nitrogen. And also we check the electrochemical stability of the prepared composite, and we found that there is no leakage. Current was observed between the 0.5 volt, means that within the operating window of the lithium and oxygen batteries, we did not find any leakage current. It means we can easily use this composite in lithium air battery system. Also, after the, as like initial, again we have used the symmetric cell to again check directly in contact with the lithium metal stability of the prepared composite in case of the lithium metal, and we found that here there is no big change in the potential even after 1000 cycles. Even after 1000 cycles, there is no big change in the EIS. It means as compared to the earlier directly in contact with the solid electrolyte, the stability of the solid electrolyte directly in contact with the lithium metal was not good, but after inserting the life-on layer, the stability is increased much more. So we believe that we can. So we believe that we can increase the cycle life when we will use this solid electrolyte directly for the battery application. So there is something wrong. Yeah. So when we use directly in the battery system, when we directly use this in the battery system, it shows earlier here there was only the solid electrolyte. Now we have coated life-on the solid electrolyte, which faces towards the lithium metal. And now if we see with the another same conditions, same catalyst, same lithium, and all this condition was the same. Just we have inserted the lithium life-on layer on the solid electrolyte, and we found that the stability sites result into the 52 cycles, means from 35 cycles to 52 cycles it's increased. So it means the stability is increased and even cycle life is also increased. It means our approach to protect the lithium is worked out very well. So same like after the 52 cycles failure, again we did the post-mortem of the all elements, and we again this check for the cathode and also the solid electrolyte surface, also the lithium surface. So again we found that here on the cathode again there is a formation of the lithium carbonate species, which is irreversible in nature and which is a byproduct of the reactions, and which is irreversible in nature. But if we see for solid electrolyte lithium surface, there is no major change. It means this time for failure of the cell, only cathode is responsible, not the lithium. Because in earlier case, when we use just solid electrolyte, at that time the lithium as well as the cathode was both responsible for this failure. But this time here only the cathode. So if we develop the good cathode for this, then we can increase also the more cycle life. So in conclusion, I will now summarize. The boron oxide is act as a good sintering agent as well as improve the grain boundary conductivity. Also, the secondary phases are much more responsible for the grain boundary conductivity. Also, the lipon layer, which increases the stability of the solid electrolyte in contact with the lithium metal. And when we employ this composite of the solid electrolyte and lipon in battery, it's showing the better performance. And if we want to increase the total in battery performance with high stability, high electrocatalyst, which will show the high stability, or which will minimize the formation of the lithium carbonate species, and the present lithium lipon and solid electrolyte composite, if we use together, we can increase the battery cycle life up to the like 500 cycles also. So presently we are working on that. So these are my academic achievements. These are my collaborators. Thank you for attention. Stay at home and stay safe. Thank you very much.
Okay, now the session is open for the question. You can unmute your mic and ask two questions. Now participant can unmute their mic.
Hello. My name is Dr. Kuldeep Mishra. Hello. Am I audible to you?
Yes.
Oh, yes. I can thank you for this tremendous talk on solid electrolytes for lithium and lithium air batteries. I want to ask one question about the impedance or the bulk resistance of the solid electrolyte after addition of that lipon layer. As in the dynamical state, the dynamical studies you have shown, I mean, I find in a slide that the resistance significantly increased for from 440 or something to around 1000 ohms. Can you comment on that? Uh, I'm asking
Sorry.
about I'm
Yeah.
asking about the impedance increase of, of the reversible cell after deposition of lipon layer.
Yeah. So actually, if we look, the solid electrolyte which we synthesize, the LAGP, its conductivity is in order of 10 raised to minus 4. But in case of the lipon, the advantage is, because always we know everything comes with advantage and disadvantage. The advantage of lipon layer is it's highly stable in case of in contact with lithium, but its conductivity is order of 10 raised to minus 7. So whenever we make the composite, the total conductivity stability is increased, but the total conductivity we try to optimize up to the 10 raised to minus 5.
Okay.
In original, if you just consider only the lipon layer, its conductivity is of 10 raised to minus 7.
Yeah. Okay.
Yeah.
One more question I want to ask you.
Yes.
I mean, you have used boron oxide as amorphous material to
Yeah.
increase the to reduce the grain boundary effect. Okay.
Yes.
Lipon itself is a lithium ion conducting material. It can it can donate lithium ion, and it is
Yes.
amorphous in nature. Can you do the same thing instead of using boron oxide? Can you use lipon as a disperser in that solid electrolyte system?
Yes. Instead of just using the solid electrolyte, if we able to deposit lipon directly on the lithium metal, then we can. But in case of in that case, there are also limitation while we using the sputtering to deposit on the lipon, because there we need highly vacuum system to transfer your lithium to the sputtering system and this kind of things. So
Okay.
this is the main challenge.
Okay. Can we disperse this lipon in our solid electrolyte systems? In that
Sorry.
that LNGP GP, can we use that lipon as a dispersoid in that solid electrolyte system?
Yes, we can.
Uh, that's what you have actually sputtered that you used the thin layer of that. I'm asking
Yes.
about the removal or replacement of boron oxide by that lipon.
No, no, no. It's not possible because the role of the boron oxide is different and the lipon is different. So why we use the boron oxide? It acts as sintering agent. Also, the main purpose was to increase the grain boundary conductivity. With the lipon, that's not possible because specifically we first of all focus on the solid electrolyte. One by one we went on the our final goal. So first of all we increase the solid electrolyte conductivity by increasing the grain boundary conductivity, and then next approach was to protect the lithium because the solid electrolyte was not highly stable in contact with the directly lithium. So again we made another approach to protect the lithium.
One more question is
Yeah,
organizers.
sure.
Uh, do you really bother about the transport number of lithium ion in solid electrolyte?
uh,
Have
in
you
what
ever
sense?
measured that? Have you ever, since for a rechargeable battery, the transport number, transference number is very important for cationic
Yeah,
transport number I'm talking about.
yeah.
So
So
do you anytime measure that?
yeah, so whenever just in case of just if I'm using the only the liquid system, surely there will be high. There will be lithium transfer number will be high because of the ionic conductivity. It's 10 raised to minus 2, 10 raised to minus 3, 2 to 3 order. But in case of the solid electrolyte, the conductivity is lower. But we are looking mainly for safety because in case of the lithium air battery, directly we are taking oxygen from the air. So air doesn't contain only the oxygen; it contains moisture also.
Okay.
So in that sense, or another side, whenever we are using with the purely aqueous system, that time how we can separate the lithium metal from directly in contact with the pure aqueous like lithium hydroxide or lithium chloride and that kind of electrolyte.
Thank you. Thank you so
Yeah,
much.
thank you.
Any more question?
Hello.
Yes,
Hello, sir. My name is Dhanraj. I'm a student.
yes.
I have just small query. Whenever we are charging this battery, at that same time it will give output. It means while discharging, can we recharge this battery?
While
Hello.
you discharging, yeah, you can. While you
I
are
mean,
charging, your question is while you are charging, you can discharge it. Is it?
yeah. I mean, whenever a vehicle is on running on road, at say, actually at that time, vehicle is battery is discharging, right?
Yeah.
So
So
at
in
that
in
time, we
in that case, there is another one concept date of discharge. So you should have minimum amount of charge battery. That time only
okay,
you can discharge, and again same time you can charge.
okay. Thank you,
Okay,
sir.
nice
Yeah,
question.
that's. Yeah.
Hello,
Yes,
hello,
yes, sir.
hello,
Yes, sir.
hello.
I
I
could,
can
Uh,
hear you.
can you add a cobalt ion in the lithium so that it can increase the conductivity, or can it also the stability?
Yes,
Just
there
like
are
you added
some attempts.
boron glass,
Yes,
but
yes, I agree. There are some attempts, those did for not especially cobalt, but silicon or aluminum oxide. This kind of thin layers we can add on the, we can deposit on the lithium metal. But at the same time, as I said, even the deposition of the aluminum oxide or you said the cobalt, any kind of material on the protect lithium is easy. But the same thing is the lithium metal handling is very difficult. So whenever you are
yeah,
depositing or you are handling, you are transporting for the making the cell, that time the total system should be totally inert. And another case, the electrolyte you are using, for example liquid electrolyte, this should be stable in contact with the that material you are depositing, because the purpose it should not form the another secondary phase which will be the harmful.
okay, okay,
That's
okay,
important.
okay. Thank you.
Yeah, thank
Thank
you.
you for your nice lecture.
Oh, thank you very much.
any questions? Again, since nobody have a question, thank you very
Okay,
much,
thank you.
sir. And you
Yeah,
have
thank
a
you.
wonderful lecture, and people are very much satisfied from you. And
Thank
thank
you
you
very
very much
much.
for
And
their quick.
first of all, extremely sorry for bad quality of voice.
Okay.
Okay, thank you.
Okay, thank you very much, sir, for on behalf of my college. I now request to Dr. Anant Vadatkar to introduce our next speaker. Dr. Anant Vadatkar.
Hello, Dr. Prashant. Can you audible me?
You are audible, sir.
Thank you, sir. Thank you. Next invited talk is delivered by Dr. Sandeep Waghule. Dr. Sandeep Waghule presently working as a associate professor in Department of Physics, Sant Galge Baba, Amravati University, Amravati. He has been actively engaged in research since 2002. He is a member of many national and international professional bodies. He has an administrative experience as a coordinator of fabrication laboratory, Fab Lab, during 2012 to 2016, and a coordinator of the patent cell since 2019 of the same university. Dr. Sandeep Waghule has authored 137 plus journal publications with more than 1000 citations and H index. Under his supervision, 6 students have been awarded PhD and 3 are working. Also, he has guided 6 MPhil students. 1 patent is granted to his invention and 2 patents are filed. He has completed individual and group research project. His work has been reported by Journal of Electronic Material, Sensors and Actuators, Materials and Design, Optical Materials, Ceramic International, Material Science in Semiconductor Processing, Material Letters. He has received a prestigious award, Best Researcher Award of Education Expo in 2019, Utkrishta Seva Gaurav Puraskar, that is Best Teacher Award, awarded by SGBAU, Amravati University, Amravati. In 2017, Distinguished Researcher Award in 2017. Also, he has gotten number of awards like FISCA Award in 2012, Elsewhere Reviewed Status Award in 2014, Best Research Paper Presentation in 2015. Interest covers nanocomposite, conducting polymers, sensors, conducting glasses, thin films, quantum dot, carbon-based materials, graphene, nanofluids, photovoltaics, and he has delivered more than 42 expert talk as a resource person. In recent few years, Dr. Waghule's group has developed particle CO2 gas and LPG sensing materials, highly conducting glasses, efficient photovoltaic materials. The work has been published in high impact journals and cited by the number of researchers. So thank you, Dr. Anand Sandeep Waghule. I invite you to deliver the talk. Please, sir. Karat, sir.
Yes, sir.
Thank you, sir. Thank you very much. Yes, this is the topic we have selected for the international conference, WIP conference on advanced materials. Here is held by the Vinayak Vigyan Mahavidyalaya Nandgaon Khandeshwar. And this topic we have to discuss for the innovative ideas for designing advanced materials and the nanomaterials. This is the application of these nanomaterials for the artificial photosynthesis. And these are the different types of the materials. We know about these different types of the materials for the application of these materials that depend on the size of the nanomaterials and other things. Therefore, here, yes, for this, I have shared my PPT. Here, we see about the band gap engineering of nanomaterials for artificial photosynthesis. Means what is the engineering? behind this synthesis of these nanomaterials for this application. And therefore, we see here the nanomaterials, how to prepare or how to synthesize. This is our university on the globe. This is our department, and these are our laboratories. And we have prepared this material in our laboratories. Now, from the introductory part, we have to see here the man behind the nanotechnology, which is a very famous person. All physics people, we are very well familiar with this man, and his name is Richard Feynman. He's got Nobel Prize in 1959, and his a famous statement that is there is plenty of room at the bottom. Means this is a very famous statement at that time also, and today it also means all the physics people are very well known with this person. Now we have to see that the definitions means what is the definition or the introduction about this nanotechnology. This is for the beginners of the research that can carry out their research or are going to carry their research on the nanotechnology. Means the nanotechnology in this word is from the International Conference on the Precision Engineering, which is held at Japan. And from this nanotechnology term is come out, and it is a very popular today, actually. And in this, another definition given by the NASA, that is a creation and functional of the materials, devices, and the system through the control of matter on the nanometer scale. Means this is one of the nanometer scale. We have to take here, there is a 1 to the 100 nanometer actually definitions. Now, what are the nanomaterials? We have to see here the nanomaterials, means these are the properties of nanomaterials. That is nanomaterials having the grain size is of the order of 10 to the power minus 9 meter, and having the extremely large specific area, means volume to surface ratio is also a very important in this case actually. And the structural and non-structural some applications, and stronger and ductile, means chemically very active materials we have to, means the nanomaterials having an improved property as compared to the bulk, means that are called as nanomaterials. And another, these are the examples of the nanomaterials. These are the nanorods, then nanotubes, nanoparticles. Means all these are nanotubes is a best familiar example is a CNT is also there. And these are the many different applications that are shown by these nanomaterials. Now, one of the things here, permeability and potential superplasticity. Then it possesses, means the nanomaterial possesses the high strength, toughness, ductility, means all these extremely large specific surface area, means number of sites is available for the interaction. Then reduce the thermal energy also, then reduce the energy cost, means all these are the benefits of these nanomaterials. Therefore, we have to choose here the nanomaterials for the another application, that is the we have to see here the artificial photosynthesis. This is one of the leading topic of the research here. Therefore, all new researchers should concentrate on this topic. And therefore, this is a preliminary idea what is meant by the nanotechnology. I have talked earlier that the nanomaterials having the properties differ from the those in the bulk materials. Means bulk materials does not show such type of the properties, and therefore the nanomaterials have different properties. Means that is depend on the nanoparticle size. Actually, nanoparticle size. This nanoparticle size we have to also another thing, sir, that is a absorption spectra, that is a optical spectra of this nanomaterials is also different from that of the bulk. Therefore, the size dependence of the absorption spectra arises from the quantum mechanical confinement effect actually, and this effect that is a we will see later on in this slide also. And important properties of these nanomaterials could affect the nanoparticle behavior and toxicity comprises of the particle size, shape, surface properties, aggregation, nanoparticles in the different matrices also. Means all these things we have to improve in the nanoscale. Therefore, one of the thing is that there are the different methods for preparation of the nanostructure materials. We have to see here the nanostructure, and therefore we synthesize the different materials. Therefore, their name they can be shown in a different way, that is the nanoparticles, then nanocomposite, then nanocapsules, nanoporous material. All these things, such as a fullerenes is also buckyball, we have to see here. All these things we can synthesize by using the different techniques. Therefore, they have a very stringent properties shown by this material, just like a nanotubes, then multi-wall carbon nanotubes, then single wall, all these things. And there are the broad methods how to synthesize the nanomaterials. That is, one is a chemical method. Chemical method that include the Soldier technique, then chemical bath, chemical bath method, then CBD we have to see here. Then another technique is Solgel, then aqueous method also we have to see here. Then another is a physical method is also there. Physical method that includes the spray pyrolysis, then PVD. Another is a pulse laser deposition. All these techniques, that can fabricate the nanomaterials. Now, the broad approach means there are the two approaches to synthesize the nanomaterials. That is, one is a bottom-up approach, another is a top-down approach. Means these are the two approach. They can be easily understand from this figure. We have to see here that this top-down method. We have to crush the materials, that is a bulk material that can be converted into the nanomaterial. Means best example is that is a ball mill method is also there. That is a ball mill. This crushing is also there. Grinding, crushing, means all these things, that method that can convert this the top to the down method that contains. Then another method means all the chemical methods are in the bottom-up method. Actually, they can start with the atom or molecules and build up the nanostructure materials. We have to see here the flow chart of these materials. Means these two approaches that can be referred as the top-down. Top-down means it is a bulk material, then converted into the powder material, then powder material converted into the nanomaterials, then there can be converted into the nanomaterial. Means that is nothing but that refers to the slicing, then successive cutting of the bulk material to get the nano size material. And another thing is that the bottom up, that is a bottom up is nothing but we have to see here that the build up of a material from a bottom, that is a atom by atom. Now this is a famous statement of the Richard Feynman. Therefore, we have to see here means both the approaches play a very important role in the modern industry and most likely in the nanotechnology as well. Means, and there are the advantages and some disadvantages to each method. Means there are the number of methods to fabricate these nanomaterials, but the engineering is that depend on, because we have to see here the band gap engineering. This band gap engineering that can be related with that our application today. We have to see here. That is that is artificial photosynthesis. One of the physics behind this nanomaterials is a quantum size effect. There is a quantum size effect that depends. That is a density of the state for the free electron. In statistical mechanics, we have seen here that the density of the state, and therefore that the density of state for the quantum dot, then quantum wire, one-dimensional, then quantum wheel, just like a particle in box, there is bulk material having the like this. Means all these things, and all these are related with that energy. Means that is the energy, means the minimum smallest energy we have to see here for the formation of this electron hole pair. And by using this formula, we have to see here the same nanomaterial showing the different absorptions. Means for the different absorption in case of the UV. Means that is the electronic absorption spectrum of the nanomaterials that depend on the particle size. Means the particle size important properties that affect the nanoparticle behavior. Means all these are the things we have to see here, and therefore this UV means spectra we have to take here to find out this particle size of these nanomaterials. Then we will go to our application, that is artificial photosynthesis. This is actually biophysics application. We have to see here the biophysics application because some biological but botanical actually the botanical applications we have to take here, and that is related with that of the nanomaterials in our physics subject. That is artificial photosynthesis is nothing but the rapidly developing, yes, it is nothing but the artificial technique to mimicking. Mimicking is nothing but the replication process of the natural photosynthesis by using the solar energy to release the hydrogen from the water. Means therefore, this technique is a very developing branch of the interdisciplinary sciences, and we have to choose here this topic for this presentation in this international conference, and therefore this is a very important or leading topic for the researchers. Now we have to see here that the carbon dioxide, what is the carbon dioxide, what is the role of the carbon dioxide in our artificial photosynthesis, that can provide the solution for reducing this carbon dioxide in the solar fuel. Another thing, that is, therefore there is a very interesting factor we have to see here, and I have read this paper in the Nano Letters. This paper contains the nanostructures in the artificial photosynthesis that enable the fundamental process occur in the natural photosynthesis, one of which the light harvesting. That is just like a light antenna is also there. That is a light harvesting, and therefore this light phenomena and therefore absorption of this light is very important. And this absorption of the light that depend on the synthesis of the nanomaterials. Therefore, we have to take here the synthesis of the nanomaterials is a major role for the artificial photosynthesis. Now, we have in previous slide we have to show that the hydrogen plays a very important role. That is, the generation of the hydrogen has strong potential to use this various process, just like a fuel cell, hydrogen base, means all these things. And in case of the artificial photosynthesis, it is a very fastidious. That is, a working of individual components are reported in the literature. We have to see here. This is the literature. That is the Journal of Agriculture, Food Chemistry, and this is very well explained in this researchers. Another thing, the plant pigment. That is the botanical idea of the thing. These are the potential candidate. Potential candidate means the zirconium, because the zirconium is applicable for the gas sensing applications, means another applications in our electronic part. And zirconium is also one of the best of the candidate, and it is also a biocompatible. That's why we have to choose this material. And another thing is that the copper sulfide. This copper sulfide, we have to see that the copper sulfide is a material that can be used in many applications of some supercapacitor materials. We have to use then copper sulfide for the photovoltaic cell. We have to use these materials. Therefore, the absorption of this material is very good, and we have to use this material for the band gap engineering. And therefore, the band gap engineering, we have to show that here this material for the photosynthesis. Now, this material, that is a research work behind that, is that this material, that is a zirconium and copper sulfide material, they can play the role of the tyrosine, then histidine and tryptophan metabolites in artificial photosynthesis, because we have to prepare this material for the different absorption scale. And therefore, these nanomaterials, there is one engineering, we have to call it as engineering, and we have to one method. We have to prepare only the temperature, is the annealing temperature we have to see here, and therefore the band gap engineering high annealing temperature we have to use here to synthesize this material. And just as the zirconium nanoparticles, we have to prepare in our laboratory from the zirconium nitrate and HMT, hexamethylene tetramine, we have to use. And this is the one of the step, that is a 1 mole solution we have to take in our double distilled water, and we have to mix this hexamethylene tetramine dropwise, and therefore we have to get the precipitate of the zirconia, and it is collected at the bottom. And this is a very simple method, or it is we have to call this method as a one pot synthesis method is also. And therefore new beginners or the new researchers should concentrate this such type of the research, how to synthesize these nanomaterials, and it is very easy. Now, another, these are the vacuum filtration, means all these things are related with this, and therefore the product is like this. Now the figure shows this product of the ZR2 nano particles here. Now the similar way, the copper sulfide nanomaterials we have to use, but here we have to use the nitrate form of this copper material, and another is the sodium sulfide, and both of the things we have to take in the 1 mole solution, and we have to use here the distilled water, and this is a very preparation method. This is a detailed method we have to see here. That is, one of the thing is that the temperature means we have to prepare this material by using the spray pyrolysis setup. That is, a spray pyrolysis having a substrate temperature varies from the 150 degree to the 300 degree, and this is a very important part of the temperature, because in nanomaterial high temperature may occur the agglomeration. Therefore, we have not get the prepared size, because some chemical methods are very difficult to control the size of the nanomaterial actually, and therefore the temperature is very. This is one of the our research is published in Material Science in Semiconductor Processing Elsevier journal, and this is also a band gap engineering of the CUS nanomaterials we have to prepare this material. Here CUS we prepared by using the spray pyrolysis technique. It is this technique is also very simple technique, spray pyrolysis. Another thing is that this we have to use the band gap engineering, and then we get the nanomaterials of the different sizes here and different absorption. They have got the very, and these materials we have to characterize, means how to synthesize, means how to take these nanomaterials, means we can characterize these materials by using the XRD. We have to take here the XRD analysis. This is a very simple analysis and the available analysis. This is a very primarily analysis to analyze the nanomaterials actually. Therefore, we take, and this is a very famous formula to calculate the average grain size from this of the nanomaterials here. Now, the same microscopy we have to use here for the what is the shape of this material of nanomaterial. Therefore, we have to use. Then another is the important property is the UV, that is spectroscopy. That is in case of the optical properties, and optical properties is based on the Beer-Lambert law. We have to see here. And another thing is that by using this UV spectrum, we have to show that the different bonding also is there. Means stretching vibrations and bending vibrations is also there. Means we have to calculate it. Now in our research, now the research is related to our zirconia. This is a zirconia, and this XRD is clearly shows that if we go through the 300 degrees centigrade, then 350, then 400, then 450, means if we increase the temperature from 50 degree, then the XRD pattern shows that is we have to get the different sizing materials, means the materials that are showing that the different size, that is a correcting matching. Means if we match this material, means the particle size increase as a function of the annealing temperature actually, and this may due to the increase in the temperature actually, means the temperature that this is also a band gap engineering actually. Band gap engineering means the size is different, then yes, its band gap is different. Therefore, we have to use a different temperature for annealing temperature, and particle size is estimated from this, and particle size we have to obtain in the range of the 22 to the 27 nanometer, in the range of this for the zirconium nanoparticles, and therefore in this way another means similar way we have to annul this CO and this CUS means material, that is a copper sulfide material, that are also show the strong and the sharp diffraction peak here. This XRD pattern also shows for the different temperature, we have to show that the degree of crystallization increases, means that can crystallization increases with the temperature. Then another is thing that there is a hypothesis for the mechanism of CO formation from the COS standby at the elevated temperature that can be proposed by the some researcher. Therefore, we have to see here also.
in similar way. That is a, and there are some weak peaks that are shown in this XRD analysis that can be ascribed to the CEO, means formation of the CEO on the CVS surface. Means some peaks are shown here. These are some is in chemical methods. There are also some some impurities also is there, and therefore we have to say not clear, not purely synthesize the material. But in this application, we have to see here the only the is their band gap, different band gap, means at a different temperature. Therefore, we have to obtain this material and different from ranging from the 21 nanometer to the 37 nanometer. Means as the different temperature, we have to see here the different temperature treatment we have given to the material, then material we have to obtain as a different nanometer size. Means this is one of the technique how to prepare the material of a different size material with the temperature treatment. Actually, these are the same photographs. The same photographs also very well that is a that can very well reflect in the XRD spectroscopy. Then XRD analysis in this, that is the increase in particle size may be due to the annealing. Means this shows that they are the annealing temperature. Means this is a 300, then this is 350, then 400, 450. Means from this same micrograph, it is clearly shown that the particle size increases. Particle size increases with the annealing temperature. Now another photograph of this same image is of the CO. Is also it is clearly shown that the particle size increases with this CVS nanoparticles. Particle size increases. Means in this way, the particle size of the nanomaterials increases with that of the annealing temperature. It is a very simple technique to increase the particle size. Means we have to prepare the materials with the different particle size. Now this is a UV-Vis analysis. Actually, in UV-Vis analysis also that shows the absorption till around 221 to 232 nanometer. Means here we have to show this. Means this shows that the annealing temperature increases. That is the absorption tail shows the red shift. Actually, it is shifted to the red side, and therefore the particle size increases with the annealing. Means this is also a confirmed on this and the band gap decreasing. Band gap decreasing, this is a very mechanism we have to represent in a graphical abstract also, conduction band and valence band, and it decreases with the increase in the annealing temperature. Now here where particle size and band gap is inversely correlated with each other actually, and therefore they can be supported by the hyperbolic band model and effective mass approximation. Means this is one of the things. Now we have to show that this is the absorption tail. In case of this, that is one of the in zirconia particle that are 221 to 232 nanometer scale. We have to take here the UV synthesis, and therefore the UV absorption material we have to obtain in the range of the 200 to the 250, in the range of the 200 to the 250 nanometer scale actually, and therefore this material is useful. Means this is a replacement of the tyrosine, histidine, and for CVS, this is for the light gathering antenna. This material can be work as a light gathering antenna for the artificial photosynthesis. We have to call it as a light harvesting antenna in the leaf for the artificial photosynthesis. Therefore, if we apply these nanomaterials to some plant or some another some biological, we can call it as some botanical plantations, then this is one of the application, means most important application for the artificial photosynthesis. Means this is a very need, today's need, because some plant are there in our home is also there. If we use this such type of the nanoparticles, then the plant without sun they can live. Therefore, we have to use this such type of the nanomaterials for the plantation. Now, one of the we summarize our work here. We prepared in our laboratory that is very successfully, that is a zirconium and copper sulfide nanoparticle with the band gap engineering of the different sizes and different UV absorption spectra. Therefore, we have to made these nanoparticles which have absorption spectra in the range of the 221 to 232, means in the range of this biological entity. And in the similar way, the serious nanoparticles we have to obtain is both. If we use also our another research is also about the composite materials, that is a ZrO2 and CUS materials, and these materials we have to use here for the composite. Then we have to apply for this material. Therefore, this study for the further development of ZrO2 and CUS means we will go through the composite of the material, and another some new materials we have to added in these materials. Therefore, we have to get the another improved application. An improved application actually in the improved application in the artificial photosynthesis actually, and therefore this is currently underway in our laboratory. This is one of our research that is having new applications. In our research, we have also taken the application just like a gas sensing applications of materials, then photovoltaic, then supercapacitor applications, then some conducting polymer, then some conducting polymer. They can be applied for the some applications of the antibacterial polymer, antibacterial paper, then antibacterial some cellulose is also there. Means we have to take. Now, one of the achievement in our laboratory is our patent granted in the last year. That is on the graphene. That is, graphene is a carbonious form, and therefore we have to make the graphene paste. And for this process, we have to granted the one patent. Therefore, our research group having a great achievement in the last year. This one of the paper is recently is published in a Iranian polymer journal. This is our research papers published in a elsewhere journal actually, and reputed journals. This is a Spinger journal. One of the applications we have to take here that the conducting polythiophene. This is a conducting polymer material. One of the photovoltaic properties, copper sulfide materials here in this paper, we have to taken one of the application that is a photovoltaic application for this same material, that is a copper sulfide material. In this, we have to take the materials of the different band gap size, and we have to use for the means it is in the range of the artificial photosynthesis, but actually we have to apply for these materials for the botanical applications. Then this is one of the application, that is a sensing application we have to taken for this, and this publication is published in material letters. Then photovoltaic of ZNS material. Means different types of the materials we have to prepare in our laboratory. Some polymeric material, then nano composite materials, polymer composites. This is author Scopus preview for this publication. Then this is a Google Scholar citation. Another thing is a Web of Science, and I am very much thankful to our Honorable Vice Chancellor for providing the necessary facilities in our laboratory, and also I am very much thankful to the organizers of this international conference, Dr. Alka Bise Madam, Dr. Suchita Khodke Madam, then organizing secretary Dr. Ananta Vodatkar sir, then convener of this conference Dr. Prashant Khat sir, then co-convener of this conference, Mr. Ajay Ambore. Means all these are the organizers. I am very much thankful for the providing the platform to present such type of the research. Thank you very much. this is my contact, and if any interesting students, then call me on this mobile number, also related to this research. And this research topic is open for the discussion, and suggestions related to this topic is always welcome. Thank you very much.
Now participant can allow to unmute them and ask questions. Over to Bharat sir.
Yeah.
Question is open for the question.
Gauss sir.
Very excellent presentation as expected.
Yeah. Thank you, sir.
सर अनम्यूट करा माइक से पहले जादू सर
ओके
माइक अनम्यूट करा नाही तुमचा ऑन केम जाऊ सर बोल सर जादू सर तुमचा माइक म्यूट आहे सर माइक म्यूट आहे सर Any questions?
This research topic is a very simple, sir. This is for the new faculty recently joined in their college. Hello, and they will start their research. Yeah.
3, 2, 1, don't.
Hello.
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 Sir.
It was a very nice lecture, wonderful lecture.
Thank you,
sir.
It is
related to the nanomaterial, but the application point of view of the nanomaterial, you have shown the new direction. That is the artificial photosynthesis, on which very few researchers are working, I think so.
Okay.
You in your work, you have shown the zirconium oxide was used as a material for artificial synthesis. In similar way, can you use the TiO2 or ZNO, which may have the very good band gap, and that can be used for the artificial photosynthesis? This is my question to you.
Yeah, sir. Thank you, sir. Sir, ZNO and TiO2. ZNO is slightly having a difficult to control the band gap of this ZNO. Therefore, TiO2 is very easy to synthesize also, and it is easy to control. But these are some hazardous materials somewhat. But in some medical literature survey, it is reported that the ZNO and TiO2 is a biocompatible actually. Therefore, at a smaller scale, we can use to the plants also for application, direct application. Yeah. Therefore, we may use this TiO2 also and ZNO for the artificial photosynthesis.
Okay, sir. Okay. Thank you.
Any other questions? Okay. No question from the participants. Thank you very much.
Okay, sir. Thank you, sir.
Lecture. You have nicely covered the all things of related to materials and polymers also. So it's time to welcome our last speaker, Dr. Prashanta Ghosh. Dr. Prashanta Ghosh is he's done his PhD from Aurangabad, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. Now currently he is working in the Vishwa Shanti University, Pune, and I request to him to deliver his talk.
Hello course from School of Physics, MIT, World Peace University, Pune. I conduct research mainly on nanomaterials-based chemical sensors and electronics devices. I am appreciating Vinayak Vigyan Mahavidyalaya for arranging this web conference, and also thankful to the organizing committee members for inviting me to deliver my thoughts and experiences on nanomaterials-based sensors, especially on gas sensors. Now, we science and technology peoples playing the key role in development. Day by day, we are improving the technologies through research for the betterment of society. Now, even during this COVID-19 issue and this lockdown period, due to science and technology only, I am able to share my thoughts through this platform. Now, let us see how nanomaterials could ensure for a better health and better life, and especially on gas sensing field. Now, let us see. Environmental pollutants are a major global concern as they threaten our safety and economic stability. As a result, on-site, low-cost and reliable monitoring is becoming essential. The research of environmental gas sensors started since 1960s. Research on gas sensors and materials expanded exponentially in the last 60 years. Several research papers were published to claim suitable gas sensors. There is an enormous number of sensors available for monitoring toxic gases. However, most of them are expensive, need pretreatment, have difficult operation and slow response, and do not have the ideal limit of detection, sensitivity, and selectivity. Since the discovery of electron microscope, nanomaterials and nanotechnology have been influencing academic and industrial research greatly, bringing out newer and better products with improved materials. In the field of environmental gas sensors too, the demonstration of nanomaterials for sensing various gases has become a common practice. On the perspective to improve the parameters, nanotechnology has sponsored the most promising upgrade on materials properties, providing significant advances to overcome limitations once experienced by conventional materials. Now, these are my acknowledgements, and my special acknowledgements to our mentor, Professor Dr. Mahendra D. Sirsat from Department of Physics, Dr. Baba Saheb Ambedkar, Marthwada University, Aurangabad. And also my sincere acknowledgements to my fellow researchers, Dr. Kunal Datta and Dr. Aarti Rusi. Human beings are considered to be the highest intelligent class among living creatures, and automatically the term development comes as a prime responsibility of them. But unfortunately, the pace and demands of development often overshadow the concerns for nature, and such acts have put the environmental condition of planet Earth in great peril. The condition of landmass, water, and air have become a serious matter of concern today. Among these, the air pollution is needed to be dealt with highest priority since it is the most obvious requirement for life, and question of mass scale air quality treatment as on today seems impossible. As a matter of fact, almost 96% of environmental pollutants are in gaseous form, and many of such pollutants can be highly pernicious to human health, even at trace amount of presence. Now, the source for the air pollution we know very well, and you can see the statistical figure of the for that sources of pollution, mainly the air pollution. The cars and mainly gasoline-powered cars and trucks having the major portion, 42%. Aircraft, trains, those are having that 16%. And natural sources are also there. On the main phases, the fast-moving development in urbanization, often unplanned. By 2030, all the world's developing regions, including Africa, will have more people living in cities than in rural areas. And between 2010 to 2015, the world's urban population is expected to grow by 3 billion people. A rough figure mainly. That is the world's total population in 1950. Now, such trends are mostly driven by changing socio-economic policies and heavy industrialization that generates tremendous human resources opportunity in cities. And setting up new industries needs space and immediate effect in deforestation. Now, a city's demand for original resources places strain on ecosystems hundreds or even thousands of miles distance. Now, for this, the global climate change adds to the mix of problems, increasing coastal flooding risk for low-lying cities, exacerbating urban heat island effects, and increasing the frequency of heat wave-related mass fatalities. Now, this figure is more pertinent in economically developing and or underdeveloped countries due to easy availability of low-cost resources, including manpower. General awareness of mass population in this sector is generally low, and that enhances the threat of some ultimate calamity. Now, from this figure, that is that this data has taken mainly from State of Environment Report India. Okay, that is mainly from Ministry of Environment. We have taken this data. You can see that 60% of diseases. You can see 60% of almost diseases associated with respiratory infections that are linked to exposure to air pollutions. Outdoor pollutants such as sulfur dioxide, ozone, nitrogen oxide, carbon monoxide, and volatile organic compounds came from mainly vehicle exhaust, power plant emissions, open burning of solid waste, etc. These are the health effects of pollution. As a pictorial view, you can see. These are the pollution report of selected Indian cities, and you can see the levels. It is quite high for Bangalore, Pune, Hyderabad. I have not taken all the cities. I have taken the major cities. Okay, and you can see the level is very high. And the indoor pollution, the death rate across the world, you can see. India having near the 400 to 600. You can see. The death rate. Now, all these are not only by man-made resources or reasons, but natural sources also add up to the pollution contents in air. Now, one thing is for sure that the above that we are needed to be convinced about the air we breathe. It is the limitation of our olfactory system that it cannot detect most of pollutants and more profusely. We get used with many of hazardous pollutants in our day-to-day life. For example, like exhaust from motor vehicles contains several highly poisonous elements like SO2, CO, methane, etc. However, urban livelihood is adjusted to it. It is sheer ignorance of large mass of population that keeps them unknown of the fact that many of such gases have slow poisoning or carcinogenic effects on long time exposure. Similarly, most of the factory workers do have no idea on terminologies like PEL, permissible exhaust limit, or IDLH, immediately dangerous of life or health. So it is our duty that we need an immediate step to save ourselves from the menace of air pollution. Is it to create awareness and should have some solution. So these are the such solutions. Perhaps not, because these are not a smart solution. We need some reliable sensing devices that should detect the pollution level. But those devices have high cost or less selective or require some conditions like or processes, long-term process is not real-time time. So we need some device that are low cost, durable, easy operable gadgets. That kind of thing we need. Reliability factor of such device should be unquestionable. And some modern electronic integration and microfabrication technology is quite able to provide highly sophisticated and precision hardware platform for this device to come to reality. However, all such technologies fails to serve unless they are equipped with smart materials that are sensitive towards a particular or at least a group of gases and analytes. And these materials are commonly termed as gas sensors across the globe. Millions of researchers are making it hard to come up with sensors that can provide target-oriented outcomes. Plenty of mysteries remain unfold in this area, and sensor research efforts continue the call of the day. Now, what is a sensor? A sensor is a device that can interpret some physical or chemical change in terms of signal that can be easily understood and output in the form of electrical signal, in generally short for since it is easier for an electrical signal to be further analyzed, processed and stored. Now from this figure you can see the press sensing element can respond to change of several physical conditions with several physical inputs. Now, physical or chemical, not only physical. Okay, and in this idealized case, it is shown that the signal output is electrical in type. You can see a signal conditioning level takes care of amplification, attenuation, or resetting of the sensor. The signal conditioning sector. And in actual sensing platform, sensing application, the stage plays the crucial role, this signal conditioning part and the sensor part. Okay, and now in the last, this is the actual figure of the sensor. This is the ideal sensor card, and you can see this is the baseline, this is the rise time, there is a saturation point, and we can say this is the sensor response, means topmost response for a particular analyte for a particular concentration. Like it's 50 ppm up to this sensor response. If it is 10 ppm, that must be lesser than this level, the top level. If it is 100 ppm, it will be more than this level, higher than this level. And when we just taken away the gas from this sensor, that should be came out the signal to the down and at the same level of the baseline. That should be the signal of ideal sensor. But in general, that is very critical to achieve this kind of sensor that have full recovery. That means it will came to the base level after just taking off the gas from that sensor. So it is also a challenge. Second thing, this shows the response time from baseline to the topmost sensing response. or sensor's response. There is a response time. And from that point, when we just switch off the gas or we just keep the gas from the sensor, it should be came to its baseline at this time. From this top to the again to its zero level or its from appropriate level is the recovery time. Now, for ideal sensor, the response time and recovery time both should be very short. If it is in a few seconds, then it is a very good sensor. If it is in taking minutes, then it is not good. Or if it is an hour, it is not at all usable for real-time sensing. So there's a lots of the challenges there for a ideal sensor that need a full recovery type of sensor, that need a very short response time and recovery time, and their response should be high. That means for a small amount of gas, that should show a high response current or high response resistance. Now, these are some characteristic of the ideal sensor that we can see. The ideal sensor should be highly sensitive, portable, precise and accurate, low power consumption, durable, mass fabrication should be possible, and it should be user friendly. That is the characteristic of an ideal sensor that require mainly. Now, there are lots of sensor categories like chem register, chem fate, ampermetric, thermistor, pilistor, optomes, and piezoelectric type. But we are working mainly on chem register and chem fate type of sensors. Now, among chem fate and chem register, chem fate have very much advanced capabilities when it comes to low detection of any analyte. When we are detecting a very small amount of analyte, we can get or we will get a very small signal that could be in pico level or in nano level. Now we know that for pico ampere current or pico volt, we cannot detect with our readily available multimeters or readily available any measuring devices. For that, we need some special type of measuring instrument. So we know that the cost of those instruments are in lakhs. So that is also a not a characteristic for a good sensor. That's why we have used chem fate type of sensor where the low level signals can amplify through gate modulation. Yes, we can modulate or we can enhance the signal through internal gate voltage. We will see in later onwards. Now, why nanosensor? Irrespective of any sensing material or modality, the recent scenario of sensor science and technology shows unquestionable influence of nanotechnology. Versatility of technology for synthesis of one-dimensional structure of conducting polymers or metal oxides have literally redefined the concepts developed in the era of two-dimensional gas sensors and thin film-based gas sensors mainly. This new generation of sensors would be characterized with excellent sensitivity, highly improved response and recovery characteristic, and most intensively, analytes are now under scanner at extremely low concentration of presence. In contrast with thin film-based polymeric or metal oxide sensors, their one-dimensional counterparts are generally capable of detecting a wide spectrum of analytes at ppb level of concentration. And present stature of microfabrication technology at the same time allows facile integration of this ultra-low dimensional structure, often leading to high-density sensor array that can be well applied for complex sensing applications. Now, for the one-dimensional structure, I have some special reasons for particular gas sensing application. That are mainly that they have multifold mainly. That overall sensor performance enhancement is possible with this kind of structure, one-dimensional structure, instead of certain trade-off between sensor performance parameter as with conventional structures. Low cross-sectional area of these nanostructures offer less scattering, thereby efficient motion of charge carriers along them,
This characteristics renders betterment in response behavior of sensor. At the same time, due to ultra high aspect ratio, one-dimensional structure are extremely sensitive to even slight perturbation in surrounding environment. And the dpi length of one-dimensional structure is comparable to the diameter of the nanowires that allows charged absorbance to have a strong influence on charge carrier transport. Where in two-dimensional structure, the charge depletion or accumulation is purely a surface phenomena. While in one-dimensional structure, fast and complete depletion of charge into the bulk of structure takes place, resulting in most profound effect on its electrical, electronics, and conformational properties. Now, the dpi length in case of one-dimensional structure is comparable to the diameter of the nanowire that allows charged absorbers to have a strong influence on charge carrier transport. And this one-dimensional geometries also enhance response time by virtue of their two-dimensional profile. Now, from commercial point of view, low footprints and low power consumption for nanomaterials create excellent platform for handheld portable gadgets. Now, keeping in the view the fast pace of growing complexity in environmental condition, the foremost sector of sensor science and technology has been multifold pursuits toward novel sensing materials with uncompromising sensing capabilities. Now, the question of selectivity has been the highest point of concern for all research and commercial efforts. Environmental stability and repeatable performance are other aspects of paramount importance when reliable sensing is a prime factor. Now, sensor technology shows that mammoth research in being carried out with carbon nanotube-based sensor because it has low cross-sectional dimension of carbon nanotube allows all the atoms to be present on the surface of nanotubes and thereby are susceptible to even slight perturbation of environmental conditions. Also, the room temperature operability of carbon nanotubes along with excellent environmental stability, superior mechanical and electrical properties have rendered them as highly potent sensing material. But difficulty for both processing and complex fabrication platforms stands as a barrier toward commercialized success of CNT-based sensors. Whereas conducting polymer that is also a highly explored material for sensing application offer extreme flexibility and processability along with room temperature sensitivity to a large spectrum of analytes. The tunable electronic or electrical properties of conducting polymers offer requisite optimization of sensor backbone. However, these materials are quite vulnerable to presence of humidity and oxidation effects. Now, till date, the most commercial successful sensing backbone is the metal oxides. These metal oxide sensors are robust in nature, can be easily fabricated on simple substrate by low-cost technique, and research findings can be implemented easily even with batch processing of sensing materials. But this spectacular characteristic of metal oxide are well challenged by the requirement of high temperature for operation of the sensors. High power requirement for metal oxide based sensors device hampers the portability. For that kind of metal oxide sensors, we need a heater. That is an additional component for that gadget. Now, it is evident that these three parliamentary sensing backbones have their inherent advantages and disadvantages as well. However, a common hurdle, as already mentioned, is the inability of these materials toward absolute screening of any particular analyte. Now, from this perspective, CNTs and CPs conducting polymers are finding an edge as they could be employed in a wide variety of sensing modalities, and it is easier to modify them chemically also. So now in our discussion, we will go for CNT and CP based, or mainly CNT CP composite based sensors. You can see from this table that metal oxide, although has high sensitivity and retentivity and easy for construction mechanism, but it is lack of, for this power consumption is lagging, and selectivity, some cases we can see the selectivity also having lacuna in metal oxide semiconductor, not all the cases. Whereas conducting polymer, the main drawback is the sensitivity. And for CNT based sensor, its main drawback is for selectivity and retentivity. Retentivity means recovery. So we will go for conducting polymer and CNT based sensor, and we will see. Now, what are the advantages aspects of CNT based gas sensors? Due to the curvature of carbon graphene sheet in nanotubes, the electron clouds are distorted and rich pi electron conjugation forms outside the tube, making the surface of CNT electrochemically active. Just a minute. Yeah, these surfaces. And the high aspect ratio of CNT enable them to act as molecular wires. And excellent thermal, mechanical and electrical properties that makes the CNT to work in a harsh condition or harsh environmental condition like industrial applications or in application in high temperature area for sensing. But having some disadvantages that we have already discussed. Dearth of efficient methodology for incorporation of SW20 in sensor metrics due to their size. For that we need some sophisticated instrument. Also some sophisticated instruments having a high cost. It needs around, I think, if you want to work with CNT, we need a SEM machine, AFM machine, we need a probe station or something like that to work with this. Those all are costing in lakhs. Having poor selectivity due to the limited transduction mechanism employed, poor sensitivity because some analytes, those they have low affinity, this is not detecting by CNT, and poor recovery due to the high specific surface area contribution of CNT and this binding of the analytes in CNT, and also due to the honeycomb structure of the CNT that traps the gas molecules inside it. Now, so where conducting polymer is concerned, as a gas sensor, the chemical interaction between an organic polymer with a gaseous molecule can change the polymer's electrical, electronic, and structural characteristics. Three different kind of changes can occur with the interaction with gaseous molecules, but resulting mainly in electrical response that could be easily detectable. And during polymerization process, different supporting electrolyte, if we can add, that can be employed to tune the affinity of the conducting polymer for a particular analyte that could be beneficial for selectivity purpose. Now, electrical conductivity of conducting polymer material that also can be easily modulated by oxidative or reducing doping to some optimum level so that the valence and conduction band edges in the conducting polymer material are efficiently modulated by gaseous analytes. We cannot make it like a conductor. We should make a semiconductor because there should be some gap between valence and conduction bands that could be operatable by the gaseous molecules. But now, although the conducting polymer have lots of the advantages, but it has some disadvantages. That number one, that poor lifetime, low electrochemical activity, and hysteresis. Now, if we can combine this SW20 and conducting polymer, because both having some drawbacks and some advantages. Now, if you can add both this material, that could enhance sensitivity, selectivity, response time, and recovery time. You can add by some non-covalent mode or by functionalization mode. Now, functional structure or composite structure, CNTCP, having this kind of advantages. Low cost, because if we use entirely carbon nanotube, so we know the cost of carbon nanotube. So if you can mix with conducting polymer, definitely cost will be reduced. Site-specific functionalization can be possible with this modality. Simple preparation with electrochemical type of preparation or chemical route we also can do. But we have done electrochemical route. High throughput, ability to functionalize various materials, ability to tailor the morphology and electrical properties, and fabrication of high density nanosensor arrays. Nanosensor arrays, in a small chip we can incorporate 16 different type of sensors for different gases, or 20 or 30 according to the requirement we can incorporate. These are the effects combination. Also, that CNT can act as templateless for polymerization of conducting polymer. That means that rendering the high aspect ratio of structure of polymers. So we know that polymer nanowire size in diameter around 100 to 200 or 300 nanometers. But if we use carbon nanotube or SWNT acts as a template for this polymerization, then polymer will grow along the surface of the SWNT and size will be reduced of the nanowire. Second, conducting polymers wrap up whole surface of SCNT by pi stacking, because this honeycomb structure of SWNT are not open to analytes. Because we know this honeycomb structure, if it's open to analytes, then it will absorb the analyte, it will trap. So recovery will be very poor. So we can see from this animation how this pi conjugation is possible. This is the structure of conducting polymer, and this is the bending structure of carbon nanotube. Now, if we make composite, this carbon nanotube will be wrapped by conducting polymer through this pi delocalization, and we will have a high density pi conducting polymer pi SWNT delocalization sectors sites. Also, the charge transport complex is formed and electrochemically active of conducting polymer increases due to this, because due to this pi conjugation, that we know that carbon nanotube have very high electrochemical activity, and if it's added with the conducting polymer surface, then this property could enhance. Conducting polymer library and chemistry is rich for the purpose of selectivity, because that is the main drawback in SWNT based gas sensor, that selectivity. For that, we know that polymer have a highly selective to analytes, particular analytes, and that could be tuned by adding some different dopants on conducting polymer. So it could enhance the selectivity of SWNT based sensor. Now we are going to discuss on one of our earlier investigation, that is on the effect of the polymeric component in deciding selective behavior of SWNT polymer composite based sensor. Here, formation of composite with SWNT had been carried out with two different polymers, one in polyotoluidine, POT, and another is poly N methyl pyrrole, PNMP. And the same were applied for sensing of the ammonia. Ammonia was particularly chosen since, as an efficient electron donor, it could be a justified probe towards proper understanding of the sensing mechanism. POT and PNMP both are well explored derivatives of polyaniline and polypyrrole, and suitable for sensing applications because of their environmental stability. Our finding suggests that the chemical structure of polymer can be instrumental in shaping the selective properties of fabricated sensor. And we have also incorporated the Fe nanoparticle on SWNT PNMP based composite nanowire, because we have earlier seen that Fe nanoparticle have a great selectivity towards ammonia. So to improve the selectivity nature of the particular sensing backbone, polyaniline and SWNT based structure, we have incorporated Fe nanoparticle on the PNMP structure, because we have seen later on that PNMP and SWNT have the better result than PNMP, SWNT and POT. Now, this is the structural aspect of two polymers, and we can see that one is having amine group, that is PNMP, POT, that is pure toluidine, It is having amine group and also methyl group that has two substitutions. And whereas for poly and methyl parol, there is only have the one substitute, methyl group. And we know that that amine group is one of the strongest electron donating substituents. And electron donating substituents increase the electron density on the parent ring that we know. Now, this is our sensing platform that was utilized in all our three cases, is POT and SWNT based sensor, PNMP and SWNT based sensor, and PNMP SWNT FE decorated sensor. Where AU microelectrodes, you can see in picture that AU microelectrode patterns on highly doped P silicon substrate. Briefly, a 3 nanometer thick SiO2 layer was first deposited on the substrate by low pressure chemical vapor deposition, followed by formation of chromium and then gold. Chromium having the 80 nanometer thickness and gold has 120 nanometer by standard lift-off technique. The width and gap of the electrode were fixed at 200 micrometer and 3 micron. Respectively. The micropattern substrates were immersed in piranha solution, followed by rinsing and drying under nitrogen flow before use. This is the actual picture of that electrode, and you can see the diameters. This is a microscope image we have taken at our laboratory. And you can see we have covered the rest area, and we have only kept open only in this area for our research purpose or for polymerization purpose, and that area is around 39,154 micrometer square. It is the main effective area. Now we are going to discuss about sensor fabrication, how we have fabricated the sensor platform. Now, carboxylated SWNTs, means CWH functionalized SWNTs, pre-functionalized, were dispersed under ultrasonic agitation in 2 microliter HPLC grade water for 2 hours at a concentration of 0.035 milligram per milliliter to obtain a homogeneous suspension of SWNT. Then O-toluidine or N-methyl pyrrole in the separate cases were further separately added to the SWNT suspension at concentration of 0.25 molar each. Individual suspensions were kept under stirring for 24 hours under normal laboratory condition to obtain the final form of electrolyte. For electrochemical synthesis of SWNT polymer composite nanowire matrix between the 3 micron gap, that AU micropatterns we have seen in our earlier figure, a typical 3 electrode setup was employed by externally sorting 2 electrodes. You can see in our next figure. Yeah. Yeah, this is, we have sorted the 2 electrodes to form the working electrode, and while platinum wire and an AgCl reference electrode served as counter and reference electrode respectively. And we have just kept that reference electrode and counter electrode to suspended into the solution, and it should not touch the gold pad. Now the AU pads were wire bonded to a custom chip carrier, and epoxy glue was stamped onto a bonded region for reduction of effective surface area that we have already told you, that is 37,118 micrometers square. It is confirmed by our microscope. Now a 0.5 microliter drop of the deoxygenated electrolyte were placed on the gap between AU microelectrode and a constant anionic current That current density we have used 0.5 milliampere per centimeter square was applied to the working electrodes for 15 minutes. The counter and reference electrode were precisely poised in contact to the electrolyte by precision micropositioner in the probe station. Now, this is the main structure, and you can see the probe station, figure of the probe station, and this is the setup. You can see the figure. Now, surface tailoring of composite nanostructure with Fe nanoparticles were carried out electrochemically. That is only for PNP based structure, not for POD based structure. Electrolyte solution of Fe2SO4 H2O, H2O means ferrous sulfate hydrogen were prepared in aqueous media with KCl as a supporting electrolyte. And the concentration ratio we have taken here for 0.5 millimolar is to 1 millimolar. A 0.5 microliter drop of electrolyte were dispensed on the synthesized PNMP-SWD nanocomposite, and cyclic voltammetry was employed in a typical 3 electrode configuration to obtain that Fe nanoparticles on the surface of nanowire structure. For Fe nanoparticles deposition, the lower and upper limits of potential were kept to be minus 0.05 volt and plus 0.02 volt. And with fixed scan rate 20 meter volt per second. And the fabricated device was thoroughly rinsed for removal of excess metal salts. After synthesis, the device were rinsed in deionized water to remove excess metal salts, and all the devices were finally tried under nitrogen flow. Now, so for results and discussion in concern, we can see the figure of the chronopotentiograms. Now, the first one is for PNMP SW20 nanocomposite, and second one is the SW20 POT nanocomposite. Now, the lower polymerization potential observed for SW20 PNMP nanocomposite suggested that conductivity of this backbone should be higher than the order. In present case also, the substantially lower polymerization potential could be observed than reported for electrode deposition of POT and PNMP thin film with conventional dopants. Such observation suggests the active role of SW20 in the polymerization process. Basically, during polymerization, the SW20 acts as highly conducting templates for polymerization that facilitate the process at lower electrical force. Now we can see the scan electron micrographs of PNMP SW20 nanocomposite, the second one, and first one is that left side one is PNMP SW20 POT nanocomposite, and right side SW20 PNMP nanocomposite structure. We have also taken the nanoparticle decorative. Next slide. We have also taken next slide the Fe nanoparticle decorated structure. Now, average diameter of the structure for both the cases were found to lay in the range of 25 to 40 mainly, but in an average that is 35 to 43. No characteristic difference in morphology could be observed for these two cases. You can see, since a single step galvanostatic deposition had been carried out for the present synthesis, it is evident that SW20s provide effective nucleation site for polymerization to take place. At the same time, reported average diameter of POT and PNMP with conventional dopants is more than 200 nanometer, which is several times higher than the synthesized composite structure that we have synthesized here. Thus, efficient role of SW20s as polymerization templates was further confirmed that resultant in high aspect ratio yields. The surface of the composite structures were found to be uniform and consistent. Finally, the Fe nanoparticle, that is here, found uniformly distributed through the SWNT PNMP composite and average diameter of the nanoparticles in the range of 52 to 55 nanometer. We can see. On the right side, we have taken the EDAX spectrum for confirmation of the elements, and we can see the different peaks of EDAX spectrum corresponds to the element of carbon, oxygen, nitrogen, silicon, Fe for the Fe nanoparticle decorated structure. That Fe nanowire, Fe SWNT PNMP, Fe decorated nanowire. Okay, and silicon, because of this, is on silicon substrate. That's why it has the silicon element also. Now, IV characteristic of S10 SWNT. We can see S10 SWNT, SWNT POT. The light blue is the pristine SWNT, SWNT POT, the orange one, and the white one. POT is the white one, and orange one is SWNT PNMP, composite nanowire matrix. Now we can see that for pristine SWNT characteristics, the S type of nature is evident, which indicates toward formation of shocky contact at the metal nanotube junction. Although such nature is well reported with SWNTs synthesized between AU electrodes, complexity arises if work function value of pristine SWNT is considered. Mostly reported value of SWNT work function is around 4.8 electron volt, that suggests formation of ohmic contacts at gold nanotube junction. However, the Schottky junction formation is, in our case, allows inferring that molecular adsorption of oxygen atoms rendered higher work function of SWNTs. In the rest of the cases, the device exhibit ohmic behavior, suggesting that work function of synthesized composite nanowires lie below than that of gold. Now, lower device current could be observed for both SWNT POT and SWNT PNMP devices than the pristine SWNT. Now, on the basis of this consideration, our observation will indicate that both PNMP and POT donate electrons to the SWNTs. Since SWNT are p-type in nature, donation of electrons resulted in lowering of holes in SWNTs, thereby increasing overall device resistance. And because of the lower recorded device current for SWNT POT nanowire composite than SWNT PNMP device, it was well inferred that POT acts as a better electron donor than PNMP, with SWNT as an acceptor. Now, this is our schematic of FET sensing modality. We have used the backgated structure. You can see here, mainly there is a MOSFET type of configuration. This is our chemi-resistive sensing modality that is well known to everyone. Just we have connected our resistive meter or current meter in between these two gold electrodes only. This is our gas sensing schematic of gas sensing setup, dynamic gas sensing setup. You can see mostly people are working on static gas sensing setups for gas sensing purpose, but we are working on that dynamic for real-time sensing. This is our sensing chamber, indigenously developed. Entirely we have designed and developed in our laboratory. Now, this is our FET transfer characteristics of nanocomposites. In reference that were drawn from that IV characteristic were further confirmed by these FET studies. Now this figure shows the curve recorded for pristine SWNTs and other fabricated composite sensors devices mainly. Now, a generic p-type nature was evident in all cases. For both the nanocomposite, we can see the negative shifts. Yeah. This is a negative shift in this direction. And this that negative shift in device threshold voltage could be observed, and maximum shift was observed for SWNT POT based device. Negative shift in device threshold voltage could be well ascribed to the donation of electrons for both POT and PNMP to the SWNT backbone. Behavior for the SWNT POT device again confirmed the better electron donating behavior than PNMP. No characteristic tilt behavior in any of the cases could be observed. This is our normalized sensing response, that is change in resistance of the sensor at certain concentration of ammonia. We can see the first figure. This is mainly SWNT PNMP nanocomposite based sensor, and Fe decorated, the final one. The left side, that is right side from 1 to 50 ppm, that upper range level, and left side is from 0.05 to 1 ppm level. We have reached up to 0.05 ppm concentration level of ammonia using this Fe decorated SWNT PNMP nanocomposite. This is a very good range. Now, this is the comparison between the three sensors, SWNT POT, SWNT PNMP, and SWNT PNMP Fe nanocomposites. Now we can see, irrespective of all these devices, resistance was found to increase with introduction of ammonia. And that is for only the upper range level, 1 to 50, because other sensors, means POT-based sensors and pure PNMP and SWNT, we could not reach to the lower level. We can get only this upper window level up to 1 to 50 ppm. We cannot go down below the 1 ppm with this, without nanoparticle devices. Yeah, in our case, we have not got that result, but in other cases, we could. Now, in this, irrespective of all these device resistance, we can see that this is found to increase the introduction of ammonia upon the introduction of ammonia, and decrease upon flashing with 0 ER. And calibration curve for fabricated sensor, that is also there, and evidently the SWNT PNMP composite nanowire based device had shown better sensing capability than SWNT POT. We can see from that figure. Further, to validate whether the SWNT PNMP composite nanowire based backbone also exhibited an enhanced sensing behavior, by a surface telling of Fe nanoparticle in accordance to the best observed sensor modality. We have seen this is with Fe decorated structure. We can see and expectedly best sensitivity and linearity was obtained with the Fe decorated structure. You can see that Fe decorated structure have the highest one, that yellow first one, yellow one, not green one. The best sensing platform exhibited excellent linearity, it is R square value of 0.098, that we can see. Here, you can see the R square value reach up to 0.098 with an average sensitivity around 48.6% in the range of 0.05 to 1 ppm of concentration. Now this is the tabular form with response time and recovery time, and we can see that this is mainly SW20 PNMP if decorated structure, and we can see at lower concentration means 0.05 ppm level the response time is high, whereas recovery time is low, and whereas in higher concentration at 50 ppm the response time is short, 0.4 minute, whereas recovery time is high due to this high concentration, 3.95. But it is very well for the real-time sensing application. Now, FET transfer sensing behavior. This shows the transfer curve of SW20 POT and SW20 PNMP nanocomposites both. Now, first one is for SW20 POT and also FE nanoparticle decorated composites devices. All we have kept under 1 ppm atmosphere of ammonia, and we can see negative shifts. Both. You can see the negative shift of the threshold voltage from ambient air condition was evident in all cases, and the effect of ammonia exposure was most profuse for the surface tailor device that displayed maximum negative shift. In significant downward tilt, the mechanistic phenomena in the fabricated sensor is exhibited in manner that lone pair of electrons from ammonia are donated to the protonated site of the polymeric backbone that resulted in decrease of overall hole concentration in the device backbone as reflected by the negative shift, and most increasing outcome we have got with the SW20 PNMP based nanocomposite device that suffer from negative shift than SW20 POT nanocomposite device, indicating a less affinity towards ammonia. And no tilt could be observed the device transfer characteristics in either cases, and a pursuance towards elucidation of such behavior kept in consideration that POT was evidenced by our IV and FET transfer observation is a better electron donor in comparison to PNMP, and then showed a less affinity toward acceptance of electron from ammonia. A comparative look into the chemical structure of POT and PNMP readily offered a justified figure. Basically, in methyl pyrrole is having one substituent we have already discussed on pyrrole structure, that is a methyl group, whereas O-toluene is formed due to bi-substitution of benzene ring by two substitutes, amine and methyl group. And as a matter of fact, this amine group is rich in electron. Thus, the overall electron density is more in O-toluene, and our observation that POT is better electron donor to SW20 thus stands justified. Also, since electron rich the POT is less prone to accept electrons from ammonia. And our best sensing response observed for the surface tailored backbone that was fabricated to the donation of electron from ammonia to the backend d orbital of Fe in addition to the nanocomposite backbone, and such electrons are transferred to the nanocomposite, affecting further decrease in hole concentration. Thus, the maximum negative shift observed for the Fe nanoparticle tailored device that was well in line with expectation. And finally, introduction of such electrons at nanoparticle nanocomposite interfacial sites affected in further recombination at the metal nanoparticle nanocomposite interface sites, resulting in depletion layer that act as potential sites for scattering. Thus, the scattering of charge carriers gains more prominence than the conduction at ambient atmosphere, bringing down characteristics device mobility. The downward tilt in device characteristics is a clear indicator of such phenomena. Now, we can see the temperature stability of our sensor platform, the best sensor platform, SWNT, PNMP, and FE based. And we can see that the left side figure, that is for temperature stability performance for SWNT composite based sensor, that is for temperature, and right side for validity of insensitivity with days. And we can see a deviation of 7.9% from the initial baseline resistance could be observed at 65 degree. However, at 85 degree, the deviation was recorded to be the 37%. That indicates that the probable limit of operating temperature for the sensor lies around 65 degree, 65 degree centigrade. Now, in the right side figure, the stability with the days, very negligible drift could be observed in the performance of sensor till 75 days, with a maximum deviation of only 4.94% from the initial sensitivity. That is very well structured. Now, this is the conclusion part. We can conclude that chemical structure of polymer are found to have intensive role on deciding the selective behavior of polymeric sensor. Substituents that are present on the monomer parent ring decide affinity characteristic of the sensor, and the presence of strong electron donating, the NH2 group, on POT structure affected in donation of electrodes in the SWNT backbone and reduces overall hole concentration, and adversely affecting device conductivity and less affinity towards electrons donated by ammonia. In contrast of POT-based composite device, Schottky barrier were formed at Fe nanocomposite interface due to the relative difference of work function of the entities, and enhanced sensing behavior was detected for Fe nanoparticle tailored device. Now we can see the sensing tabular form for the three cases. We can see the detection range for POT based sensor, which is up to 150 ppm, linearity 0.918, whereas sensitivity is very low, 1.1%. Whereas for SWNT PNMP FE based structure, the range is from 0.05 ppm to 50 ppm, and the linearity for lower detection range is 0.984, and for higher detection range is 0.99. And sensitivity is very high for lower detection range, that is 48.6%, and for high detection range is 2.8%. It is quite acceptable. These all are the sensing sensors performance, mainly for ammonia. Now, these are some devices we have developed indigenously. First, the CVD for the production of carbon nanotube. First, right side one, topmost. Then the right side topmost, that is sensing chamber. And the lower left side, that is mainly for a deep coding unit. It's computerized. And right side, it was our indigenously developed probe station. These are some other devices which was required in due course of our research. Some furnaces, ovens, some data acquisition systems. Those are these things. So we have seen that in our discussion that polymer plays a vital role for selectivity of a sensor. That means towards affinity towards a particular gas molecule. So we can use or we can modulate the selectivity characteristics of a sensor by using different polymers with SWNT, because we have seen that SWNT is also required to achieve the lower detection and better sensitivity orbital electron donating nature. For that reason, we need SWNT. That we have concludes from our research. Thank you for your patience and for listening my experiences. Thank you.
Okay, dear participant, now technical session is open, over. Uh, Thank you, sir, for delivering this wonderful lecture, sir. You have focused on sensors and sensor properties and polymer applications on the sensing materials. Sir, now the session is now the time for the lunch break, and session will poster and oral presentation will start on sharp 2 o'clock after 15 minutes. Hello, welcome to all. Now we are starting the poster presentation and oral presentation. So I'm starting inviting the first presenter of oral presentation.
Welcome to all. I am Dr. Sangeeta Shinde, Assistant Professor, Department of Physics, Pratishthan Mahavidyalaya, Pathan. I am going to present a research paper on topic preparation and characterization of copper oxide nanoparticle synthesis via Soldier method. The outlines of paper is objective of research, introduction to nanotechnology, synthesis of copper oxide nanoparticles, result and discussion. The objective of my research is the synthesis of copper oxide nanoparticles by Soldier technique. The characterization of copper oxide nanoparticles by techniques X-ray diffraction, UV, visible spectra, same to confirm the synthesis of copper oxide nanoparticle size, band gap, energy, and structure. What is a nanotechnology? Field of applied science which is the control of matter on an atomic and molecular scale. A nanometer is 1 billion of meter 10 to the minus 9 amp. This is roughly 10 times the size of an individual atom. The scientist Richard Feynman is the grandfather of nanotechnology. He first conceived the idea of molecular manufacturing in his 1959 speech. There is a plenty of room at the bottom, in which he described the possibility of synthesis via direct manipulation of atoms. These are nanotechnology areas. Nanoparticles, objects with at least one of the dimension in the range 1 to 200 nanometers. Why nanoparticles? High surface area, significant reduction in material usage, unique properties, different from bulk as well as molecules, and it has high reactivity. There are two different approaches for synthesis of nanoparticles. One is the top-down and other is the bottom-up approach. There are some methods of synthesis. The first is the physical methods, then biological methods, and chemical methods. We are interested in chemical methods, that is co-precipitation, solvent processing, microemulsions, hydrothermal, tonochemical, etc. For the synthesis of copper oxide, the Solvent technique is used. The Solvent method is based on inorganic polymerization reaction. There are 4 steps: hydrolysis, polycondensation, drying, and thermal decomposition. The size of solvent particle depends on the solution composition, pH, and temperature. In my work, I follow this table. First, the 3 gram of copper chloride is dissolved in a 160 ml of the ethanol. Then the 1.8 gram of NaOH is dissolved in a 50 ml of the ethanol. Then the second solution is added dropwise in a first solution and it gets stirred continuously at room temperature. Slowly this solution converts into the dark green and after dark green it is converted into the black precipitation which is called as the copper oxide, copper hydroxide. This black precipitation is washed 3 to 4 times with ethanol. Then it is dry at 60-degree temperature. And after that, this sample is annealed at 200 degree, then 300 degree, and then 400 degree. And after that, this anneal powder is grind, and so we get the copper oxide nano. Methods for characterization of nanoparticles are to get a particle size, electron microscope, X-ray diffraction, magnetic measurements. Then for surface composition, IR, UV, EDX is used, and for surface morphology, same and TEM is used. Result and discussion. In my result and discussion, the synthesis of copper oxide nanoparticles by Solgen method, then the characterization of copper oxide nanoparticles are done by the X-ray diffraction, then UV, that is visible spectra. Same to confirm synthesis of copper oxide nanoparticle size, band gap energy and structure. We are going to discuss about the XRD, the X-ray diffraction analysis. Here figures show to the right side, this is the X-ray diffraction spectra of a copper oxide nanoparticle. From this, here all the peaks can be indexed to the monoclinic crystal system copper oxide, and the crystal size has been estimated from the XRD pattern using the Scher's equation. And here the average crystalline size of copper oxide nanoparticle is found to be around 19.48 nanometer. The next characterization I use is the UV visible spectra. So in a figure, UV visible spectra shows the wavelength versus absorption plot. Copper oxide nanoparticles showed a band at 280 nanometer due to metal interband transition. It also shows the broad absorption peak between the 450 and 550 nanometer can be contributed to the characteristics absorption of copper oxide nanoparticles. This figure B2 shows the plot of HV versus E. In order to calculate the optical band gap of sample, the relation Taussig's relation is used. Here, A is the absorption coefficient, B is the material constant, and G is the band gap. The band gap can be estimated by extrapolating the linear region in the plot of HV square versus the photon energy as shown in the figure. The band gap of nano copper oxide is calculated, which is 3.43 eV. And it is higher than a reported value of copper oxide in the range from 1.8 to 2.5 eV. The increase in band gap may be due to quantum size effect of synthesized sample. Then the third characterization is the same. So this diagram at the right side clearly shows the shape of the nanoparticle. Here, the scanning electron microscope is used and which shows the same micrograph of the copper oxide nanoparticle at a 15,000x magnification. The same micrograph indicates needle shape for a copper oxide nanoparticle, and the same reveals the little aggregates of chemically synthesized nanoparticles. Then the conclusions. From my work, I conclude that copper oxide nanoparticle has been synthesized by Sol-Gel method successfully. This method is easy, less time consuming and flexible. Copper oxide nanoparticles require no expensive material and complicated equipment. XRD pattern confirms the crystalline and monoclinic structure of the copper oxide nanoparticles, and the size of it is around 19.48 nanometer approximately. UV visible spectra gives band gap of nano copper oxide is calculated to which is to be 3.43 eV, which is higher than the reported value of copper oxide in the range of 1.8 to 2.5 eV. Same image of copper oxide nanoparticles showed that the copper oxide nanoparticles were like a needle shape. Accumulation of all experiments confirmed the uniformity of synthesized copper oxide nanoparticles. I must be thankful to the Pro Vice Chancellor Dr. Babasaheb Ambedkar Marathwada University of Aurangabad for giving the financial assistance to complete minor research project, and also thankful to the Principal Pratishthan Mahavidyalaya for providing necessary laboratory facilities and encouraging for research work for the completion of the project. Stay home, stay safe. Thank you.
Greetings of the day. I am Dr. Aarti Rishi presenting here my research work entitled Spin-Coated Carbon Nanotube Sensor Platform for Ketone Detection. Here I am going to concentrate on two ketones that are nothing but acetone, and another one is ethyl methyl ketone, which is nothing but 2-butanone. We know these two ketones constitute it is the most important part of several products that we use on our daily life. For example, say paints, nail paint remover, or they are the most constituent material in laboratories and industries, because for the fabrication of various products, these ketones were used as a solvent. While having the applications with these ketones, we need to understand they are highly flammable, and at the same time, they upon exposure, say high amount of exposure, they show several effects on the human body. Some are chronic effects and some are acute effects. Chronic effects are highly dangerous. So to avoid that danger, we need to have some detection mechanism or some kind of detectors that will give the user the actual amount of concentration in the environment. And for that purpose, we have tried to fabricate sensors with the help of carbon nanotubes. Single wall carbon nanotubes is the most promising sensing material used in the present era, but due to their honeycomb structure, they undergo the problem of recovery. And at the same time, selectivity issue is also there with pristine carbon nanotube based sensors. So to avoid that and to have the high sensitivity and selectivity, here I have used cobalt octithyl porphyrin to decorate the side walls of carbon nanotube. And by their combinations, we have tried to have the sensor. So for the fabrication of the sensor, the procedure is given. The SWNT solution were prepared by sonication, centrifugation. Then their coating on prefabricated AU electrode was done with the help of spin coating method. Then the devices were finally prepared by annealing process. And after that, the porphyrins were coated on the fabricated sensor. And after functionalization, post-functionalization annealing was done to have the stiff contact with the electrodes. So here you will get the idea, whatever procedure I have said, this is the depiction of the fabricated sensor. It is a SiSi2 platform on which there is a AU electrodes, two AU electrodes and in between that gap, SWNTs and porphyrins were deposited. So if you see, this will act as a resistor, basically electrochemical resistor we can say. So this is the FESM image of the fabricated sensor. Here you can see the materials, sensing materials have coated or bridged the gap that is present in between AU electrodes, and it has been observed that after functionalization, there is increase of 20 nanometer as compared to pristine SWNTs. After the structural characterization, electrical characterization were done with CHI 660 electrochemical workstation. And here you can see current voltage characteristics before and after functionalization. So basically, from these characteristics, we can say that there is a formation of charge transfer components. The main aim was covered through sensing characteristics. Sensing characteristics were performed in the indigenously designed and developed dynamic gas sensing setup. And here you can see what we have done. We have applied the constant current, 10 microampere. For that constant current, whatever changes happens in case of voltage, that were recorded. And first, the sensor is exposed with the help of dry air to achieve the baseline resistance. And after that, various concentrations of the analytes were exposed upon the sensor in the range of 50 ppm to 200 ppm. With respect to that exposure, whatever are the normalized changes in resistance that were recorded and put over here. So through this calibration graph, we can see that in case of both the analytes, electron donation has been observed from the analyte to the sensor. In case of butanol, the donation is more promising because it has highly donating species. So this is related to detection of the ketones by the fabricated sensor. As a conclusion remark, I would like to say the fabricated sensor is able to detect both the analytes below their PEL level. PEL is permissible exposure limit. We can have that much presence of analytes. So both the analytes were detected by the sensor below their PEL level. And in future, we are trying to have the detection of other VOCs with the help of same kind of sensor. More selectivity and sensitivity issues. Even also, we are thinking about cross-analyte related study. So this is all about the research work that I would like to share with you. Thank you so much.
Good afternoon, everyone. Myself, Dr. Rajesh Barade from Government Vidarbha Institute of Science and Humanities, Amravati. First of all, I am very much thankful to the organizer for giving me such a platform to represent my research here. Today, I am presenting investigation of DC conductivity of polyaniline NaO2 composite. As we know, conducting polymer has been broadly studied because of its various applications in gas sensors, batteries, light emitting diode, solar cells, etc. etc. Polyaniline is the most prominent polymer among the various polymers due to its unique properties like electrical property, easy for synthesis, environmental stability, etc. and various applications like rechargeable batteries, photovoltaic cell, etc. The preferable formation of sodium superoxide at the oxygen side is due to the transport limitation of gaseous oxygen through the electrolyte filled cathode structure. It is known that the sodium superoxide can be formed as a stable and solid compound. Experimental procedure. Polyaniline was chemically synthesized at room temperature by oxidative polymerization method. The suitable quantity of ammonium persulfate was dissolved in deionized water and subsequently kept for magnetic stirring for 1 hour. The aniline monomer was added in ammonium persulfate solution in dropwise manner under the constant magnetic stirring for 2 hours. The resultant product appears greenish black. The product was filtered and washed until the filtrate becomes colorless and dried it at 45 degrees Celsius in an oven for overnight. The sodium superoxide was prepared in a single step method by heating sodium nitrate in oxygen-rich environment. The polyaniline NaO2 composite were prepared in wet percent stoichiometry by organic media using XC2 technique. The composite's preparation range was fixed from 5 to 20 wet percent. The figure 1 shows the XRD pattern of prepared sodium superoxide. The peak position appeared in pattern exactly indexed to NaO2 according to JCPDS data. The XRD pattern for pure Pani and Pani NaO2 composite are as shown in figure 2. Figure 2a shows XRD pattern for pure Pani, as Pani is inherently amorphous and hence there are no sharp peaks for pure Pani. The peak of NaO2 are seen in XRD of Pani NaO2 composite as shown in figure 2b to a, along with some other peaks. However, intensity of 200 and 222 peaks are suppressed in Pani NaO2 composite as compared to the XRD of pure NaO2. This suggests that NaO2 is present in a Pani matrix. However, these peaks are slightly shifted from their respective standard position, which may be due to presence of Pani matrix. The calculated value of D spacing, interchain separation, and crystallite size corresponding to the highest intense crystalline peak of Pani NaO2 composite are as mentioned in table 1. The figure 3 shows the same image of 20 wet percent of Pani NaO2 composite. From the image, it is observed that grains are high agglomerated and good interconnectivity between the particles. Such morphology helps the transportation of charged particle through the carbon backbone of polymer chain. The entire region of micrograph shows that sample exhibit an irregular granule morphology. The figure 4 shows the relation of DC conductivity with temperature. This relation varies exponentially with temperature. The result shows the positive influence on temperature-dependent conducting property of pani, which may be caused by the mobility of counter ions. This is attributed to the modification of bulk morphology of pani NaO2 composite. It is observed that conductivity increases with temperature. The reason for the increase in the conductivity is attributed to the thermal energy at higher temperature to excite electron to the conduction band. Such behavior can be expressed by the Arrhenius equation. The dependence on temperature of DC electrical conductivity of the composite is similar to the semiconducting behavior. The electrical conductivity of this composite increases with temperature in all the composite as the weight percent of NaO2 increases and exhibit a thermal electron process and a hooping process. The various values of conductivity and activation energy of pani NaO2 composite is as shown in the table 2. The highest value of conductivity is found to be 1.59 into 10 to the power minus 7 Siemens per centimeter for 20 weight percent of NaO2 composite. Now, conclusion. The sodium superoxide was prepared in a single step method by heating sodium nitrate in oxygen-rich environment. The pani NaO2 composite were prepared using ex situ technique range from 5 to 20 weight percent with the interval of 5 weight percent. The peak position appear in XRD pattern of as prepared sodium superoxide exactly index the NaO2. The peak of NaO2 are seen in XRD of pani NaO2 composite suggests that NaO2 is present in a pani matrix and presence of pani has influenced the prepared orientation of NaO2 grains to some extent. The entire region of same shows that sample exhibit an irregular granular morphology. The DC conductivity shows Arrhenius type temperature dependence. The electrical conductivity of this composite increases with temperature in all these composites as the weight percent of NaO2 concentration is increased, and this exhibits the thermal electron process and hooping process. The maximum value of conductivity and minimum value of activation energy are found to be in the range of 1.59 into 10 to the power minus 7 Siemens per centimeter and 0.56 electron volt for 20 weight percent of NaO2 at 390 degree Kelvin respectively. These are the various references used for this research paper. Thank you. Thank you very much.
I am Nitya, Assistant Professor, Department of Physics, PUCR Christian College for Women, Coimbatore. My title is Synthesis and Characterization of Cerium doped TA with nanoparticles for gas sensing activity. Introduction. Nanoscale is the study of materials that exhibit remarkable properties, functionalities, and the phenomena due to the influence of small dimension. Among the all metal oxide nanoparticles, PaO2 is the most suitable material for antibacterial, photocatalytic, and gas sensor activity, owing to its physical and chemical properties, optical properties, higher selectivity, and response. Adjective. To synthesize cerium doped PaO2 nanoparticles through Solder method. To characterize and confirm the structural and physical properties of the sample have been analyzed through XRD, FESIM, HRTEM, UV visible, and FTIR spectral analysis. To study the properties of gas sensing activity, the aim of this work is to develop cerium doped PaO2 nanoparticles for gas sensing applications. Synthesis procedure. 5 ml of TTIP was dissolved in 100 ml of isopropyl alcohol. Then cerium nitrate dissolved in 100 ml of isopropyl alcohol. Then the cerium nitrate solution was added dropwise to the TPIP solution. To maintain the pH 9.4 mole of NaOH solution was added to the precipitate. Then the precipitate was aged for 24 hours and kept in oven 120 degrees Celsius for 5 hours and annealed 500 degrees Celsius for 3 hours to obtain cerium doped TiO2 nanoparticles. Result and discussion. XRD analysis. The figure shows the XRD analysis of cerium doped TiO2 nanoparticles, and these are the two theta values, and these are the corresponding HKL plane values, and these HKL plane values are well matched with the JCPDS card number. And here the graphite is the prominent peak. Then the crystal size of the prepared sample decreases when increasing the concentration of cerium. FSM analysis. The figure shows the FSM analysis of cerium doped TiO2 nanoparticles with a heterogeneous morphology of uniform distribution. The structure of cerium doped TiO2 nanoparticles are accumulated with a highly porous structure. When increasing the dopant concentration of cerium, agglomeration was reduced and it has inhibited the particle size. Tegman-Redox analysis. The figure shows the Tegman-Redox analysis of cerium doped TiO2 nanoparticles that exhibit non-uniform distribution of nanoparticles with fine polycrystalline nature. The prepared sample shows a polycrystalline nature. The lattice species was found to be 0.283 nanometer, and it was further confirmed by XRD results. UV visible analysis. The figure shows the UV visible analysis of cerium doped TiO2 nanoparticles. The absorption values are 340 nanometer, 341, 342, and 343, and the corresponding band gap values are 3.64 to 3.61 electron volt, and the band gap value shifted to higher wavelength and further decreases. FTR analysis. The figure shows the FTR analysis of cerium doped TiO2 nanoparticles. The functional band at 376 centimeter inverse corresponding to OH group of TiO2 nanoparticles. The vibration band is 1350 centimeter inverse assigned to symmetric and asymmetric vibration of carboxyl group, and the band at 456 centimeter inverse attributed to TiO. The shifts in the peaks indicates the cerium doped group with TiO2 nanoparticles. The gas sensing activity. The first figure shows the selectivity, and the second figure shows the temperature versus response, and the third figure shows the resistance versus time, and the fourth figure shows the different concentration of ethanol, and the fifth figure shows the stability curve. The selectivity of the sensing material was tested with different gases, namely moisture, acetone, acetaldehyde, ammonia, ethanol, benzene, and toluene respectively. Among all these gas activities, highest for ethanol gas. And the selectivity of ethanol for sensing material was found to be 52 to 94%, and the resistance value was 8.6 to 3.5 into 10 power 9 ohm, and the response and recovery time was 16 seconds to 9 seconds, and the stability of the sensing material was tested over 30 days for ethanol gas at room temperature, and the stability of the sensing material was found to be good. Thank you.
Hello everyone, this is Dr. Sheikh Ifra Fatima, working as Assistant Professor in the Department of Physics and Electronics, Dr. Rafiq Zakaria Campus, Maulana Azad College, Aurangabad. I am going to present my work on dendritic fractal patterns of lead in electrodeposition process using circular cell geometry. This presentation consists of introduction, aims and objectives, experimental setup, electrodeposition of lead, effect of cell operating conditions, lastly, result and conclusions. Introduction. As we know that classical methods of geometry are insufficient to describe natural shapes because of its complexity, in the year 1975, Benoit Mandelbrot coined the term fractal. Fractals are irregular and complex geometrical shapes which can be further divided into sections, and each section is the replica of the whole object. Its characteristic features are, at all scale, it has fine structure,
It possesses the property of self-similarity. So, what is self-similarity? If an object or any geometrical pattern is magnified, the shape of the magnified portion of that pattern will look approximately the same as that of the original pattern. Then and only then we can see that the object or geometrical pattern possesses self-similarity. Another most important property of a fractal is scale invariance. So, if the feature of the object do not change even if the scale is varied up to a certain limit, then the object is said to have the property of scale invariance. The aims and objectives were to study growth of dendritic pattern using electrodeposition technique to characterize irregular shapes, and to study the effect of cell operating conditions on growth and development of dendritic patterns and application of suitable techniques for determination of fractal dimension. For the purpose of study, electrodeposition cell was designed and constructed using perspex. The main part of this setup is the acrylic plate of thickness 3 mm that carried a circular cavity to accommodate the electrolyte to be studied as shown in figure. A thick white circular border forms the electrolyte compartment, and a circular metallic anode is placed within the circular space and the cathode pin at its center. This top plate was mounted on a rectangular box made from acrylic sheet as shown in the figure, and the whole electrodeposition cell was kept inside the constant temperature bath to maintain the temperature constant. For electrodeposition of dendrites from lead, 1 molar lead acetate solution was used as an electrolyte, and the electrodeposition was studied at different self-operating voltages, that is 3 volt, 5 volt, 7 volt and 10 volt at room temperature. Here we can see the images of grown dendritic patterns of lead at different cell operating voltages 3 volt, 5 volt, 7 volt and 10 volt. The growth of fractal pattern exhibit tendency to grow branches and sub-branches in accordance with crystal structure. Therefore, the deposits are in the form of leafy patterns. When cell operating voltage is 3 volt, there are shorter branches. In case of 5 volt and 7 volt, prominent longer branches are seen, and at 10 volt, there is rapid growth of branches. Also, fine hairy tentacles develop at faster rate. These tentacles, being poor in mechanical strength, tend to move in electrolyte. This causes masking effect for inner branches. The fully developed fractal pattern is then subjected to analysis using box counting technique. Characterization. Here we are using box counting technique to determine fractal dimension, which is the measure of complexity. In this method, using computer program, number of boxes required to cover the entire image using boxes of different sizes are recorded and tabulated with its log values. Using the log values, graphs are plotted. As we can see, all graphs show straight line pattern, which shows that self-similarity is followed and pattern obtained is a fractal. Result: the power law exponent and fractal dimensions obtained for the 4 electrodeposits using 1 molar lead acetate solution at different voltages are summarized in the table given. Here we can see that all the values of R square are close to unity, confirming the presence of self-similarity and scale invariance. as the power law is obeyed, and all the 4 patterns are fractals. So here are the conclusions. It is seen that the fractal dimension is in the range of 1.44 to 1.51, which is close to the standard DLA characteristic fractal dimension. The cell operating voltage is increased from 3 volt to 7 volt. The proportion of random motion of ions is reduced relatively. Thus, the pattern deposited deviate more and more from the DLA-like patterns, and hence the deposit exhibit lower fractal dimension at higher voltages. For the electrode deposit at 10 volt, the fractal dimension appears to be slightly higher. The reason behind this is that at higher currents, flow of ions is enhanced, which in turn contributes to thicker deposits and formation of thicker and wider branches. Additionally, the formation of fine hairy tentacles that tend to move in unspecified direction due to convection currents mask the movement of ions. A combined influence of such processes result in growth of an pattern that exhibits slightly higher fractal dimensions. And this is the end of presentation. Thank you. Hello everyone, myself Soumyagiri, research scholar in Department of Physics, Bundelkhand University, Jhansi, UP. Here I am going to represent my topic, effect of aluminium ion substitution on magnetic properties of nano-sized barium saccharide in the International World Conference on Advanced Material Science and Nanotechnology, NANOMAT-2020. Outline of my presentation, introduction, synthesis method, characterization techniques, result and discussions, conclusion and references. First of all, introduction. The crystallic structure of barium saccharide is hexagonal and it has a space group of 263 mmc. It is the superposition of a spinel block and hexagonal block. Barium hexaferrite material has so many applications like recording media, storage devices, microwave devices, etc. Due to its high Curie temperature values, saturation, magnetization, coercivity, etc. Synthesis method, solid auto combustion method is used in our research work. It has many advantages like simple equipment, low cost, and low sintering temperature, less time for processing, etc. Here material are used ferric nitrate, aluminum nitrate, barium nitrate, urea. Urea is used here for reducing agent or fuel, and nitrate are used as oxidants. Synthesis procedure, here diagram form. First of all, we make sol of urea and nitrates, then heated on the hot plate at 80 degrees Celsius. After that, a viscous gel is obtained. Then burn combustion in the micro oven, we get loose powder. Then sintering in the metal furnace, we get the ash. After that, we are grinding all the samples of the powder obtained in the ash form up to the 800 degrees Celsius temperature. After that, we get fine powder for further characterization. Characterization techniques. First of all, X-ray diffractometer, then scanning electron microscope, tunneling electron microscope, TEM, and for magnetic properties analysis, GSM, magnetic sample magnetometer. Result part XRD. Table 1 shows the structural parameter of the barium ferrite sample form. In the table 1 we can see that lattice parameter A and C values. Lattice parameter A and C both value are decreased by aluminum ion substitution, and porosity is increases, crystal size decreases, cell volume is also decreases. These values are decreased by aluminum ion substitution due to the small ionic radii of aluminum ion. Figure 1 shows the XRD patterns. Figure 1A is a barium ferrite sample and figure 1B is aluminum substituted. Figure 1B shows the higher value, the two theta value are shifted toward the higher value. This due to the aluminum doping. Shifting occurs due to the replacement of Fe3 ions by aluminum ions. Since the ionic area of aluminum is smaller than Fe, it is going to the occupy tetrahedral side of the hexagonal structure. So that escape plane gets shifted to the higher theta position. Come to the next slide, morphological. Figure 3A and B show the ideal spectrum. We show the elements are present in our sample formed. Figure 1A is pure barium ferrite. And figure 3 is pure sample and figure 3B is substituted. Here figure 4A and B show the same images and figure 4C and D show the 10 images. Same images show the hexagonal shape and agglomeration of the particle forms, and figure C and D 10 images show the nano size of particle form. Here magnetic properties. Table 2 show the magnetic properties. In the table 2 we can see that MS values saturation magnetization and SC value. MS value decreases and SC values increases by aluminum ion substitution. It is due to the replacement of Fe3 ion that has magnetic moment of 5 MeV by aluminum ion have 0 magnetic moment. 35% of aluminum ion occupies octahedral site and 15% occupies tetrahedral site. Decrease in MS due to the aluminum ion substituted by Fe3 at the spin-up state in the hexagonal structure. Here hysteresis loop shows. Here resonance magnetization, that is MR value directly calculated from the hysteresis loop, which is shown in figure 5. Come to our conclusion. Finally, conclusion is here. Aluminum substituted barium has about 2 nanoparticles have been synthesized successfully by several auto-combustion technique. Particle XRD shows the particle size decreases from 26.26 nanometer to 23.21 nanometer. Here, a secondary phase of alpha phase is also obtained, and same images show the agglomeration of the particle. 10 images come from the nano range of prepared sample, and magnetic properties show the decreasing magnetization values with aluminum ion substitution. Effect of aluminum ion substitution shows this the prepared ferrite material used for storage devices, recording media, and permanent magnet, etc. Prepared material shows the nature of hard ferrite. It is also due to the high PR ratio of sample form. Here, these are some references we have used in our PPT, and thank you.
Hello friends, I am Dr. Ashish Kadu from Professor Ram Meghe College of Engineering and Management, Patnera, Amravati. Today, I am going to deliver my presentation on my research paper entitled Structural and Ethanol Gas Sensing Properties of SR Doping on IN2O3 Nanoparticles. In the present work, thick film of nanostructured SR doped IN2O3 were synthesized by Soldier citrate method. The structural property of SR doped IN2O3 nanoparticles were analyzed by using XRD. The minimum crystallite size of SR doped IN2O3 calculated from Scherrer formula is found to be 20 to 25 nanometer. The sensitivity of SR doped IN2O3 to reducing gases like acetone, ethanol, H2S, and LPG was been compared. SR doped IN2O3 is adopted to improve the gas sensitivity of pure IN2O3, especially to enhance the response to ethanol gas. The quick response and fast recovery are the main feature of this sensor. Synthesis. SR doped IN2O3 nanopowder were prepared by Soldier citrate method. The powder of indium nitrate, deuterium nitrate, citric acid were weighed in a desired proportion and dissolved in small amount of distilled water. Ethylene glycol was added to make the colloidal solution. Stirring was done on magnetic stirrer for 1 hour at 80 degrees Celsius to obtain the homogeneous solution. After heating at 140 degrees Celsius for 12 hours, the dried gel was ignited in a corner. The gel was subjected to calcination at 650 degrees Celsius for 6 hours in a furnace and to obtain the combustion flag for the material. Now result and discussion. Figure 1 shows the XRD pattern of iron O2 and 3 weight percent SR doped iron 2O3 powder sample calcined at 650 degrees Celsius. These are the graph. The XRD pattern of iron 2O3 and 3 weight percent doped SR doped iron 2O3 powder sample calcined at 650 degrees Celsius were shown in figure 1. There is no impurity peak found indicating the formation of pure sample. The XRD peak of 3 weight percent SR doped iron 2O3 were sharp than that of the undoped iron 2O3 sample. And here you observe that the crystallite size in the range of 20 to 25 nanometers. Now figure 2 shows the responses of the gas sensor based on this A, that is a 2 weight percent SR doped iron 2O3, B, pure form, C, 1 weight percent SR doped iron 2O3, and D, 3 weight percent SR doped iron 2O3 here. And here we observe that as the operating temperature increases, the gas response increases, and this sample shows maximum response at 180 degrees Celsius. So out of these all the samples, the 3 weight percent SR doped iron 2O3 is the best sample. Now next is the response and recovery. This is one of the main characteristics of the gas sensing. The response and recovery curve of the gas sensor based on pure iron 2O3 and SR doped iron 2O3 nanoparticle to 100 ppm ethanol at 180 degrees Celsius is shown in the figure. From the figure, we can see that although SR doping in different amount, the response and recovery time of each sample change slightly. Next is the gas concentration. The figure shows the responses of 3 weight percent SR doped iron 2O3, and here we observe that as the gas concentration increases, the response increases, and it should be maximum at 1 to 500 nanometers ppm. Next, selectivity. The selectivity of the gas sensor based on 3 weight percent SR doped iron 2O3 nanoparticles was measured by expose the sensor to 10, 50, 100 ppm acetone, ethanol, H2S, and LPG at 180 degrees Celsius. It is clear to point out that sensor is less sensitive to H2S and LPG, and it has a higher response toward ethanol. Finally, conclusion. In summary, pure iron 2O3 and SR doped 1, 2, and 3 weight percent iron 2O3 nanoparticles were synthesized by using Sol-Gel method, and their gas sensing property were investigated. The XRD pattern also shows high degree of crystallinity and complete phase formation with a grain size of about 20 to 25 nanometer with cubic structure. The XRD peak of 3% SR doped iron 2O3 were sharp than that of the undoped sample. Among all other all additives, 3 weight percent SR doped iron 2O3 was found to be optimum and shows highest response to ethanol gas at 180 degrees Celsius. So, the 3 weight percent of SR doped iron 2O3 nanomaterial thick film sensor has good selectivity to ethanol gas against acetone, H2S, LPG at 180 degrees Celsius. Thank you very much.
Hello everyone. I, Dr. Deepak Taikar, Department of Physics of Sri Lanka Patil Mahavidyalaya Mandal, presenting my research paper, Effect of Lithium Ion on Photoluminescence Property of EU3+ Doped Z-nanophosphorus. oxide. Zinc oxide is highly stable material. It has very wide band gap around 3.37 electron volt, which is suitable for luminescence property. It has high exciton binding energy, and it's shown in past that it is a very good host for lanthanide doping. Now that a zinc oxide phosphor was prepared by co-precipitation method, in which initially stoichiometric amount of zinc oxide and europium oxide were taken, and then it gets converted into nitrate form, and then that mixture both the solutions were taken in a single beaker. Then the oxalic acid solution was added to that mixture, which is in nitrate form. So after adding oxalic acid solution, precipitate is obtained in the form of oxalate. Then that precipitate was filtered, dried and heated at 1000 degrees centigrade for 2 hours, so that U3 plus dose ZnO was obtained. This is the XRD analysis pattern of ZnO. The upper graph is the XRD of prepared material, and the lower one is the ICDD file 800074, and both these patterns are in good agreement with each other. This is the crystal structure of ZnO. It is rootside structure and crystallized in hexagonal form. Here, that green dot indicating zinc atom, whereas the pink dot indicating oxygen atom. So you can see here that single zinc atom is in coordination with the 4 oxygen atom to form corner sharing ZnO4 tetrahedron. And similarly, that single oxygen atom is also in coordination with 4 zinc atom, and it forms OZN4 tetrahedron. This is the PL spectra of that prepared material. That curve A and B is the photoluminescence excitation emission spectra of ZnO-EU, whereas curve C and D is the excitation emission spectra of ZnO-EU after addition of lithium ion. So here that black curve A or dotted curve A is the excitation spectra of ZnO-EU. It shows broad excitation spectra from 220 to around 400 nanometer. That main excitation spectra, broad excitation spectra band is due to charge. It is because of the charge transfer band, and one peak is there around 395 nanometer. It is due to the transition of U3 plus ion from 7F0 to 5L6 transition state. That blue dot indicating the emission spectra of ZnO-EU phosphor. It shows broad emission band from 420 to around 650 nanometer. Along with some sharp peaks around 615 nanometer is due to the 5D0 to 7F2 transition of U3 plus ion, whereas one small peak around 585 nanometer is due to the transition from 5D0 to 7F1 transition of U3 plus ion. And a broad emission band peaking around 510 nanometer is due to the emission of ZnO itself. Now, after addition of lithium ion in ZnO-EU, you can see here that the excitation peak enhanced drastically. The peak around 395 nanometer increases, and that peak is due to the transition of U3 plus ion from 7F0 to 5L6 state. Whereas if you see here that curve D, which is indicating by a red line, conclusion that the xylenophosphor was successfully prepared by co-precipitation method. The XRD measurement confirmed the formation of zinc oxide compound that PL spectra indicates that EU3 plus ion shows characteristic emission line corresponding to 5D0 to 7J transition of EU3 plus ion. And after addition of lithium ion in ZnO phosphor or ZnEU phosphor, the luminescence efficiency enhanced due to the charge compensation. So overall, PL spectra indicates that, or the PL study reveals that the prepared phosphor are useful in near UV excited LED, optoelectronic display devices, and related applications. So that is all about my presentation. Thank you very much.
Hello everyone. This is Manasi Mahadik from RUSA, Center for Advanced Sensor Technology, Department of Physics of Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. Today I am going to present the synthesis and morphological analysis of polypyrene nanobars for the application of the heavy metal and clean technique. Let us start from the fundamental analysis. As you know, the current era is moving rapidly towards the nanotechnology as nanowires and nanodevices. Then the question arises, why we are moving towards the nano things as nanostructures, nanobars which I am going to represent here. This is what the nanostructures and the nanobars and connecting polymers like this. Improve the sensitivity of the sensor. This is the main thing that is why the nanobars are rapidly using in the sensing application. And the conducting polymer nanobars are used because of its large conductivity change, flexibility. The main important thing is rate of synthesis, and another thing is can be synthesized at any other desired location. This is also electrochemical setup for the synthesis of the polypyrene nanobars or any other nanobars. It shows the CHI which I have used, that is CH1120, and the 3 electrode setup which contains the working electrode, reference electrode, and the counter electrode, and with the polypolar solution. And it shows the airframe image of the grown polypyrene nanobar at the desired location. Here we are using the platinum electrode. It shows that as it is a two-stage galvanostatic technique, in the first step, we are applying the 0.08 milliampere in the ratio of current. In the first step, and it is for the 20 minutes. In the second stage, we are applying the 0.02 milliampere current for the 90 minutes. This is for the two-step galvanostatic technique. After this, this is the airframe image of the polypyrene nanobar zone. From this, we can see around 34 nanometer to around 32 nanometers length nanobars can be grown, and it can be reached between the 3 micron gap of the electrode, which we can use for the sensing application. This is the airframe image. In this is the 3D plot. It shows the histogram of the airframe image. By using the histogram, we can measure the height of the grown nanobars at the desired location. And the airframe is done because we can also measure the roughness parameters. By changing the roughness parameters, we can use it for the sensing application. And these are what the roughness parameters of the grown nanobar. This is the main roughness parameter. This is the main max, but this is the main roughness parameter. This roughness can be changed by using the polypyrene nanobars, and it can be changed by using the metalloporphyrin group or by using the chelatin ligand for the sensing application. And thank you.
Myself, Vishal Kamble, Assistant Professor at CKT College, Panvel, and today I am going to represent my research topic entitled cobalt-doped zinc zinc oxide sensor grown by co-precipitation technique for NO2 sensing application. Now, introduction. We know that zinc oxide is a semiconducting metal oxide having wide band gap 3.37 electron volts and extratonic binding energy 60 mega electron volt. Therefore, zinc oxide is very specific attraction for gas sensing. And when we dope any metal in that, then surface to volume ratio as well as grain size of zinc oxide increases. Therefore, we use zinc oxide metal for preparation of gas sensor. And we know that there are many environmental pollutants. Among that, NO2 is very harmful to human being as well as environment because it creates greenhouse effect as well as global warming. Therefore, we took effort to prepare a sensor to detect the NO2 in the environment. Now, for that purpose, we use a simple co-precipitation method for preparation of zinc oxide film in that precursor, that is the zinc acetate, and for doping, that is the cobalt nitrate hexahydrate we use. And in actual procedure, the precursor solution 0.2 molar was prepared by dissolving required amount of zinc acetate in absolute ethanol and methoxysal and stirred at 70 degrees Celsius for 90 minutes, leading to the formation of clear and homogeneous solution. The solution was deposited onto a pre-cleaned glass surface. Similarly, for cobalt doping, use cobalt acetate hexahydrate as a precursor. We add a 5 atomic weight percent in solution to zinc acetate solution, and this was dropped on pre-cleaned glass surface and dry over 2 hours with the help of UV lamp. And here the formation of zinc oxide and cobalt of zinc oxide nanostructure. Now, next part is what the result and discussion we divided into two parts: characterization technique, and second one, that is the gas sensing performance. Now, with respect to characterization technique, we studied the nanostructure with the help of XRD, APSEM, and UV visible analysis. Now, first one, that is the XRD analysis. Now, check this XRD analysis of my nanostructure, and I match this nanostructure with the CPDS card number 0.10790205, and we get the amazing result intensity along 101 axis. That is the very high intensity. Therefore, here formation of clear-cut indication of formation of nanorods with hexagonal vertex structure. That is the geometry of our zinc oxide and cobalt of zinc oxide nanorod. Now see, that is the FACM result at 200 nanometers and 100 nanometers, and here clear-cut indication at 100 nanometer. We see that the formation of porous-like morphology as well as rod structure and a range of morphology of that is the 50 nanometers average length for structure, and length of nanorod, that is approximately 350 nanometer range. We see there, and we confirm with XRD again. Now, next one, that is the FTIR analysis. For FTIR analysis, we use to detect the functional group as well as chemical bonding. For that purpose, we carry out the FTIR analysis, and we carry out FTIR analysis for zinc oxide, pure zinc oxide, as well as cobalt doped zinc oxide. Then, due to small amount of doping, we see the same result of zinc oxide as well as cobalt of zinc oxide. But at 496 transmitter wavelength, we see the formation of zinc oxide. That is the indication of formation of zinc oxide nanostructure. Now, next performance, that is next task is what the gas performance test. Now, firstly, we check the temperature effect on our nanostructure, and for that purpose, we take the temperature. We took the temperature in range 120 degrees Celsius to 280 degrees Celsius, and we get the result maximum gas response at 200 degrees Celsius. That is amazing result at 200 degrees Celsius and 100 ppm NO2 gas concentration. Therefore, that is the optimum temperature as well as optimum concentration for further analysis. Now, see the second graph. In second graph, we check pure zinc oxide nanostructure and cobalt of zinc oxide nanostructure at operating temperature 200 degrees Celsius and NO2 concentration, that is the 100 ppm. And we get the result when cobalt doping zinc oxide shows the maximum gas response as compared to the zinc oxide. Why then? That is due to increasing surface area as well as increasing grain size, that is very attraction for gas sensing performance. Now, here the another diagram for zinc oxide and cobalt of zinc oxide. Then cobalt of, here clear-cut indication that cobalt of zinc oxide shows the maximum response as compared to the zinc oxide gas response. And conclusion. Last one, that is the conclusion. We systematically investigated the structure, NO2 gas sensitivity of cobalt of zinc oxide structure with the help of simple and inexpensive co-precipitation technique. Now, XRD analysis confirm hexagonal volatile structure of nanostructure. A PSEM show a rod-like nanomaterial were formed, taking into reflection of all the result of gas sensing test. It is decided that cobalt of zinc oxide nanostructure detect 100 ppm NO2 gas at 200 degrees Celsius operating temperature and has extreme ability in the field of gas sensor, and therefore zinc oxide, cobalt of zinc oxide is a very important material for gas sensor of the NO2. Thank you. Thank you very much.
Hello everyone. Very warm greetings to all of you. I am C.R. Kumar from Department of Physics, Shri Shivaji Education Society, Amravati, Science College, Nagpur. And today I am going to present on the synthesis and luminescence study of bis 8-hydroxyquinoline strontium. So, the outline of my presentation is Introduction to OLED, Organic Luminescent Material, 8-hydroxyquinoline metal gelate sets, Organic Luminescent Material, Synthesis of bis 8-hydroxyquinoline strontium, Structural Characterization, its Spectral Characterization, and Conclusion. Now, Introduction to OLED. OLED is basically a light emitting diode, that is LED, which is made up of carbon compound. Basically, OLED is classified in two ways, that is OLED and PLED. When we say OLED, it is made up of small molecular weight carbon compound, whereas the PLED, that is made up of polymers. So, the advantage of PLED, these are the fabrication of PLED is more cheaper than the fabrication of OLED. As OLED are fabricated by physical methods, or we say we usually form the different layers by physical vapor deposition and so on. But whereas in case of polymer LEDs or PLEDs, all the thin films or the layers are being deposited by the chemical method, easy solution processable method. So PLED has got more interest area in this. So basically, in PLED and as well as in OLED, there is a need of luminescent material. Now, what is luminescent material? We'll discuss it. So the major area of research involved in this stream is about the semiconducting materials that have been used for the luminescent devices. Then luminescent material. And third one is the device structure. These are the major areas involved in the OLED research. So OLED luminescent material. When we say luminescent material, we already know the concept of fluorescence and phosphorescence. This concept arises because of the radiative transition from higher energy electron at higher energy level to lower energy level. It loses the energy in the form of radiation. This phenomena is seen and These phenomena observed in such material are called luminescent material. Now, when we say organic molecule or organic material, these energy levels are usually formed because of the molecular orbital. That can be understood with the molecular orbital theory. And when we say organic molecule, we can form large carbon compounds, large chain of that, and we can easily tailor the molecular energy levels of the organic compound. And that has attracted more attention towards, because the tailoring of energy levels in organic molecule is quite easier as compared to as we have limited scope in inorganic material. So this organic molecule or organic material has great scope of that. That is why we are calling the tailoring of energy levels or molecular energy levels. Now 8-hydroxyquinoline. We are quite interested in this research. The 8-hydroxyquinoline metal chelates. Now there are few unique properties that 8-hydroxyquinoline has. The basic properties is that it has good electron transport properties, right? So it is very useful in electronic device. Its band gap can be easily tailored by forming metal chelates. Metal chelates means a salt with metal and 8-hydroxyquinoline. So when we form the bond with various metals, or we form the various metal chelates, its band gap, that is say the energy levels, the difference between the energy levels can be tailored. So although it has limited scope, but it can be tailored in UV to green to yellow region. Again, the synthesis process of these metal chelates are quite easier, and because we can go with the solution processable method or chemical method, in which the co-precipitation is considered to be the cheapest one, and that can be also, these complexes are thermally stable, and usually when we say nanostructure of these complexes, they usually used to form the nanorods. These nanorods are very useful in OLED. And also a unique property is that when we are embedding that with the host, polymeric host and polymeric host, it has good compatibility with that. There are well-known metal chelates from 8-hydroxyquinoline, that is aluminum, zinc, nickel, cadmium, Mg, barium, lead, copper, beryllium, indium. Now, in this part, we are discussing about the strontium. So, for synthesizing the 8-hydroxyquinoline strontium chelate, we prepared two solutions. First solution is, we labeled it as A, and that is prepared by dissolving 2.9 gram of 8-hydroxyquinoline in 160 ml of ethanol, and solution B by dissolving 2.12 gram of strontium nitrate in 40 ml of methanol. Under the constant stirring of solution A, we added solution B drop by drop to it. To maintain purity of the ammonium hydroxide, as the 8-hydroxyquinoline is liberating H plus ion in solution, so its pH will tend to move towards the lower side. That means it becomes basic. So it becomes acidic. So to neutralize that, we add some basic or the base to neutralize the or to maintain the pH of the solution. The obtained precipitate is washed and used for the washed and dried and used for the further characterization. Now we had the structural characterization, that is FTIR. In FTIR, all these bands are basically associated with the cumulin stretching and bending. But only the peak what we have observed, that is at 502 centimeter inverse, and that is associated with the strontium oxygen bond. And in X-ray diffraction, we basically took the X-ray of the sample and we compared with the X-ray, XRD data of raw materials. So we compared with 8-hydroxyquinoline and strontium nitrate. So it is clearly indicated that none of the peaks were matching to the complex peaks. Right? So this confirms the formation of the complex. Now we took, for spectral characterization, we took UV absorption spectra. In UV absorption spectra, it was found that it is absorbing at wavelength 401 nanometer and 333 nanometer. So at 40 nanometer, we took the emission, we checked the emission, and it is found that it has emission at 526 nanometer. Highest peak of emission is 526 nanometer for excitation wavelength of 416 nanometer. So from this data, we took TACU plot. TACU plot describes about the optical band gap of material, and the optical band gap is found to be 2.183 electron volt. And from CIE plot, we can easily see that this 526 nanometer lies in pure green region. So it emits bright green color. So to conclude, this complex can be used in OLED and PLED as it emits the green color, and it has excitation wavelength of 416 nanometers. So this can be used in dye-synthesized solar cell. Thank you.
Namaste everyone. My name is Kisan Khatri. I am from Nepal. I am a student of MSc Physics 4th semester at the Central Department of Physics, Tribhuvan University, Kirtipur, Kathmandu, Nepal. Today I am going to present my research work that I have carried out entitled Estimation of the Global Solar Radiation at Pokhara Valley, Nepal. Under the supervision of Professor Dr. Khemnaran Paudel and the advisor, Associate Professor Dr. Nurapati Pantha. My presentation is followed by introduction, instrument, methodology, results and discussion, conclusion and recommendation. Actually, global solar radiation is the radiation that is emitted from the sun, by the sun from a nuclear fusion reaction, and that creates the electromagnetic energy. Actually, you can see from the figure that it is the sum of beam radiation, diffuse radiation, and the reflected radiation. Primary source of all the energy of Earth, providing 99.97% of its energy required for all the kinds of chemophysical process in the Earth and the land. Earth, land, and the water bodies is managed by the global solar radiation. And the spectrum of solar radiation consists of ultraviolet 8%, visible 42.3%, infrared 49.4%, which falls in the range of wavelength of 100 to 400 nanometer, 400 to 700 nanometer, and 700 nanometer to 100 mm respectively. Actually, the global solar radiation is affected by different factors like the pollution, wind speed, sunshine hour, and the day length, temperature, altitude, relative humidity, solar zenith angle, and latitude, longitude, cloud cover, time of day, atmospheric effects, climate, weather, and factors like that. Okay. This is the instrument called pyranometer. Its name is CMP6 pyranometer. Actually, pyranometer is the device which is used to measure the intensity of solar radiation. Okay. My research work is to study of the global solar radiation of Pokhara Airport and the value by using the different meteorological parameters like sunshine hour, day length, etc. Then I will describe later. And all the value of these meteorological parameters like sunshine hour, day length, wind speed, etc., temperature, humidity, etc., are measured by this CMP6 pyranometer, And measured value of global solar radiation has been taken from the Department of Hydrology and Meteorology of Nepal and computed by using the empirical formula. Okay, this is our device. The pyranometer is a Greek word. Pyr means fire, ano means above the sky. Anything fire above the sky means the solar radiation. Simply, okay. It has the spectral range of 285 to 2800 nanometer, and having the operating temperature which ranges from minus 40 degree to 80 degree centigrade, and it has the response time of 18 seconds. Okay, and okay, this is our formula. This is called the modified empirical formula. Here, Hg by H0 equals to A plus B small n by capital N, where Hg and the H0 are measured in the extraterrestrial global solar radiation, which was measured in megajoule per meter square per day. Small n is the sunshine hour, capital N is day length, and the small a and the small b are the radiation coefficients. Okay, here S0 is calculated by using this formula, where the declination angle delta and the hour angle omega s are given by this formula. Here, every value of every here phi is the latitude, n is the day of the year. Okay, everything. Due to time limit, we can discuss in our question answer session. Okay, different statistical tools like root mean square error, coefficient of residual mass, mean bias error, and there is mean percentage error are here. These four statistical tools are also known as the performance parameter of the model. Model is the empirical model. These statistical tools are performance parameters. Okay. Now we go to the result and discussion section. All the results are the study of global solar radiation of the Pokhara Airport. Pokhara Airport is in the Pokhara Valley for the year 2016 AD. Okay. This is the empirical formula, as I have already described it. Yeah, from the global solar radiation, Hg is the measured value of GSR by the CMP6 parameter, and the S0 is the extraterrestrial radiation we computed by previous formula. Small n and the capital N. Small n is the sunshine hour, capital N is the day length. Okay, these are given. By using this formula, we have used all this formula and computed the value of A and B at 0.40 and 0.2. Okay, and for the year 2016, the sum of A plus B must be 1, and we use this value of A and B in the empirical model, and the value of sunshine hour, small n, and day length, capital N, for the year 2040 was used to compute the GSR, and that value was computed to be 15.98 megajoule per meter square per day, which is the average value of GSR for the year 2014. And the average value of global solar radiation for the year 2016 is measured to be 16.05 megajoule per meter square per day. Okay. So we have calculated the value of GSR for the year 2016. Then the value of A and B are used to predict the GSR for the year to come. But for this, we need to have the value of small n and capital N. Since the value of small n and capital N is not found for the year of 17, 18, 19, we have compared our work with the year 2014, which seems nearly equal. Okay. Yes. Different statistical tools, RMSC is found to be 0.323, MB is found to be 0.160, MP is found to be 8.92%, CRM is found to be 0.159, and the coefficient of determination is R is 0.643. These all performance parameters shows that shows the significant variation of the estimated GSR. Estimated GSR, we use the regression analysis to estimate the GSR. Okay, from the given value of GSR that was measured by the CMP6 parameter. Okay. This is the graph showing the variation of GSR, daily variation of GSR at Pokhara Valley. The maximum is due to the different factor, like the different meteorological factor. Okay, we can see the maximum peak is there. At that time, the day might be sunny day. Okay, एकदम sunny day and clear sky, etc. And the low peaks shows that at that time the day might be cloudy, where water rainy, cloudy, dust particle, etc. can affect. Okay. This shows the monthly variation of GSR. We can easily see that during April, maximum GSR is found, and in December, minimum GSR is found as 13.62 megajoule per meter square per day. This is the seasonal variation. During spring, it is found to be maximum 7.44 in megajoule per meter square per day, and during winter, we found 14.43. Okay. This is the variation of GSR with sunshine out. They have a direct relationship. As the sunshine out increases, GSR also increases, and the vice versa. We can easily see from the graph. Due to time limitation, I go very fast. Then I will discuss the previous session. Okay. And this is the relationship between GSR and the rainfall. As the rainfall is high, the GSR is low. As the rainfall is low, GSR is high. This is the relationship between GSR and the relative humidity. As you know that as the relative humidity increases, they have the inverse relation. Okay, and as the temperature increases, GSR also increases, and the GSR decreases with decreasing temperature. They have the direct relationship. With the wind speed, they also have the inverse relationship. During the high wind speed, low GSR is found. During the low wind speed, high GSR is found. Okay. Okay, this graph shows the relationship between the predicted and the measured value of the clearness index. Hg by the ratio of Hg by S1 is called the clearness index. From this analysis, it is shown that the coefficient of determination R square is 0.643. Which is in good agreement with our result. Okay. Finally, I am in a conclusion. From this, we can find A and B, whose value of A and B must be 1, 0.40, and 0.15. This means 0.6, as nearly 6, and this means our work is in good agreement and valid, and the value of A and B are used to estimate the value of GSR for the year to come. Okay, and the average value of GSR for the year 16 for the year 2016 and 2016 was measured as 16.05 megajoule per meter square per day, and the computed value of 2014, that the value of A and the B are used to compute the value of 2014, the average value of average GSR value of 2014, which is found to be 15.98. And why I use this value for the previous year? This is due to the reason that we could not find the value of sunshine hour and the day length. Okay, as I already said that seasonal and the monthly variation are found to be this and 17.76 and 13.62, and similarly 17.44 and 14.43 on April and December for the month, maximum and minimum, and for spring and winter respectively. Okay. The overall confidence parameter RMSE, MBE, MPE, CRM, and R square are significant. The variation of GSR is due to the effect of different geographical and physical parameters. So we can recommend all of you to work on the same data by minimizing the errors. To study the same recommendation, to study the same data by minimizing the errors as far as possible, and also by using the other parameters and analyze them to find the GSR potential in different regions of Nepal with the single climatic and geographic location and conditions. To compare the major ground level GSR with the corresponding satellite GSR, one can do research to make a solar mapping for Nepal. Modern facilities should direct towards solar vehicles, solar heaters, and many power tools. Most researches should be carried out based on how to utilize GSR. Okay, due to time limitation, I have stopped it here. we can discuss more in the question answer session. Thank you so much.
Hello, welcome to International Web Conference on Advanced Material Science and Nanotechnology. I am Mr. John from Physics Department, Shaming Bottom University of Agriculture, Technology and Sciences, Prayagraj, Uttar Pradesh. So I am here to present my work, doublet-shaped deflected ground slotted microstrip patch antenna. The antenna is a device which is used for the radiating and receiving the electromagnetic energy. It is also used. It can be also used for the convert the electromagnetic energy into electric and magnetic energy. Patch antenna is a device which is used for the telecommunication services at microwave frequency. Microstrip patch antenna is the type of the antenna. The contains introduction structure of work, result and discussion. Defective ground structure is analyzed by initial aging of a normal shape slots or defect in the ground surface plane, which is called defect or fault. Defective ground structure simply means by the word that some defects or fault can be introduced in the ground plane of the structure. So, requirement of DGS, it was used for the site reduction, cross polarization reduction, matrix coupling reduction, and antenna errors. It is used for the improved performance, compact size, lower cost, and there are the different shapes of the defective ground structure. Defective ground structure as rectangular shape, square shape, circular shape, L shapes, concentric ring, hexagonal, and the defective ground structure is liquid periodic or aperiodic defective configurations. I work to design and simulate study of doublets of microstrip patch antenna with defected ground and slotted patch antenna for the multi-band application with help of the high frequency simulation circuit. It is also used for the performance and another object is the performance analysis of optimized microstrip patch antenna with directivity, gain, return loss, and VSWR. The simulation study of the fractal antenna. The proposed method is simulated with the substrate FR4 dielectric constant 4.4 and thickness 1.5 mm at frequency 2.2 GHz with the help of the high frequency simulation software. In the present work, the rectangular shape of the defect is introduced on the ground plane of the structure, and the slot rectangular shape of the slot it has been cut on the patch of the antenna to improve the performance and enhancing the return loss of the structure. This is the structure of the proposed antenna. There is the doublet shape of the microstrip patch, and there is the square shape of the slot. There is the square shape of the defected ground. Use the defect or fault on the ground plane of the structure. This is the general specification of the proposed work. There is the material FR4 substrate, the dimension of the ground, dimension of the substrate, dimension of the patch, dimension of the field. By the work, result has got that of antenna parameter, return loss, gain, directivity, voltage, standing wave ratio. The defective ground plays very important role for the microstrip patch antenna because there is a frequency sensitive antenna which is used for the multiple frequency applications. With the help of the defective ground structure, the effective inductance and capacitance can be increased. The return loss gain, bandwidth, and ensure the better result as compared to the non-DCS structure. The return loss, this is the curve of the return loss at 12.85 GHz. The return loss is minus 26.86. The return loss always should be less than minus 10 dB. The gain at 12.85 GHz, the gain is 0.736, which is useful for the antenna. The directivity at 12.85 GHz, the directivity is 4.56 dB. Voltage standing wave ratio is used. It is the amount of the transmitting receiving electromagnetic wave of an antenna over a particular band of frequency. And the VSWR at 12.85 GHz, it is 0.778. It should be very minimum, and the voltage standing wave ratio is always less than 2. This is the radiation pattern. The radiation pattern is the directional variation in intensity of the radiation from the source. I conclude my work with the that the VGS effective cloud structure has a significance for the good radioactivity and the return loss and enhancing the performance of the design structure. So the structure is operating at 12.85 gigahertz, and that is the gain band. The impedance of this slotted VGS antenna is around 34.68 ohm, and actually series 1.4. This presented antenna is supported for different gain band application, for example, satellite communication, microwave towers, radio astronomy services, mobile services. These are the some of the references which I have used for my proposal.
Hello everyone, this is Dr. Smita A. Patil from P.R. Bhoti College of Engineering and Management, Amravati. Here, I'm delivering a presentation on Raman spectroscopy for cancer diagnosis. This is the abstract of my paper. Early cancer diagnosis is very difficult by conventional diagnostic method. Most of the biological molecules are Raman scatterers, and hence Raman spectra can capture a fingerprint of specific molecular species and can, therefore, be potentially used for biomedical applications. In the present work, we have discussed the difference between Raman and fluorescence spectra. We have reviewed the literature and analyzed the normal and cancerous samples by recording their Raman spectra. Conventional method of cancer diagnosis. Biopsy is the conventional method of cancer diagnosis. Biopsy is the removal of tissue from any part of the body to examine it for disease. Complications that arise from biopsy may include bleeding, infection, accidental injuries to adjacent tissues or organs. Also, pre-cancer such as dysplasia and carcinoma in situ, which are only 0.2 to 1 mm thick, are very difficult to detect by biopsy. So, in order to remove these drawbacks, new techniques for cancer diagnosis can be developed. Tissue autofluorescence spectroscopy can be successfully used to diagnose early cancer, but it has some drawbacks as the spectral features are broad and show less specific difference between normal and cancerous tissue. Most of the biological molecules are Raman scatterers. Raman spectra exhibits sharp spectral features and thus provides more information about a given tissue. Here, the diagram showing the fluorescence and Raman scattering. Here, the literature review is given. Several groups have studied the potential of Raman spectroscopy for detection of breast cancer. Raman spectroscopy of various gynecologic tissues were first studied by Alfano et al. Characteristic Raman feature of normal tissues and malignant tumor on the cervix, uterus, endometrium, and ovary were studied. Red et al. Employed Raman spectroscopy to study the malignancy of human breast tissues. Feld and colleagues have done extensive work on using Raman spectroscopy for breast cancer. The experimental arrangement is discussed here. Samples of tissues were collected and their Raman spectra were recorded. This setup consists of diode laser, a transversive imaging spectrograph with holographic grating. The 785 nanometer laser is coupled to 200 micrometer core diameter fiber. The optic arm of the probe consisting of collimating lenses, a bandpass filter, and a focusing lens delivers the laser light onto the tissue. The other optic arm of the probe, equipped with collimating and refocusing lenses and a holographic notch plus filter, is used for correcting tissue Raman signals. The holographic notch filter is used to block the Rayleigh scattered excitation laser light while passing the frequency shifted Raman signals.
The scattered radiation is detected by the intense radiation of nitrogen-cooled CCD camera, which is controlled by computer. Here the Raman spectrogram for 4 different tissues are shown. Result and discussion. We have recorded the spectra of 4 tissues samples at 6 different positions. The height of the peak displays the degree of malignancy. The curve for normal tissue appears to be at lower intensity, whereas the curve for malignant tissue appears to be at higher intensity. Also, the peak of the curve shifts to a longer wavelength as spectra moves from normal to cancerous cell. For example, the peak at 1425 cm inverse for normal tissue in first sample attributes to collagen. However, in malignant tissue, collagen band was found to shift to 1445 cm inverse. Conclusion. The position, intensity, and shape of peaks in Raman spectra of cancerous tissue were significantly different than those of normal tissues. The detailed study of vibrational levels of biomolecules such as amino acids, structural proteins, and lipids can help in the study of differentiating cancerous cells from normal ones. More number of Raman spectra are to be recorded and investigated so that the degree of malignancy can be studied. Development of Raman instrumentation is also needed to make it reasonable so that it becomes affordable to the people.
Welcome to all of you. My topic is, that is the title of presentation, is a study of intermolecular interaction of aqueous urea fertilizers at different concentration and different temperature. My supervisor is Dr. Ajay Larson. He is currently working in the Department of Physics, Amarashan Mahavidyalaya, Yavatmal. He is also working as a chairperson, Board of Studies, Physics, Sangadi Baba Amravati University, Amravati, and presented by myself, that is the Paritosh Mishra. These are the contents that we are going to explain in this presentation, that is the introduction, instrumentation, parameters, results, and discussion, conclusion, and analysis. So number 1 is the introduction, that is the structure of urea. We are selected the urea because it contains 46% of nitrogen, which is essential basic material for the chemical industry as well as in fertilizers for agriculture. These are the basic structure of urea, which contain the 2 NH2 group and 1 CO group. The ultrasonic parameter and characterization helps to forecast and understand the behavior of intermolecular interaction strength as well as the peak of the liquid mixture present in the system. In view to above facts, the ultrasonic velocity and density measurement studies on fertilizer of number of concentrations vary from 0.02 to 0.2 mol per kg at different temperature. The various thermodynamic, volumetric, and acoustical parameters that can be determined through this density and velocities are isobaric thermal expansion coefficient, pseudo-granulation parameter, hydration number, operant molar volume, internal pressure, solidity parameter, thermal constant, thermal conductivity. Hence, the study explores the structural sense of the liquid mixture, and results have described on the basis of intermolecular interaction existing in the system and structure making or breaking effect. These are the instruments we have used for performing our experimental, that is the digital ultrasonic interferometer and cell. For determining the ultrasonic velocity operating at 2 MHz frequency. Next is the thermostat. Thermostat is used for circulating the constant temperature of throughout the experimental. Digital weighing machine for weighing the amount of the substance, and density bottle. We have used 10 ml specific gravity density bottle for measuring the density of the liquid or solution. So these are the parameters of defining relation which we have determined to compute our results. There are actually 8 parameters here we describe, but actually we determine near about 30 parameters. On that basis, we can compute our results. coefficient, sublimation parameter, hydration number, operant molar volume, internal pressure, solidity parameter, van der Waals constant, and thermal conductivity. We are explaining only 8 parameters due to the lack of time. So these are the results which we have obtained after the calculation. This is the ultrasonic velocity and density, isothermal expansion coefficient. It is of great importance in order to understand the change in the structure of solution during mixing. This confirms the decreasing in the fluidity of solution due to more interaction between the component of solute and solid molecule. Second one is the sublimation parameter. Sublimation parameter, this parameter measures the degree of molecular or ionic association. The eliminating value suggests the probable formation of intermolecular complex in the system and strong molecular interaction. Next is the hydration number. Hydration number is also known as solution number. Actually, it is one of the important parameters in terms of explaining the degree of interaction and structure, making or breaking behavior of the solid molecule. After that, we have determined apparent molar volume. Apparent molar volume is one of the important molecular parameter and helpful in order to understand the degree of interaction present in the solution. As shown in figure, all the calculated values of apparent molar volume are positive. The behavior supports that there is strong interaction existing in the fertilizer solution. Next is the internal pressure. The obtained trends of internal pressure supports the association among the constituent molecules of the solute and solvent. After that, we have determined the solubility parameter. Solubility parameter, the trends of the variation of solubility parameter is similar to that of the internal pressure, such as increase may attribute to an increase in the cohesive energy, viscosity, and density, and favors the rate association among the component of solution. After that, we find out the van der Waals constant B. The van der Waals constant shown in figure represents the effective volume of molecule. The change in van der Waals constant would be due to the change in internal geometry. And last one is the thermal conductivity. The theoretical value of thermal conductivity of solvent shows good agreement with the literature data. The increase in thermal conductivity with increase in concentration and temperature creates the flow of energy is possible where molecules get close to each other. This means in present system, intermolecular interaction taking place, it confers with rise of velocity and density and hence drop of free length values due to close packing structure. On the basis of the above result and discussion, we concluded that in the light of above observation and discussion, it will be concluded that the concentration nature of solute nature of solvent and its position plays an important role in determining the interaction occurring in the solution. From the optical and volumetric parameters, it is concluded that hydrogen-bonding interaction is strong at higher concentration. Third is the thermoacoustic, physicochemical, and volumetric parameters exhibit the strength of molecular interaction. It promotes that the urea behaves as a structure breaker while dissolving in water. And last one is the figure shows that the possibility of hydrogen bonding between the urea and water. These are the references which we use for making our article. Last one is thanks.
Hello, I am Dr. Sonal Bapre, Assistant Professor, Department of Physics, Shri R.R. Lahoti, Science College, Morshi. My research paper title is Effect of AC Conductivity of Proton Conducting Solid Polymer Electrolytes. Abstract. A proton conducting solid polymer electrolytes of polyvinyl alcohol with ammonium bromide having different composition have been prepared by solution cast technique. The increasing amorphous nature of polymer electrolyte by addition of salt is confirmed by X-ray diffraction analysis. The ionic conductivity shows that 2.5 mole% low ammonium bromide in PVA polymer electrolyte has been maximum conductivity. The conductivity were measured using 4284 LCR meter in frequency range of 20 Hz to 1 MHz and at different temperature. Keywords: polyvinyl alcohol, ammonium bromide, X-ray diffraction, AC conductivity. First, we see the introduction. In recent years, electrical conduction in polymer have been studied to understand the nature of charge transport. Different types of conduction mechanism have been suggested for the charge transport. Polymer is good insulating material with low ionic conductivity. To increase the ionic conductivity depends on the addition of some dopant ammonium salt in polymer. Ammonium salt have excellent proton donor. Polyvinyl alcohol have been particular chemical and physical properties as well as industrial applications. Its good film forming nature, high dielectric strength, good charge storage capacity, and dopant-dependent electrical and optical properties. It has carbon chain backbone with hydroxyl group attached to methane carbon. Many researchers have been reported to enhance the electrical properties of PVA, that is polyvinyl alcohol, blend another polymers with inorganic dopant. So in present work, to study the AC electrical conductivity, proton conducting solid polymer electrolyte. Experimental technique. Polyvinyl alcohol with molecular weight, ammonium bromide and deionized distilled water as a solvent have been used to prepare proton conducting solid polymer electrolyte by solution cast technique. In this technique, polyvinyl alcohol and ammonium bromide have been dissolved separately in deionized distilled water by mole percent. Then different molar ratio of ammonium bromide in PVA and the solution stir were using magnetic stirrer until homogeneous solution was formed. Then homogeneous solution was casted in petri dish and evaporate slowly at room temperature. The films have been formed with uniform thickness and then cut into the small pieces. And this film is prepared the electrolyte. The AC conductivity were measured using 4284 LCR meter in frequency range of 20 Hz to 1 MHz and at different temperature. Result and discussion. First, we see the X-ray diffraction analysis. The figure shows that X-ray diffraction pattern of pure PVA and PVA with ammonium bromide with 10 to 25 mole percent ammonium bromide added in PVA. This A shows that the pure PVA and B shows that the PVA with ammonium bromide with 10% and C shows that the PVA with ammonium bromide with 25 mole percent. The broad peak is observed for pure PVA has been shifted in the complex formation. The salt added system has been found to increase in body and decrease in intensity. The broadening of the peak due to the addition of ammonium bromide is attributed to increase amorphous polymer complex electrolyte. The broadening of the peak due to addition of ammonium bromide is attributed to increase amorphous polymer complex electrolyte. Thus, the X-ray diffraction analysis reveals the complex formation between polymer and ammonium salt, that is ammonium bromide. AC conductivity. The figure or the graph shows that the variation between AC conductivity with frequency for pure PVA with ammonium bromide with 10 mole%, and then PVA with ammonium bromide 25 mole%. It is observed that conductivity increases with increasing frequency in all compositions due to more number of free ions. This will increase mobile of charge carriers. This graph shows that region, that is two regions, low frequency region and another is high frequency region. In low frequency region, more and more charge accumulation occur at electrode and electrolyte interface, and to decrease the number of mobile ions and conductivity also decreases. Therefore, the electrode polarization effect is occur. And the middle region is plateau region, is representing the DC conductivity. In high region, AC conductivity is increases due to high mobility of charge carrier, and it is related to the variation of bulk conductivity. It is found that the AC conductivity variation with the frequency follows the universal Johnson law, that is universal power law. This figure 2 shows that the conductivity of polyvinyl alcohol increases with increasing salt concentration up to 25 mole% due to the enhancement of ionic mobility and the large number of carriers ion being introduced into the complex. Conclusion. The proton conducting polymer electrolytes of polyvinyl alcohol, ammonium bromide with different mole% have been prepared by solution cast technique. The increasing amorphous nature of polymer electrolyte has been confirmed by the X-ray diffraction analysis. It is found that AC conductivity variation with frequency follows the universal Johnson power law. References. Thank you.
A very good morning to one and all. Respected Chairman and examiners of this session of International Web Conference on Advanced Material Science and Nanotechnology, that is NANOMAT-2020. Myself, Dr. A.B. Kohre, Assistant Professor in Physics, Sri R.R. Rao Science College, Mosh. I am here to present paper on topic Effect of Oxidant on Temperature-Dependent Electrical Conductivity of Polyvinyl Composite Films. Content of my topic are Introduction, Experimental Method, Results and Discussion, Conclusion, and References. Let me start with the introduction. Polymers, which are generally flexible, processable materials having electrically insulating properties. But the term conducting polymers become more popular in the year 2000. Reason is that three scientists Shirakawa, Higer, and McGiarney were awarded with the Nobel Prize. So conducting polymers have high electrical conductivity and non-metallic temperature dependence of conductivity. If we combine these two, that is traditional polymers and conducting polymers, then we get conducting polymer composites which provides good mechanical properties and processability associated with electronic conductivity, electrophorism, chemical sensing properties, etc. Conducting polymers have lot of applications in microactuators, electrostatic discharge, conducting coating, corrosion protection, battery, sensors, etc. Experimental methods. Here, all these reagents and solvents were obtained from the commercial sources and were used as a residue. Synthesis of the composite films
were done by the chemical oxidative polymerization method. Films with different concentration of oxidant FeCl3 were prepared by casting technique. Thickness of the film were measured by digital micrometer, which has a least count of 1 micrometer. To measure DC conductivity, two-probe method was used, and conductivity was measured over the temperature range 300 to 358 Kelvin. Then result and discussion. The variation of DC conductivity with concentration of FeCl3 weight percent for PPY PVAC composite films at temperature 323 Kelvin is as shown in graph. So here it is observed that initially conductivity increases, it becomes maximum for 25% of FeCl3 and then decreases. Many researchers reported similar bell-shaped conductivity isotopes with respect to oxidant concentration. Increase in conductivity with FeCl3 was explained on the basis of formation of polypyrrole conducting network due to well-dispersed polypyrrole in the structure of composite. Next figure gives the Arrhenius plot of PPY PVAC composite films. It also gives the temperature dependence of DC conductivity. From this plot, it is observed that conductivity increases with increase in temperature. As the temperature increases, mobility of ions increases, which result rise in conductivity. For 25% of FeCl3, conductivity is maximum. All the curves are linear, hence follows Arrhenius law. The slope of the Arrhenius plot decreases, suggesting the activation energy for conduction decreases. The activation energies for conduction and pre-exponential factors for different FeCl3 weight percent are given in this table. Variation of activation energy with FeCl3 weight percent is as shown in figure. It is observed that values of activation energy decreases with FeCl3 weight percent and again increases for higher concentration of FeCl3. The activation energy is minimum for 25 weight percent of FeCl3 indicates that charge carrier require minimum energy to hop along conducting network and shows maximum conductivity. Composite films with lower concentration than 25 weight percent and also of higher concentration offer high resistance to hopping of charge carriers and shows higher value of activation energy. Then conclusion. Composite films can be prepared by chemical oxidative polymerization. DC conductivity depends on FeCl3 weight percent and maximum for 25 weight percent. Increase in conductivity is due to FeCl4 minus ions. Further increase in FeCl3 weight percent shows decrease in conductivity, and it is due to segmental motion of PVAC. Conductivity is temperature dependent and follows Arrhenius law. Activation energy is low for 25 weight percent of FeCl3 indicates that charge carriers require minimum energy to hop along conducting network and shows maximum conductivity. These are the references which I have referred. Special thanks to the director and head of the physics department from Government Vidarbha Institute of Science and Humanities, Amravati, for providing laboratory facility. I am also thankful to Principal of Sri R.R. Lahoti Science College, Morshi, for his constant support and motivation. I am also thankful to the organizer for giving me an opportunity to present paper and successfully organizing such mega conference during lockdown period. So once again, thank you very much.
Hello everyone, my name is Ajay Vijay Ambore. I am Assistant Professor in the Department of Physics at Vinayak Vignan Mahavidyalaya, Namgaon, Khandeshwar, Amravati. My topic of presentation is solid dispersion technique, which is an alternative approach to controlled release drug delivery system using drug polymer suspension. In the introduction, the drugs which are having poor water solubility, they often show poor oral bioavailability due to the low levels of absorptions. Drugs that undergo dissolution rate limited absorption. Their dissolution rate can be enhanced by reducing the size, which is called as micronation. But this leads to aggregation of particles, which leads to poor wettability of the particle. Various other approaches for increasing the bioavailability of poor water soluble drugs include: first one, salt formation; second, solubilization using a co-solvent; complexation with cyclodextrin; and fourth, particle size reduction. Now, the definition. Solid dispersion is defined as dispersion of one or more active ingredients which should be hydrophobic in an inert carrier which should be hydrophilic at solid state prepared by the following methods. There are many methods, around 8 to 9 methods, from which we are using 3 methods. First one is solvent evaporation method, melting method, it is also called as fusion method, and melting solvent method. In this graph, we can see that the accumulative dissolution against the timeline. The graph for these three methods are equivalent. Now, how this method works? When the solid dispersion comes in contact with the aqueous medium, the inert carrier dissolves and the drug is released. The increased surface area produces a high dissolution rate, thus increasing the bioavailability of poorly soluble drugs. Now, talking about the polymers. Polymers used in this solid dispersion method. First is polyethylene glycol, called as PEG. These are compounds are obtained from a reaction of ethylene glycol with ethylene oxide. PEGs whose molecular weight is above 3 lakh are commonly termed as polyethylene oxides. Next is phospholipids. Solubility of phospholipids is intimately linked to the conformation of the aggregate material rather than strictly a chemical function of the molecule. Monoacyl phospholipids, which tends to form a micelles, are usually more rapidly soluble in aqueous solutions. Next is PVP, that is polyvinyl pyrrolidine. PVP molecular weight ranges from 2500 to 30 lakh. It is having solubility in solvents like water, ethanol, chloroform, and isopropyl alcohol. PVP gets decomposed at higher temperature. Therefore, it is not suitable for preparation of solid dispersions prepared by melt method because melting takes place at a very high temperature. Now, next polymer is cyclodextrins. Cyclodextrins are primarily used to enhance solubility, chemical protection, test, masking, and improve handling by the conversion of liquids into solids by entrapment. Now, there are some advantages of using this cyclodextrins. First is increasing the stability of the drug. Next, release profile during gastrointestinal transit through modification of the drug, release site and time profile, decreasing local tissue irritation, and masking unpleasant test. Characterization of solid dispersion. There are various methods for the characterization, such as drug carrier miscibility, hot stage microscopy, differential scanning calorimetry, polar X-ray diffraction, spectroscopic methods like Raman spectroscopy and FTIR spectroscopy. Physical structure.
to know the physical structure, one can use scanning electron microscopy, that is same surface area analysis, surface properties, dynamic vapor sorption, inverse gas chromatograph, atomic force microscopy, Raman spectroscopy, etc. Now, coming to the conclusion, increasing the bioavailability of a poor soluble drug is a challenging aspect of drug development. Because of the poor aqueous solubility, the drug possesses dissolution problems due to which the absorption of the drug is reduced and thus the bioavailability is reduced, making the drug inappropriate for oral consumption, and therefore solubility enhancements become necessary for such drug candidate. Solid dispersion using polymers is a most simple and efficient technique for increasing the aqueous solubility of a drug. Thank you.
Hello everyone. I am Dr. Sugandha Vithala Kangarwad, Assistant Professor, Department of Physics, Mahatma Phule Arts, Commerce and Sitaramji Chaudhary Science Mahavidyalaya, Varud. I am presenting this topic, frequency and temperature dependence of ultrasonic properties of aqueous polymer solution using pulse echo technique. These are the outlines of my present work. For introduction to ultrasonics, ultrasonic is a term meaning the applications of ultrasound having frequencies beyond the audible limit, that is of 20 kilohertz to 1 gigahertz. This technique is a convenient and powerful tool to probe the properties of the medium, since most of the phenomena such as molecular interaction, but chemical kinetics, molecular relaxation, molecular conformations, etc. The ultrasonic technique provides an ideal method for studying the physico-chemical properties of the material. The study of interaction in solution provides the valuable information regarding the internal structure, internal pressure, molecular association, complex formation, phase separation, compatibility, miscibility, etc. Now, this is about the introduction to polymers. What is polymer exactly? The polymer is a large molecule, that is, we can say macromolecule, composed of repeating structural units called as monomers. Polymers are classified into three types. One is the natural polymers, which included cotton, wool, paper, silk, and rubber, etc. Semi-synthetic polymer, that is the cellulose, and the synthetic polymer, that is polyvinyl alcohol, that is PVA, polyvinyl pyrrolidine, polyacrylamide, etc. In this system, now why do we use this synthetic polymer? Nowadays, economically attractive raw materials and processes support the economics of many generic industries that are totally dependent on the synthetic polymer. The growing interest in polymer material is because of their strengthening stability, toughness, liability, decorative surface effects, etc. The polymer science is a fascinating subject, and there are many demanding challenges awaiting scientists who venture into the study of polymers. Now here, we have chosen the synthetic polymers as a PVA having structural formula C2H4O N times. Then PVP, that is polyvinyl pyrrolidine, that is C6H9NO. Now, to study these ultrasonic parameters, I have used this technique, that is the pulse echo technique, which is my experimental technique. In this, I measure the viscosity. Viscosity measurement is done by using Oswald viscometer, density measurement by the pygmometer method, and the velocity I measured here by using MHF 400 ultrasonic pulsar receiver. Also, I maintain the temperature range by using plastograph thermostat. Result and discussion. Here I use the system, that is the systems under investigations are polyvinyl alcohol, that is PVA, and water, and the polyvinyl pyrrolidine and water, that is we can say aqueous polyvinyl alcohol solution and aqueous polyvinyl pyrrolidine solution. Now see your discussion. Here the various parameters, that is the ultrasonic velocity. I have measured the ultrasonic velocity at 2 megahertz and 5 megahertz. So see here, this is at maximum temperature, that is 308 temperature, and this is at minimum temperature, that is 288 Kelvin. So in both the frequencies, the velocity will be nearly, velocity changes nearly same. That is, velocity increases at higher temperature and decreases at lower temperature from the graph. Also, with increasing concentration in weight percent, velocity will is also increasing here. So it is observed that the ultrasonic velocity increases with increasing concentration of polyvinyl alcohol in water, indicates the association in the component molecule. The association in the constituent molecule may involve due to hydrogen bonding or due to dipole-dipole interactions between the constituent molecules. All these processes may lead to strong interaction forces. We have used the solute PVA, trap into the cavity and formed by the water. Therefore, the solution becomes thick, is responsible to increase the ultrasonic velocity. Now, this slide is related to the density and velocity. See here, increase in density, decrease the volume, indicating association in the component molecule. The increase in density is due to the fact that the number of polymer chain added to the solution increases with increase in concentration of the polymer solution. This viscosity depends upon the molecular interaction as well as, now see here, this is the viscosity graph. The viscosity increases with the viscosity depends upon the molecular interaction as well as the shape and size of the molecule. Here, velocity increases with increasing concentration. The dipole-dipole interaction of permanent dipole in a constituent molecule increases the viscosity in the polyvinyl alcohol solution system. Now this is about the second system, that is the polyvinyl pyrrolidine plus water, that is PVP plus water, or we can say aqueous PVP. Now see here, in same way I have discussed in PVA, the ultrasonic velocity in PVP is also higher at higher temperature, and which is also increases with increasing concentration. So it is observed that the ultrasonic velocity increases with increasing concentration of polyvinyl pyrrolidine in water, indicating association in the component molecule. In present system, ultrasonic velocity is also increases with increasing temperature. Now see here, density also increases with increasing concentration, and also with decreases with increasing temperature. At higher temperature, density is less. It is observed that the density increases with increasing concentration of PVP in water. Now this is related to the viscosity. It is observed that the viscosity linearly increases with increasing concentration in water, because the viscosity depends upon the molecular interaction as well as the shape and size of the molecule, increasing the temperature of the substance, decreasing its density and viscosity also. Now come towards conclusion. The linear nature of ultrasonic velocity suggests the miscibility of polymer indicated by the single phase formation, and thus suggesting compatibility of the polymers. The thermoacoustic parameters such as the ultrasonic velocity, density, etc. indicates the strengthening of the molecular interaction, molecular bonding we can say, in the binary liquid mixture of the polymer. Now, these are the applications, that is the ultrasonic study of water-soluble polymers offers the potential to increase the drug circulation time, to improve the drug solubility, and hence increase the drug absorption in this study. So PVA plus water and PVP plus water system in particular concentration in weight percent has maximum ultrasonic absorption value as compared to the literature. One can be used as a tablet binder in medicinal purpose owing to its water solubility. Now, this application I have found from the ultrasonic velocity measurement have been extensively applied for assessing the molecular interactions in pure binary liquid mixtures. It also determines miscibility, compatibility, or semi-compatibility present in the system. Now, this is the future scope of my work. The development of molecular theory for absorption based on the latest development in the statistical mechanics. This theory could successfully reproduce the temperature and concentration dependence of compressibility, ultrasonic velocity, and density of the binary liquid mixture of the polymers observed experimentally, and it have a better insight in various ultrasonic phenomena in
358.48 and retentivity is 301.41. Thank you.
Hello everyone. In this presentation, I'm talking about theoretical investigation of nonlinear optical properties of some Coumarin derivatives. We have synthesized two major series of Coumarin derivatives, out of which one contains coumarin moiety along with benzene sulfonohydrazide connection, and another series contains coumarin moiety along with benzamide group. We undertook the theoretical analysis of theoretical calculation of the nonlinear optical properties of both the series of molecules. We observed the molecules having coumarin and benzene sulfonohydrazide moiety exhibited a potential nonlinear optical properties. In this presentation, I'm only talking about those compounds which exhibit significant nonlinear optical properties. Coumarin is well-known chemical moiety among organic chemists. It's known for its sweet smell. It can be found in many naturally available materials like cherry, licorice. The sweet smell of lavender is actually partially attributed to coumarin, and apricots and strawberries, they all contain the coumarin. It has a freshly mown hay smell. And coumarin derivatives are significant, very important in organic or medicinal chemistry also. They exhibit some of the coumarin derivatives exhibit anti-cancer properties, anti-tumor properties. They have antiviral, anticoagulant properties. Further, these coumarin derivatives are very good fluorescent materials. Hence, they are being used for in-cell fluorescent imaging of organic two major series of coumarin derivatives, out of which one in this purview, coumarin derivatives along a very important benzene sulfonohydrazide connection. We synthesized, and as I mentioned, two major series of coumarin moiety along with I'm here presenting the synthesis of only that particular set of coumarin derivatives. Theoretical analysis of theoretical calculation of the nonlinear benzene sulfonohydrazide is combined with the molecules having coumarin and benzene sulfonohydrazide in the ethanol medium exhibited a potential that resulted in coumarin derivative containing this presentation. I'm only talking about those compounds which exhibit major significant nonlinear optical properties. And we undertook DFT calculations to theoretically optimize the molecular structure, moiety, to determine the molecular chemistry. We also computed NO natural bond orbitals, which helped us understanding and found molecular naturally available materials like the molecular orbitals of the sweet smell of lamp. As I mentioned, as it will make
the working liquid has been modified with super nanoparticle conjugated after 1 that has been selected particularly for quick transferring. So now you must be thinking what is metformin. There is nothing but a drug. It is psychoactive abused compound that is associated with serious health complications like deficits in attention, memory, and personality changes. So for silver nanoparticle synthesis, Celestina parapteris was the plant that was used, which is often called Sanjeevani booty for its desiccation properties. The same has been used as both reducing and treating agent. Then characterization was done using UV rays, FTIR, and flow. After characterization, aptamer was then selected using Telex technology, and then conjugates were then formed, and the conjugate was then top coated onto the working electrode. The target analyte can be detected when it interacts with the conjugate that had been already put onto the working electrode, since the target analyte is electrochemical in nature.
finally, the interaction gives the enhancement in the electrochemical signal and detection takes place. Now coming on to materials and methods. Silver nitrate reacts to water with a standard nucleotides for aptamers, which are currently unexpected to use. To that, H1 is plant extract. That was then first dried, washed and dried. Then these were collected like this. These were then grinded like this. 5 grams of pea powder was then mixed with 100 ml of distilled water and aqueous leaf extract was then taken that you can see over here. For instrumentation part, UV spectrometer, FTIR, scanning electron microscope, and electrochemical workstation were used. These are the objectives. First, to synthesize single nanoparticles and to characterize them, then finally finding the aptamers with the conjugate nanoparticle and aptamer, modifying the vertical to that conjugate and finally taking the mid-conjugate. Now coming on to the results and discussion part. So silver nanoparticles were synthesized using several volumes of leaf extract and several volume and concentration of EgNO3. So this is the table. Then these two solutions were mixed and kept under incubator shaker for 1 hour under 50 degrees Celsius. So this was the color that was observed from colorless after 1 hour of incubation. And after 12 hours of keeping under room temperature, finally the dark yellowish color was observed that indicated the presence of silver nanoparticle formation. Then under characterization, UV rays was used. This showed the prominent peak over here at around 40 nanometer for this particular solution. FTI showed prominent peaks at around these, and SAM also showed the presence of silver nanoparticles of diameter 40 to 60 nanometers. As FX technology was used, this is the structure of the chemical specific aptamer that was based upon the lowest free energy values using ample fluid. Conjugate was formed and further work still needs to be done using electrochemical workstation. That is the last step of the study. So finally it can be concluded.
Welcome sir.
Welcome to all. I am Dr. Sang. As they give successful interpretation of various remote sensing data.
And light is electrochemical enabled. So finally, the interaction gives the enhancement in the electrochemical signal and hence detection takes place. Now coming on to materials and methods of EGMP, they
present potassium at
EGMP in the initial stage, and then FTI also showed these peaks that indicated the presence of compounds like protein, flavonoid, and terpenoids, so responsible for reduction, keeping and stabilization. And SEM also showed the presence of keeping agent in the extract. And also, nanoparticles were polydispersed and concentrated and slightly aggregated. So it is confirmed that nanoparticles were formed using green synthesis, and the aptamer conjugate specific to the methamphetamine has been formed. Further work still needs to be done for final sensing using electrochemistry. Thank you so much. These are the references, and you can contact for further inquiry over here.
Hello everyone, I am Sayyida Ruhi Nishad from Maulana Azad College of Arts, Science and Commerce, Aurangabad. I am doing PhD under the guidance of Dr. Yusuf Anim Sheikh. I am here to present my research work entitled Effect of Potassium Nitrate on Dielectric Properties of Soil at X and J band Microwave Frequency. The outline of my presentation are introduction, sample preparation, method used, experimental technique, summary and conclusion. Introduction. Study of dielectric properties of different earth constituent at microwave frequency is very important as they give successful interpretation of various remote sensing data. There are different types of waves present in electromagnetic spectrum. Out of these waves, microwave has its vast importance
From cooking popcorn to study the galaxies, they are being used in different ways. Microwave electrical properties of material provide information about material characteristics. The natural nutrients found in the soil essential to plant growth, such as nitrogen, phosphorus, and potassium, are manufactured synthetically from inorganic material and applied to soil in the form of chemical fertilizers. Although chemical fertilizer improve the growth of plant and increase the yields of fruit and vegetable in a relatively short period of time. Sample preparation. For preparation of soil sample, two samples having black color and of white marginal textural difference were collected from Maharashtra. Soil were first sieved by standard sieve. The sieved out finest particles are then oven dried to a temperature around 180 degrees Celsius for half hour in order to completely remove any trace of moisture. Such dry sample is then called as oven dry or dry base sample when compared with wet. Soil sample of 4% gravimetric moisture content are prepared by adding an exact amount of distilled water to the known mass of oven dry soil. The soil samples are then prepared by mixing different concentration of potassium nitrate in 4% distilled water, and this mixture is then added to soil. These mixtures are kept in airtight sealing bags and allowed for few hours to facilitate internal drainage, homogeneous mixing, and proper settlement. These soil samples are then inserted into the solid dielectric cell for measuring their dielectric properties. Extreme care was taken to expose them to the atmospheric air as little as possible. Method of measurement of dielectric properties. The infinite sample method is used to determine the dielectric properties of fertilized soil sample. An X-band and J-band microwave setup in the TE10 mode with klystron source operating at frequency 9.8 GHz and 6 GHz respectively. Experiments were performed at room temperature range between 30 degree to 40 degrees Celsius. The solid dielectric cell with soil sample is connected to the opposite end of the source. The signal generated from the microwave source is allowed to incident on the soil sample. Figure 1 shows variation of dielectric properties of soil at X and J band for soil sample 1 for different concentration of potassium nitrate, which range between 0% to 12%. Figure 2 shows the variation of dielectric properties of soil at X and J band for soil sample 2 for different concentration of potassium nitrate. The dielectric constant and dielectric loss are calculated for two different frequencies. Figure 1 shows the variation of dielectric constant and dielectric loss of soil sample 1 with increasing concentration of potassium nitrate on X and J band. From graph, we can see that dielectric constant and dielectric loss decreases with increasing frequency. It is also observed that at particular frequency, the dielectric properties of soil increases with increasing concentration of potassium nitrate. Figure 2 shows the variation of electrical conductivity and relaxation time with concentration of potassium nitrate in soil sample 1 on X band and J band. It can also see that the conductivity at lower frequency is comparatively less than at higher frequency. Figure 3 and 4 shows the variation of dielectric constant, dielectric loss, relaxation time and electrical conductivity with increasing concentration of potassium nitrate on X and J band. Summary and conclusion. It has been observed that the dielectric constant and dielectric loss decreases as frequency goes on increasing. It is due to molecule having less time to rotate with increasing frequency that reduces polarization of molecule. It is also observed that as we increase the concentration of potassium nitrate, the dielectric properties increases slowly. The naturally available macronutrient of soil show variation in dielectric properties. Potassium nitrate in soil appreciably affects in dielectric properties. These dielectric parameters are useful for researchers working in the field of agriculture. Thank you.
Hi everyone, you are listening to Shoaib Khan from Department of Chemistry, Islam College, Nagpur, and today we are going to discuss about recent development in drug discovery for COVID-19 in reference to chloroquine and hydroxychloroquine. Insertion of RNA into the cell. Hydroxychloroquine is a weak base, causes the alkalization of endosome and lysosome, inhibits the endocytosis, and also stops the fusion of endosome with lysosome. Increase in endosomal and lysosomal pH decreases endosomal and lysosomal function, so inhibits the endocytosis. Second way of hydroxychloroquine is that hydroxychloroquine is also act as zinc ionophore. Zinc ions enter into cell through plasma membrane. Zinc prohibits RNA polymerase. Increase in the concentration of a zinc decreases the viral RNA formation. The third factor is presence of salicylic acid on a cell membrane. Salicylic acid helps to bind virus and enters into the cell. Hydroxychloroquine binds to salicylic acid and prevents the binding of virus to salicylic acid. In this way, hydroxychloroquine showing its antiviral activity. So what literature says about the use of hydroxychloroquine and chloroquine? So Portet et al. Have reported effective use of hydroxychloroquine with azithromycin in treatment of COVID-19 with and sees a good recovery in the patient. This study has several limitations, such as a small sample size, limited follow-up, exclusion of patients during treatment, and specific age group. However, another fringe group by Molina et al. Reported no clinical benefit and poor clinical outcome with this energetic treatment of azithromycin and hydroxychloroquine in coronavirus disease. They proposed that hydroxychloroquine acted as a protector for COVID-19 patient due to its antiviral and immunomodulatory effect. The maximum number of recovery or discharge was from control group and not from hydroxychloroquine treated group. Literature reveals that there are several disputes in the use of hydroxychloroquine for the treatment of COVID-19. Dr. et al. And Chen et al. Supports the use of hydroxychloroquine alone or in combination with antibiotics such as azithromycin. However, more scientists like Molina et al., Navis et al., and so many others did not support any significant effect or clinical outcome of hydroxychloroquine in treatment of COVID-19. Adverse effect. Several adverse effects associated with the use of hydroxychloroquine has been reported in the literature. Although hydroxychloroquine is less toxic than chloroquine, still it possesses some detrimental adverse effect which cannot be neglected. Some side effects like cardiac complications, QT prolongation to heart failure, neuromuscular side effects involves signal conduction disorders, nightmare, depression. Ocular side effects involve corneal deposition, blindness, blurred vision. Gastrointestinal side effects involve diarrhea, vomiting, abdominal cramping, nausea, abnormal liver function. Some allergic side effects also observed. Some other general effects like appetite loss, loss of weight also seen in the patients who are using hydroxychloroquine. So in conclusion, we can say that hydroxychloroquine shows antiviral effect against different viruses. Further, its use shows immunomodulatory effect. Extreme care is required for the hydroxychloroquine treatment in pregnant women, pediatric patient, and patient with comorbidity in coronavirus disease. The individual use of both these, hydroxychloroquine and azithromycin drug, are associated with QT prolongation. Misuse of hydroxychloroquine without the physician's advice should be avoided due to lack of strong evidences, which may result into one or more detrimental side effects. World Health Organization and several other countries like France, Italy, Germany has temporarily paused the clinical trials of hydroxychloroquine on 26 May 2020 owing to safety concerns. I would like to thank Head of Chemistry Department and the Principal of Islam College, Nagpur. Thank you for listening.
Colleges for this opportunity to present my work untitled on the topic the role of early defects on conformational statistics of a semi-self-awarding semi-flexible polymer chain. There is a general on it. So myself, Dr. Mutman Isra, I am from Mount University. The following conclusion of the presentation, I have concluded the terminology of polymer physics and motivation behind the full work. And the idea that I used, the model that I used to solve this problem, the method that I used in this problem, clear that I obtained and the conclusion that I have found on the basis of my present study. The references. So, polymer, poly means many, one means units. So, this is a polymer. So, for something that is monomer of the chain, sorry, kind of thing, bond between the two monomers of the chain. So, it is a linear object. In this case, we consider linear polymer chain. So, these monomers are identical. So, we have homopolymer chain. When monomers are different and distributed along the backbone of the chain randomly, we have a copolymer chain. However, when monomers are different more type of chemical units that monomers are RNA in sequences by a manner, and the backbone of the chain we have sequential copolymer chain. So monomer may be a chemical unit of this sort. So these two free units are oxygen part for the binding with the monomer. So polymer chain is a critical object. It's a volume of from the teachings and he got 1972 as a contribution in the field of polymer system. So in the case of space system, we have critical points. We have coordination and damaging the student, specifically damaging the student alpha, and disability damaging the student gamma. Similarly, in the case of linear polymer chain, in the long name frame, we have into distance of the chain damaging the student mu. Number of conforming number of linear chain damaging the student alpha. Number of conformation of the n monomer long chain damaging the student gamma. So this is so in that manner, this polymer chain polymer is a critical object. So theory of critical phenomena can be applied to discuss thermodynamics of the polymer system. So we have this schematic presentation. We have a schematic picture of a polymer chain in the solution. So we have the solvent molecules in solid circle, that is monomer of the chain. So monomer of the chain getting among each other through solvent molecules. So we indicate of solvent degree of freedom, which may lead to have monomer attraction may be attractive or repulsive. Monomer attraction repulsive, we have polymer chain good solution. In that situation, we have open chain conformation that will prevail. However, when monomer attraction is repulsive, attractive, we have polymer chain that will collapse. That is poor solvent condition. So, in this case, we have considered a semi-flexible polymer chain in presence of defects. So defects are lying along a line, and chain conformation is modeled in 2 dimensions as well as 3 dimensions. So in 2 dimensional case, we have square lattice. In 3-dimensional model, we have cubic lattice. So we have considered pre-dated self-awarding work model into a 3-dimension to describe terminals of the chain containing CM defects. So certain conformation of the chain may be suppressed or may be populated by inserting certain defects in the chain. So that way we can found polymer nano aggregates. So we have we may consider M defects in the chain, and for that defects we can have few reactions depending upon how the defects are distributed along the chain, line of defect. So this idea basically can maybe metallized. This critical that is this theoretical approach may be metallized using say atomic force microscope to synthesize artificial polymeric chain by inserting certain defect in the chain to control conformation and statistics of the chain. So that way we can have a polymer molecule of desired size may be useful to have a controlled behavior. And these defects are line. These defects are basically arranged along the line. And these defects need to have certain attractive or repulsive interaction with the monomer of the chain. So the model behind this model that we have used for this case is protracted chain, and there are references 1521. We can consider to CVT and subgroup model. So in this case we have a polymer chain. Say this is the polymer chain of CM monomers. So this is one monomer, this is another monomer, and so on. So these two circles bonded together is a single defect. So this is one defect. Basically, it's one here, and these are the monomers. One monomer, and so these are the monomers. So these, we have a same monomer long chain where there are two there. So if there is some flexibility, take into account, and enumerate all possible conformation of capital N monomers long chain to write partition function in the current sample. So since we have defects lying along the line, so T minus 1 into D power M as well conformation that is along another direction. Say in two-dimensional case we have the D power M as well conformation, two-dimensional case 2 into M as well and conformation that is defect free. So many conformation may have defects. So in this case, this is the general expression for the current partition function. The x is the fugacity of worker along defect line, and G is fugacity perpendicular to defect line. K is the boson weight corresponding to bending in the chain. And B is the number of bends in the chain. And see this P is the position of defect. M and P defects monomers are M and P monomers are in the direction perpendicular to defect line. And B is the bending shape. So in this case, we can write the exact number of defective chain conformation. So we have written exact conformations in this table. So this is the table. Say when we have 100 monomers long chain, so different position 1, 2, 3, and so on. In that case, we have square lattice. These are the conformation. When defect design position 1, we have this much number of conformation. When defect design position 2, we have this much number of conformation. Similarly, in the case of 3D, we have three-dimensional model. We have this much number of conformation. When defect design under the side 1. When defect design under side 2, we have this much number of conformation and so on. So we have exact number of polymer conformations. So exact number of polymer conformation can be used to get partition function, exact partition function of the chain. You can determine exact number of average number of length of the chain, average number of bends in the chain. And we can determine persistence length of the finite chain. However, in the long chain, in thermodynamic limit, or a small number of defects, we cannot see. We cannot appreciate the effect of the defects on the persistent length of the chain. So we have solved that model exactly for a directed work model on square based cubic lattice to get exact number of polymer conformation. So we can consider random chain and for possible two different realizations of the defects. So we can change position of defects to get all possible conformation of the defected chain. So using that we can determine size of the chain, say extension of the chain along x direction, extension along y direction, the origin length of the chain, and the size of the chain in 2 dimensions, and as well as 3 dimensions. So that way we can control size of the chip and found a polymer nano aggregate. So these are the references. Thank you.
Very good evening to all of you. We have resumed the session after the validatory function. Now we are moving towards the validatory. So now the guest can unmute their mic. Shinde sir, Sadhu sir, ma'am. Okay, madam. Del sir.
Hello, sir.
Firstly, our
Hello.
resume after the validity function. Now I call to Dr. Anant Vadatkar to give his concluding remark on this conference of NANOMAT 2020. And Dr. Anant Vadatkar.
Hello, sir. Bharat sir.
Yes, sir.
I am audible?
Yes, sir. You are audible, sir.
Yes. Thank you, sir.
आवाज कटतोय समजमध्ये.
Hello, sir.
Your voice is cut, sir. In between.
Hello. Hello. आवाज येतोय सर? Hello.
येतोय sir.
Chairperson of today's function, today's valedictory function of International Wave Conference on Advanced Material and Nanotechnology, NANOMAT 2020, Dr. Alka Bhise ma'am, Principal Vinayak Vignan Mahavidyalaya, Nandgaon, Khandeshwar, NANOMAT 2020, Chief Guest, Dr. N.G. sir, former Principal, Krishna Biyani Science College, Amravati, Senior Professor K.M. Jadhav, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad, Dr. R.S. Shinde sir from CAT Indore, RR CAT Indore, Director RR CAT Indore, IQAC Coordinator of our college and organizer of this conference, Dr. Suchita Kolke ma'am, convener of this conference, and my colleague, Dr. Prashant Rath, convener, Mr. Ajay Ambore, and all participants. I am very grateful to all dignitaries of inaugural function of this conference, as well as all resource persons from India and abroad, to give the feast of knowledge to all in their invited talks on advanced materials and nanotechnology and its relevant subjects. In this today's web conference, there are 9 technical sessions with 1 keynote address. Senior Professor K.M. Jadhav sir, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad, deliver the keynote address. In first day, there are 4 invited talks, 2 from India and 2 from abroad, delivered by Dr. R.S. Shinde sir, Raja Ramanna Institute, CAT Indore, Professor M.D. Sirsak, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad, Professor R.B. Sharma from South Korea, Dr. Pratiksha Dongre from Rice University, United States of America. In afternoon session, the participants presented their oral and poster presentations. In today's technical session, that is the second day of the conference, there are 5 invited talks, 3 from India and 2 from abroad, delivered by Professor Mahavir Singh, Himachal Pradesh University, Shimla, Professor Pankaj Koinkar, Tokushima University, Japan, Dr. Harsharaj Jadhav, Paingji University, South Korea, Dr. Bagule, Sant Gadge Baba, Amravati University, Amravati, and Dr. Ghosh from MIT Pune. For this conference, we received total 157 papers in the form of abstract. Out of that, 100, about 100 are oral presentations and more than 50 are poster presentations. Total registrations of the conference, including authors and co-authors, are 405. Here, I am happy to announce that the research outcome of this conference will be published in reputed and peer-reviewed Scopus Index journal. The name of journal is Journal of Physics Conference Series, according to their norms. Once again, I am thankful to today's chief guest, Dr. M.G. Velsare sir, Professor K.M. Jadhav sir, Dr. R.S. Shinde sir, for their unceasing blessing on us. Thank you, sir. Again, I am thankful to organizer, Dr. Alka Bise ma'am, Dr. Suchita Kolke ma'am, for their support to make the conference successful. Again, I am thankful to convener, Dr. Prashant Karat, co-convener, Mr. Ajay Ambore, and all my dear colleagues for their efforts to make the conference successful. Thank you very much, sir. Thank you.
Hello. Now I am request to Dr. Suchita Kodke, IPC coordinator of Vigyan Vinayak Mahavidyalay, to give her concluding remark. Kodke madam.
Thank you, sir. Am I audible?
Yes, madam, you are audible, but your camera is not on, I think.
Okay, just.
Yes, ma'am, camera is on, ma'am.
Okay. Good evening, all of you. Respected chairperson for this valedictory function, Dr. Alka Bise madam, principal of our college. Chief guest, Dr. N.G. Velsare, former principal, Brijlal Biyani Science College, Amravati. Dr. K.M. Jadhav sir, Dr. R.A. Shinde sir, organizing secretary, Dr. Anat Wadatkar, convener, Dr. Prashant Karat sir, and co-convener, Mr. Ajay Ambore, and all the participants, invited guests, resource persons of the various technical sessions. A warm welcome to all of you. So, hope you are safe and healthy in life and productive in work during this period, COVID-19. Friends, as we know that in every institution, IQC play a significant role in administrative bodies that is responsible for all quality parameters. So with this background, our college, that is Vinayak Vigyan Mahavidyalay, organized this for the first time, this online international conference on material science and nanotechnology, that is NANOMAT-2020. So today, this is a historical moment for all of us, because for this successful organization of this NANOMAT 2020. The objective behind this conference is to provide a unique platform for the scientists, researchers, for the discussion of the latest development, refresh their knowledge, and offer the plenty of network opportunities. It has also given an opportunity to interact with the leading researchers in the field of material science and nanotechnology. We have received an overwhelming response from all over the nations, and more than 405 participants have joined with us for this venture. Total 157 papers were presented by the researchers, which has highlighted a variety of topics. I hope that the intense discussion occurred during these sessions and have enriched the knowledge and opened up the new way for the budding scientists. Before I end, I would like to convey my heartfelt appreciation for all the participants by their presence. This is the huge success itself. I would like to express my gratitude towards the keynote speakers, resource persons of the technical session for delivering their informative and fruitful talks. I am also thank you to chairpersons and the jury members of the various technical session for sparing their valuable time with us. I cannot end without congratulating my colleagues, Dr. Anant Vadatkar, Dr. Prashant Kharar, Dr. Ajay Mbore, for their successful organization of this conference. So I personally believe that this 2 days conference must have been academic feast, and definitely it might have opened a new vistas in the field of material science and nanotechnology. Thank you once again.
Thank you, ma'am, for your remarks. Now I invite to Dr. NG Belsere sir to give his concluding remark.
Honorable Sulabhatai, Honorable Principal Dr. Alka Tai, Dr. Suchita Tai, the IQSC coordinator, Dr. Prashant Kumar, the convener, Dr. Vadatkar, the organizing secretary, Professor K.M. Jadhav, our very esteemed friend and a colleague of Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad, Dr. Arya Shinde sir, all the distinguished keynote speakers, resource persons, participants, and faculty members. A very good evening to you all. At the outset, I would like to express my sincere and very heartiest congratulations to you all for having substantially contributed to making this international e-conference a resounding success. I also very sincerely thank you all for making me part of this wonderful academic event. I express my sincere gratitude and gratefulness to you all for this very kind gesture of yours towards me. I have been given to understand that about 10 eminent speakers have delivered very educative, informative, and inspiring speeches in this 2-day conference. 157 research papers have been issued, and about 405 delegates have actually participated in the conference. The science of nanomaterials has produced the paradigm shift in the human scientific and technological endeavors, and they, the nanomaterials, are all set to make human life more secure, more protected, more comfortable, and more convenient on this planet Earth. The very idea of putting such an e-conference, such a magnificent size and magnitude, is a very thrilling and exciting proposition. I am deeply impressed by your courage, confidence, commitment, and integrity. The sheer tenacious toil, perseverance, and technological expertise demonstrated by the IQSC coordinator, the convener, the organizing secretary, in coordination with all the other faculty members, have resulted into making this event astoundingly successful. Till now, it was the popularly held belief that holding and organizing international conferences, seminars, symposia was the sole prerogative of the mighty institutions in the metro cities.
अरे
But
बच्चे नहीं
we
खाते
have
तो बच्चे जाए ना 25 टका जरूर 20 बहुत और से ज्यादा में मंगाना बच्चों ने जिस दिन खा लिया उस दिन मुझे मत देना
but
हमको
we
बहुत
have
फेवरेट
proved
नहीं
by example that they can also be held
हाँ
at a
ठीक अच्छी बात
small,
है, बच्चे खा लेते हैं
can be made in motivating and enlightening all the participating delegates on planning their prospective research. I once again congratulate the Honorable Principal, the IQC Coordinator, the Convener, the Organizing Secretary, and all the members for daring to organize such a mammoth, gigantic academic event and making it immensely successful. I very sincerely thank you all for the honor and privilege bestowed upon me. Thank you so much.
Thank you, sir, for giving your remark. Now I invite to Dr. R.S. Shinde, sir, to give you his remark. Dr. R.S. Shinde, sir. Shinde, sir. Okay, sir. Up to Sir Jain. I will request to Dr. K.M. Jadhav, sir, to give his remark on this NANOMAT conference.
Prashant, sir, he has joined. I think his mic is
yes, ma'am. I will resolve that problem till we are getting the remark from Dr. K.M. Jadhav, sir.
Sir, please unmute the mic.
Okay. Jadhav, sir.
Jadhav, sir, mic.
Mic unmute करा लागेल. Please unmute your mic.
Hello. Hello.
Yeah, okay.
Yes, sir.
Can you hear me?
Now. Yes, sir. You are audible, sir.
Okay. We are at the end of the session. That is the valedictory function. The chairman of this valedictory function, Principal Dr. Alka Bise. The ICAP Director, Dr. Suchita Khudke. The President of this college, Dr. Sau Sulba Khudke. Head Department of Physics, Dr. Wadatkar. Convener of this conference, Mr. Dr. Prashant Kharat. Co-convener, Dr. Ambore. I think this is a big conference and it was organized very successfully. I will say it is a grand success because, as mentioned by one of your organizers, that nearly 400 and plus participants have participated in this conference. So many students have delivered their oral presentation as well as they have presented their work in poster form also. So this is a huge number as far as this phase conference is concerned. Within a short span of 2 months, it was organized by the Dr. Prashant Karat and his colleague also. It is very huge. Secondly, if we go for the technical session, then you will see 5 persons, including Professor R.A. Shinde, who is very top scientist of India. You may not be knowing about his working in India's defense career, and it is a very secret job given to him. Personality is big scientist, eminent scientist. Really, you are lucky for that. Dr. R.S. Shinde, sir, is a very well-known scientist. Similarly, today also there are 4 eminent scientists from the different area. One of my friend, Dr. Mahavir Singh, who delivered on the nanostructure material, particularly the ferrite material, how they are useful. All the technical sessions were really been wonderful and informative to all the researchers who are working in different areas of the material science and nanotechnology. I hope all the participants of this conference must have been benefited by their talk, and they will continue and take their guidance in future also through email or by phone or any mode also. This particularly web conference has a 3 important feature as far as my opinion is concerned. It is timely organized. All the sessions run at 9 o'clock and end at the 6 o'clock. So timely it is running. The time management was very good. There was no delay or no any technical problem also arises. The connectivity of this conference was also very nice. For some cases, there may be a problem, but overall, you will see the technical connectivity of all these session is very nice. Then the speakers invited, they are of high standards. They are highly reputed. They are working in all the field. My colleague, Dr. Shirsat, Mahavir Singh, then Wagule from Amravati, my friend, all they are top in their research area. Similarly, I will also congratulate to all the participants, those who have presented their oral work. I was there from yesterday morning till today. I have attended all the sessions. I have heard all the presentation of the student also. All the students have made their full effort to present the research work, and really they are admirable, and I also congratulate to them also because they have actually participated in the conference and they enjoyed a lot. So once again, I will congratulate Dr. Prashant, Dr. Wadatkar, all the organizers of this college, and lastly, I also say that I am thankful to the organizer for giving me an opportunity to interact, to participate, and to meet the Vidarbha area friends. Thank you very much.
Thank you very much, sir, for your remark. Now I request to Dr. R.S. Shinde, sir, to give his remark. Dr. R.S. Shinde, sir.
Hello.
Sir. You can deliver, sir.
Are you getting my audio?
Yes, sir. You are audible, but your camera is off, I think.
No, camera is off. Hello.
Yes, sir. You are audible.
Okay. See, first of all, good evening to all of you, dear research student, all the NANOMAT 2020 participants, invited speakers, and all my respective colleagues. First of all, I would like to thank Professor Prashant Tharag for inviting me to and deliver a talk in this conference and ask me to do a few words on concluding remarks. It is my great pleasure that all have done very well presentation and a very fruitful discussion. Through this, I think 2 days is not enough. In this web conference, main theme was advanced material science and nanotechnology. I have seen all the presentation, all the topics of material.
Shinde sir. Hello. 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 सर दिसतंय आता माईक पण चालू आहे का कॅमेरा पण चालू आहे आता शिंदे सर हॅलो okay I think there is some technical problem is there so thank you very much sir for your giving your remark now I call to our principal and our organizer Dr. Alka Vise ma'am to give his presidential remark. Alka Vise madam.
Hello. Hello.
Yes madam, you are audible.
Okay. Good evening to all. Dr. N.G. Belsare sir, good evening. Dr. K.M. Jadhav sir and Dr. R.S. Shinde sir. My colleague Dr. Suchita Khodke, Organizing Secretary Dr. Anant Vadatkar, Convener Dr. Prashant Kharat, Faculty Dr. Ajay Ambore, all the delegates and the students, research students who have joined this conference. We are in the final stage of the conference. It is now coming to an end, but it has given us a new beginning. Ours is a very small college and we dare to do an international conference, and that too with a very short notice. 15 days ago, Dr. Kharat and Dr. Vadatkar discussed with me and they put their efforts in organizing this international conference. I myself was a little bit doubtful that whether it will be possible or not, but they have made it, and that's why I congratulate them, their team. As I have came to know from the speakers that it was time-wise, quality-wise, it was well organized. The renowned people joined as speakers. We are fortunate enough that Dr. R.S. Shinde sir, Dr. K.M. Jadhav sir, and Dr. Koenkar, they have given their precious time to us, and the result you have seen that 407 participants have joined the conference and discussed the various aspects of material science and nanotechnology, the novel ideas or the research they have put forth in the conference may inspire other also to come forward and take the research in this field. I think that the conference has achieved its target, or the purpose of the conference is that only on any conference that we want to come together, we want to interact, we want to get our doubts cleared, and we take inspiration from the personalities that we meet. So I feel that a small college like ours first time dared to arrange an international conference. It will be a memorable conference for all of us. I personally thank Dr. N.G. Belsare sir, Dr. K.M. Jadhav sir, and Dr. R.S. Shinde sir and all other speakers who have given their precious time for us. I think the participants who have joined this conference must have been benefited. They might have been satisfied. In this hope, I take your leave. Thank you.
Thank you very much, ma'am. It is my sincere duty to express my thanks towards the organizers, our patron, Mrs. Sulbata Sanjay Kodke, and organizers, Dr. Alka Bise ma'am, Dr. Suchita Kodke ma'am, and all speakers, Dr. K.M. Jadhav sir, Dr. Arish Shinde sir, Dr. M.D. Shirsat sir, Dr. Rampal Sharma sir, Dr. Dongre, Dr. Mahavir Singh sir, Dr. Pankaj Koinkar sir, Dr. Jadhav sir, and Dr. Wagule sir, and lastly, finally, Dr. Prashant Ghosh sir. So I thanks to them all, and I'm very thankful to our institute also, because our principal and IQC coordinator give us full authority to manage this authority to manage this event freely. And I also lastly I also thankful to the participants of this NANOMAT 2020. They are submitting their papers in the conference. Very soon we are going to publish these papers in the journal, and I hope so. Every year we are taking the same conference with the several editions of this NANOMAT. I once again thanks all to participate this event and to make this event success. Thank you all. Our and with the permission of President, I declare the conference is over. Now the conference is over. NANOMAT 2020 session of 2020 is over now. Then our remaining posters will be resumed now for today, and those are still remaining. They will play tomorrow at 10 a.m. onwards, and all participants should submit their feedback form at the earliest. I declare the NANOMAT with the permission of President. I declare NANOMAT 2020 conference is over now. Thank you all.
Thank you, sir.
The link is not shared. Feedback link.
Okay, feedback link will be very soon. You come to your WhatsApp account.
WhatsApp. Okay.
Yes.
Hello all. First of all, I would like to thank organizers for giving me the opportunity to present my work. The title of my presentation is Crystallinity and Rigid Amorphous Phase Studies in Polymer Nanocomposites. The materials that I am using in my work is a PVDF polymer, which is a well-known ferroelectric polymer, and the magnetic nanoparticles I am using in my work, the nanoparticle is Fe3O4. I am preparing my nanocomposite by simple melt mixing technique. The process parameters are temperature is 200 degrees Celsius, rotation per minute is 60, and the time of mixing is 15 minutes. The characterization of Fe3O4 nanoparticles is done using SEM and XRE technique. The SEM image clearly shows that Fe3O4 nanoparticles are uniformly distributed, having a uniform size distribution of 30 to 50 nanometers. The XRD analysis shows that Fe3O4 nanoparticle has a cubic spinel structure. The polymer nanocomposite morphology is studied using SEM technique. The SEM morphology shows that nanoparticles are uniformly distributed in the polymer matrix. It also shows that the nanoparticles are encapsulated by the polymer. The structural characterization indicates that the polymer PVDF crystallizes into alpha phase, and no other extra peaks appear with the addition of Fe3O4 nanoparticles. We have studied the thermal properties using differential scanning calorimetry. The study indicates that the heat of fusion decreases from 11.7 to 10.2 when Fe3O4 nanoparticles are added. This indicates that the percentage crystallinity decreases with the addition of nanofiller, whereas the melting temperature is not affected with the addition of nanopillars. The mechanical properties of the polymer nanocomposites were studied by dynamic mechanical analysis. The figure shows the storage modulus as a function of temperature. The temperature is in the range of -100 to 150 degrees Celsius. From this figure, we clearly see that the storage modulus increases in the entire temperature range with the addition of nanofiller. The modulus study, if we compare for different particle loading, it shows that the storage modulus increases with increasing filler loading. Therefore, we conclude the uniform dispersion of the Fe3O4 nanoparticle in the polymer matrix. The damping is studied with tan delta curve as a function of temperature. This figure shows two peaks. One peak is appearing at -40 degrees Celsius. This is attributed to the glass transition temperature. The second peak at 120 degrees Celsius is attributed to the crystalline relaxation. Earlier, we have said that crystallinity decreases, but here we see that in glass transition temperature, the intensity of peak decreases. This together indicates the presence of rigid amorphous phase, which is shown by a peak or kind of a hump at 0 degrees Celsius. Therefore, this indicates the presence of rigid amorphous phase in nanocomposite, which is attributed to the presence of interfacial interactions between the polymer and the nanofillers. So in conclusion, PVDF-based nanocomposites were prepared by simple melt mixing technique. The uniform dispersion of Fe3O4 nanoparticle is observed in our nanocomposites. XRD study indicated alpha phase crystallization of PVDF. Mechanical properties showed increase in the storage modulus and also the presence of rigid amorphous phase. Thank you.
Good morning to one and all present over here. I am Shamli Tiwari and I am here to present my topic, that is AC electrical conductivity analysis of PVC and PS blend films. As per our needs are concerned, in a whole life, even in a whole day, we came across so many polymer materials, but we know that due to abundance use of these materials, they become dangerous to our environment, and this is really a cause of worry. So I tried to make an attempt that how should I minimize the use of it, but I have found that it is very difficult to minimize the use of such material which came across it at each and every moment of our life. Some way that we can reduce the wastage of this material, which is also one of the solution of our problem. So by mixing two polymers togetherly, we can compact the use of this material and may increases its properties with better result. Here, by these materials, we can use it in various applications. Here in this paper, I have used polyvinyl chloride, that is PVC, polystyrene material, that is PS, and I have used the solvent, that is THF. By using different compositions, I have made a thin film and then found a result. Very firstly, the polyvinyl chloride is of the standard grade supplied by the auto company, and the polystyrene is taken by the Polychem industry, Mumbai. The solutions of different compositions were dissolved separately and subsequently mixed together. Here, for the measurement of the thin film and the thickness of the thin film, I have used LCR meter as well as I have also used a screw gauge to measure the thickness of the film, which is nearly about 0.03 to 0.05 centimeter. I have found that if the value of the frequency increases, then the dielectric constant decreases. With the increase in the temperature, the value of the dielectric constant also increases. If the value of the frequency increases, then AC conductivity also increases. With increase in the temperature, the value of AC conductivity decreases. Here, I have used pure PVC frequency versus AC conductivity graph and pure PVC frequency versus dielectric constant graph. In a similar way, I have drawn various graphs regarding by using PS material, 1:2 ratio of PVC PS material and 2:1 ratio of again PVC PS material. So after that we have found that if the temperature increases, then the dielectric constant increases. With increase in frequency, the value of the dielectric constant decreases. If the temperature increases, AC conductivity decreases. With increase in the frequency, the value of AC conductivity again increases. This AC electrical conductivity and the dielectric constant of PVC PS blend were measured at different temperatures, that is 323 Kelvin, 333 Kelvin, 343 Kelvin and 353 Kelvin, and at the different frequencies from 1 kilohertz to 10 megahertz by using LCR meter. Here I have also found that the amorphous nature is confirmed by using XRD spectrometer. Here I have found the nature of alternating current, alternative conductivity and the dielectric constant using by using frequency and the temperature. Finally, I have concluded that the improvement of the conductivity takes place with the addition of PS to PVC up to 50%. Then PVC and PS blend have good degree of miscibility, while increasing of the temperature, it reduces the miscibility of PVC PS blend throughout the reducing the intermolecular forces. For this, I have used different references from
myself, Dr. Chandrakant Shivaji Ahir, MSG College, Malegaon Camp, Malegaon, Nasik, Maharashtra. So first of all, I want to congratulate all the team, organizer, the Department of Physics, Vinayak Vidyan Mahavidyalaya, Nandgaon, Amravati, to arrange such international webinar on advanced material science and nanotechnology, that is NANOMAT-2020. So in this poster presentation, I have to choose Soldier method for manufacturing or production or synthesis of nanomaterials. So in my work is performed in my college, that is MSG College, Malegaon Camp, Malegaon, Nasik, Maharashtra. So for this synthesis, this indium oxide crystals in the form of nanomaterial was simply synthesized by using Soldier method. For high-speed stirring, precipitate is obtained. That precipitate is calcium, and we characterize the nanomaterials. So in this synthesis, introductory part, we will consider this nanomaterial synthesized by various methods. Large methods are available, but this Soldier method is quite simple work in our common laboratories, any common laboratories, to prepare this indium oxide particles. This indium oxide particle is used for many applications. For example, it is used for gas sensing purpose. For this experiment, we have to show 99% indium third nitrate was dissolved in triple distilled water, make it solution. In this solution, we had diluted ammonia to make a solution near to pH 9, that is basic condition, by addition of ammonia. We simply check it by using pH paper also. So this addition of ammonia make a precipitate, make it jelly precipitate. So we stir the solution 30 to 40 minutes by using Remy. Remy is the company name for this magnetic stirrer with high speed. After stirring, these particles are settled down at the bottom. Decant supernal liquid and wash this settled particle by triple distilled water 2-3 times to remove all the adsorbed materials. Collect the particle in crucible, and this particle is calcined. Calcination is carried out near to 400 degrees centigrade temperature. After calcination, in 1 hour we get a nanomaterial, that is indium oxide particle for powder. So this method is work by simply checking the powder by using different methods, available methods, that is same, TEM, simple UV, spectra. So in this poster we have give the figure for TEM. TEM image for synthesis of this indium oxide particle. So by observing this TEM analysis, we conclude that indium oxide particle has a size nearly 20 to 30 nanometer. So in my conclusion, we have concluded that but simple method, Solgen method is used or work to synthesize this indium oxide as a nanoparticle. So in acknowledgement, I have to thank my college, principal, Department of Chemistry, where we have synthesized such type of nanoparticle, and these particles are characterized by using NC Lab Pune. So I thank to all the organizers of the Vinayak Vidhan Vigyan Mahavidyalaya, Nandgaon, Kandeshwar, Amravati, especially the Department of Physics to arrange such a nice international workshop. Thank you.
Okay. Remaining posters and oral will be streamed live tomorrow 10 a.m. from tomorrow 10 a.m. onwards. So be connect with tomorrow. Thank you.